they had some proof of something to prove the globe or heliocentric model, and we asked when we asked them to present it, they said, "Oh well, it was part of my grade 9 science project, and I don't have it with me." Like, okay.
Yeah, I guess hopefully he goes and digs it up, and we'll we'll get his presentation tomorrow or shortly.
And now the globe presentation.
You have any questions, Echo Dome or Fallen?
Yeah, maybe it's not related, but I was wondering which voice chat do I join if I want to like debate people and stuff?
This would be the main chat for debate or conversation.
This one that I'm in?
Yeah.
All right. Well, damn, there's a lot of people in here. So
I guess you're a globe proponent.
Yes.
Yeah.
So if I walk up to you on the street and I say, "What's your best globe proof?" without pointing at the sky or NASA?
Without pointing at the sky. What do you mean without pointing at the sky?
Like when you're
saying that's a round object, so I must be standing on a round object.
Yeah, like when you buy a car, you look at the car and inspect the car. You don't look up at the sky and you don't look at the clouds or point up. You look at the thing that you're trying to verify.
Well, I do have something that you might find interesting and convincing that is related to the sky. So, the question I would pose is if we go to the North Pole and we take a look up at the stars and we take a time lapse, the stars seem to rotate clockwise. And when we go to the South Pole and look up at the stars, they seem to rotate counterclockwise, which just happens to fall in line with a round Earth model. But on a flat Earth model, I tried to think of how that would work, but I couldn't think of a way.
Yeah, clockwise and counterclockwise are not directions. So
what do you mean by that?
Well, like if you're standing on a road and you look at the cars going one way and then you turn around, they're going the other way. So like,
but if you look up the ceiling fan for, sorry, I'll let you go.
I was just saying rotation is a change in direction. It doesn't matter if your perspective is stationary and things are rotating around you or vice versa.
Yeah, but when you change your direction by turning your back, their cars are doing the exact same thing. It's just you went counterclockwise, but the stars are always going east to west.
Oh, I think I see what you're saying. So here's the thing. I think it's important to sort of visualize this using like real life objects. So let's say I'm in my room and I have a ceiling fan, which I actually do. It just happens to be the case. And I look up at that ceiling fan. No matter where I look at it from, it's always going to rotate clockwise. The only way for it not to appear to rotate clockwise is if I were to be able to get above the fan and look down at it. And that's exactly what happens with a globe that's spinning. If you're on the North Pole and it's rotating, you would see a clockwise rotation. Whereas on the South Pole, you would see a counterclockwise rotation. I don't see how you could replicate that if you're standing on a flat plane looking up towards something that's rotating, unless you've got something I haven't thought of.
Fallen, I got something better than that with the star trails. When you're at the equator, the star trails are divergent, meaning you'll see circular paths that go to the left, circular paths that go to the right, and right on the equator, you'll see circular paths that go straight over on you. That's impossible on a flat Earth model. It's also mathematically impossible. It violates all geometry. So how would you explain that?
And you've seen it, and you have your own video of this?
Oh, you can go out and get it, won't you?
I actually do have a family member who recorded the stars in the North Pole, and he did indeed make a time lapse, and it does indeed go clockwise.
Yeah, stars always go east to west, and then if you turn around and they're going the anti-clockwise or counterclockwise, they're still going east to west. You changed your direction.
But wait, the direction of clockwise is always the same no matter what, because like I said with the ceiling fan example, if you have a ceiling fan on your ceiling, there's no direction you can look at it from or any position that will make it appear to go counterclockwise. It'll always be clockwise unless you look at it from above, which you'd have to like climb up to the top of your ceiling and all. But I think you get what I'm saying. Any position in which you are below the ceiling fan, no matter what orientation you're in, it will always move clockwise. That is impossible to change.
Yeah, wherever you are on the flat Earth, the stars rotate east to west.
But specifically, clockwise is what we're talking about here. We're talking about at the North Pole, which on the flat Earth model would be standing in the very center. So imagine looking up, you see it going clockwise. And then if the South Pole is all the edges of the Earth, and then you look towards that center, you should still be seeing everything go clockwise, but rather you see a center point in which everything's going counterclockwise.
Yeah, the stars rotate east to west. You just changed your vantage point.
Yeah, but that doesn't.
Where is this
resolve the
video
issue
of the stars rotating counterclockwise at the South Pole? Is there a link to this video?
You want videos of like the different star rotations?
You said that at the South Pole, stars rotate counterclockwise. I would like to see.
Yeah. Let me just look up some things real quick. Let's see.
What kind of evidence would you accept on the divergent star trails at the equator?
Well, I know you've never seen it, and I know you don't have the video.
You don't know that. You know I don't have a video, but how do you know I've never seen it?
Because the stars rotate east to west, so
you're
saying that all those are photoshopped or something?
Yeah, if you type in how to Photoshop star trails, there's 20 videos that'll pop up of how to edit star trails with star stacks, multiple programs.
Oh, easy. I know the equatorial.
So if I presented a video to you in which the stars are rotating clockwise and counterclockwise, what would be the threshold required for that evidence to be accepted?
Did you post it? Direction. The stars always rotate east to west. If you turn your back to another way and it's clockwise and counterclockwise, the stars are still rotating east to west.
All right. Frame of reference aside, okay?
Yeah, I'm asking you, like, if you have a ceiling fan in your room, to look up and tell me, how can you get that ceiling fan to rotate counterclockwise from your point of view? Like, just imagine, like, any way possible. If you could, like, record a video of yourself doing that and showing me how on video it's going counterclockwise, that'll solve the problem. I don't think you could do it.
If you change to yourself hanging upside down above the fan and it did go counterclockwise, the fan is still going in the same direction. You changed your vantage point.
It is going in the same direction, but
Yeah.
you're above it now. In the same way that when you go to the South Pole, you are now, if we're considering north to be up and south to be down, just for the sake of this, you are now above the stars looking down. The direction has inverted. When you flip a 3D cube, 4 sides of it invert, and 2 sides remain the same.
So like I said, stars always rotate east to west. You can change and go counterclockwise. They're still rotating east to west.
How do I send this? Let me see. Sorry, I'm a bit new to Discord.
So yeah, but this is all meaningless anyways, and hearsay and my fake video against whatever. So like,
Wait. So I want to know,
without
like, if
pointing
I
at the
sent this,
sky and without NASA, you have no other globe proof.
oh, I have tons, but this is all I need because it's very simple, and I have yet to see how you could possibly, from your point of view, make the ceiling fan appear to be rotating counterclockwise,
So
other than flipping and putting it below you.
how well do you know the globe model?
I know it pretty decently.
Okay, out of 1 to 10, 10 being the highest, how well do you know the globe model?
I'd say about a 6. 10 being extremely advanced, understanding like everything down to the most geothermal subtleties. I mean, I wouldn't consider myself a high-level expert, but I'd say I know more than enough to know that there is undoubtable proof.
Yeah, I got a 1-minute quiz. It's 10 questions, quick fire. Give me your answer in 2 seconds. They're easy questions, easy globe questions.
Hold on, I'm trying to find where I send this.
Yeah.
Oh, I think it's right here.
Yeah, we don't have image permissions.
Oh,
well, what about a video, like a YouTube link to the thing?
You know the circumference of the globe Earth?
Just DM
no.
me the pictures. I can upload them.
So you don't know the.
That depends on what you mean by circumference. Are you talking about at the equator, or are you talking about from north to south pole?
What is the circumference when you type it into Google? The mainstream answer.
It's about 40,075 kilometers.
Okay, yeah, that's pretty close. It's either 24,000 miles, 24.9.
Yeah. If you're going to do miles.
So do you want to take? So like, you want to do the quick fire 1-minute quiz, or is it the other guy?
Oh, it's the other guy. I don't mind. Are you DMing it or what?
No, I have my list and I have my questions. Like I said, they're easy globe questions that you should know off by heart. Like, if you're defending this globe model, you should know these basic numbers.
So the video got sent to VC check-in voice text.
Yeah, or whatever. You don't even have to do the quiz. You can show me where you measured curvature.
How do you measure curvature?
There is no curvature to measure.
That didn't make sense. Say that again. There is no curvature. It's a measure.
There is no
proof of curvature. We don't see it. It's not there.
You do realize the Earth is extremely large.
The 8 inches per mile squared, which is what the globe model proposes, is not there when we go to find it.
Yeah, but you're using the wrong calculation if you're doing that.
I have a question. Have you ever?
Okay. Correct.
Have you ever taken a laser, flashed it over 8 miles, and made sure to keep it very parallel to gravity using precise equipment, and then measure the drop over distance?
Parallel to gravity, no, but we have used them to go across large bodies of water to prove that they do not bend, and the water does not bend.
Does not bend. The light doesn't bend.
That's
the light
right.
Stays straight, but the
water does not bend. The 8 inches per mile squared bend curve of the Earth that you claim is there is not there. Over 20 miles.
Can you send me this test? I'd like to see it.
Is that how you guys are determining the drop below the horizon? I got an image posted there.
Fallen.
What's up?
This observation of the stars at the South Pole kind of proves that we're not on all these random trajectories and paths of orbits and rotating. Kind of proves there's only one motion happening, one circular motion above us. That's what this proves.
Okay. Well,
okay, so how come if there are stagnant stars above us, like Polaris, which are not being pulled into orbits, which is supposed to be stagnant in one place in the sky, like most constellations, why are we watching them rotate?
Because we're rotating.
No, we're rotating, orbiting we're like on many different trajectories. Why is there only one?
Why are you saying many different trajectories?
Are you saying like on a globe model there's many different trajectories?
I'm saying on a heliocentric model, we should not be watching stars spin in just one circular motion.
This is at the North and South Pole. Meaning so if you get a ball and you rotate it,
the Earth is on an axis spinning around the sun, and we're moving through a galaxy, and the stars are supposed to be moving. Why are we not witnessing that in this time?
Yeah, so stars are incredibly far, number one. So that tiny amount of rotation around our sun is insignificant. However, our rotation of vision does show the stars turning around.
Only one is. I just don't believe that. Sorry.
Wait. Only one of what is observable?
This video kind of proves that we're not in a heliocentric model, in my opinion.
Are you sure about that? So I want you to.
I'm not even arguing this. Honestly, I just don't even feel the need to. If you really want to,
okay, well, I'm just keeping it simple.
This video proves that stars move in more than one direction. That's crazy to me. Like, you're in denial.
So I'm just going to keep it simple. Take a ball and put a needle in it, and imagine that needle is you. Rotate that ball on an axis.
I don't need to do that because this time-lapse video just proves that stars move in one direction, not like 1,000 like they say in astronomy. This video proves that the stars are not moving in all these crazy directions.
Well, I don't understand what you're talking about crazy directions. He's just talking about from a frame of reference. You're going to get stars rotating in one direction.
Because now you want to dismiss all these crazy trajectories that they say we're on. Now you're acting like we're not able to perceive them.
I'm not even.
He's talking about the spin, right?
Bro.
You guys, can you hear me? Can you guys hear me?
Yes.
I don't know why he dropped off. He just dropped off. But what he was saying is that we got a rotation of the Earth, right? That's one direction, and we're going around the sun, orbiting the sun. That's another direction. Then the sun is going in 500,000 miles per hour in another direction, right? We're being pulled along with it. So that's three vectors right there, and then you got the fourth vector, at least with the, whirling of the solar system, right? So
why are you taking a frame of reference like that? That's ridiculous.
Well, no, it's not ridiculous. What his question was, it's not ridiculous to ask a question. I mean, we're here to figure this out, right?
Yeah, I get it, but you're taking.
But do you understand? I just want to know if you understand the point that if you want to use vector math to get it all down to one smooth vector to make it seem like we wouldn't feel that, that's one argument. But his point is, when you take a time elapse of the stars, you can see that they're uniform and that the stars in relation to the Earth are only moving, if it's flat, of course, or if it's a stationary plane, they're moving in one direction. There's not. If we were on a ball, his point is that you wouldn't get that because you're moving in all these different directions. Vector math's not going to help you there.
So here's the point. The stars are incredibly far away. Your movement is not what's going to matter, but your change in direction will matter, because no matter how fast or slow you're moving, a change in direction, well, yeah, but I mean, a globe model can change direction. You believe that, right?
Well, no, of course, yeah, but the infinite stars is an answer you can give for, lack of parallax, but you can't give that answer as far as the time of the time elapse photography showing just one motion, apparently, of the stars. If we were going in all these different directions, regardless of the vector math, you wouldn't see that.
So I'm just going to come back to the original question, which is, how is it that on a flat Earth model, when standing at the North Pole, you do indeed see the clockwise rotation of stars, which works on both the flat and globe Earth model. But what doesn't work on both is the counterclockwise rotation you see at the South Pole.
Well, that's something I have an answer for. I have an answer for that. But hold up. I just want to make sure you understood his point about the different directions and how it wouldn't be working actually with the globe that's going in all these different directions. The vector math doesn't help you. Do you understand that at least?
I don't, because
no, it doesn't make sense.
Yeah, it doesn't make sense.
If we're rotating, right? If you got your camera in one spot on Earth, right? That's one stationary spot on Earth, and you're filming that time elapse, right? Then you got to take into account the fact that it's the idea that it's rotating on its axis, that it's orbiting in another direction, and that the sun's pulling it in another direction. That's three. Just those three vectors. Let's just work with that. How is it that you're getting the
difference is those other two movements aren't changing the direction.
Doesn't matter how far away they are. Huh?
The difference is those other two movements are not significantly changing the direction. They're just moving us. Like, so for example, imagine you're sitting in your car and the car is moving forward and back. You're not changing direction. But when the car turns or flips, if you get into an accident, then you're changing direction. The only thing that's going to affect your perception of the stars is when your direction changes, not how much distance you cross or move. That's just going to get you closer or further to certain things. You have to imagine it with a set of lines. So let's take the sun, for example. If I drive towards the sun incredibly fast, even at 100 miles an hour in my Corvette, I'm not going to see a change in that sun's position because the sun is so far away, at least on the globe Earth model. And stars are exponentially further away in our model. It's actually so incredibly vast, it's unexplainable just how far away they actually are. So a change in movement would be impossible to perceive unless you have really precise equipment, which we actually do, that can record these small changes. But with your bare eyes, the only thing you'll actually notice is change of direction, which is what the rotation of the Earth does. That's why the movement of the Earth around the sun doesn't matter.
How can you have change in movement without that movement having a direction?
How can you have change in movement without that movement having a direction?
Yeah, so there's no direction
when the Earth is rotating and we're changing direction, it's not the slight movement that matters. It's the fact that the Earth changed position. If it was the case that so imagine you have a basketball in your hand right now and you have your finger at a fixed point and you're rolling that basketball around your finger, your position has not changed, yet your direction can be changing. Did you get what I said there, or?
I get what you're saying there, but that's not equivalent to what the question is about all the different vectors that the globe.
Well, what I'm saying is that you'll still get that change in direction.
It sounds to me that where is your reference frame defined? Because you keep saying direction, and you're like, here's the Earth, and here's the solar system, and here's the galaxy, and is that what you're going on about?
Yeah, I've gone over it a couple times now.
No, I get it. I get it fully, but why?
No, it doesn't sound like you get it.
Dude, I've got more mathematical experience than you ever will.
Well, great. You'd be perfect person to help out with this. Okay, so
yes.
if we're rotating on the axis, right, and we're talking over a time-elapsed photography period, right? So you're going to take a time-elapsed photography over a 12-hour period, let's say. Within that 12-hour period, you got to account for the spin of the Earth, right? The rotation on the axis, and then it's going to be moving in another direction, movement in another direction, which is the orbit around the sun, and then the sun is pulling it in another direction.
And you do realize that is negligible.
These are all different directions that are happening over a 12-hour period. And his point was that you wouldn't get the consistency or the appearance of one star rotation, no matter how far away they are, no matter how all the relative.
Actually, you would.
Concepts you want to throw into this.
But hold on now, you're choosing frame of reference. That's not even.
That's what the globe would be doing. That's what any person on a fixed position on the globe would be. Your frame of reference would be changing all the time.
Relative to what?
Relative to the stars that are supposedly infinitely far away.
Most of the stars you can see are actually in our galaxy. Unless you got like Andromeda, you can see
Okay,
it's a little
but
blurry.
that doesn't
But
address the point. That
no,
what we
but
see,
you're
can you
taking a
agree to
frame
this?
of reference
What
and
we
you keep
see with
changing
the
it.
time elapse, what we see with the time elapse photography is the appearance of the stars moving in one uniform motion in relation to each other and in relation to us.
Well,
Yes
I
or no?
posted an image for you. It was taken around Kenya at the equator, and you can see the divergent star trails. Those are impossible on a flat Earth model, and don't go with all this
Divergent star
changing
trails.
references.
Why would
Listen,
divergent star trails? Actually, that's actually good proof, and it gets to
no, it's
my
not.
next thing.
It
No, it does. When you could just say no, it's not before I even continue finishing my point, but that doesn't make you right.
Okay, I'm
Okay, so
sorry.
what I'm
I
talking about,
talked over you.
the divergent star trails. In fact, we see converging and diverging star trails right at the celestial equator, which could indicate that we have two sets of stars that are funneling in on each other. And yes,
No,
one
no, no,
actually
no,
goes in
no.
clockwise
That
motion,
doesn't
and the
make
other one.
sense.
No, don't interrupt me. Don't interrupt me. Don't interrupt me. One goes in clockwise motion and one goes in counterclockwise motion. On a globe, you have to believe that that's not actually happening. They're all going the same direction. It just depends on if you're upside down compared to right side up on the globe, right?
You'll have
But the
to
idea
offer
of having
proof of
two
the
sets,
converging patterns.
the idea is that we have two sets of stars that are adjacent to us in the sky, and they are over our stationary plane, which is everything we experience. And that actually works. And I have something to link for you as well as
Yeah,
other
link it
references
because
that
that
talk about
doesn't.
this idea. It works just like thermodynamics, where they funnel in, and that would also account for the diverging and converging star trails that you can also find on stellarium, which
I don't believe
has
you're
no reason
converging
to have
trails. Show me
diverging
those.
effect. The stars being the divert. You just said you had a picture of diverging star
I
trails.
posted in here. That's divergent trails. There are no
Okay,
converging trails.
divergent. Well, what divergent trails? There are none. What'd you say?
You were saying there's both divergent and convergent trails. What I'm telling you is you're going to have to show me evidence for the convergent trails because there are none.
Oh, well, you're going to say there are none before you even see the evidence? How would you know?
Because I know the globe, man. Come on, post some evidence.
But
Post
obviously,
the
if the
evidence.
globe, so if the globe, why would the globe have diverging star trails? Let's deal with that first.
Dude, you're
Okay, at the equator, do you understand how the rotation would produce divergent star trails on a globe model?
Why?
Why? Because
does the
when you're
rotation-
at the top of the globe or the bottom, they're circular. As you approach the equator, they begin to take on a divergent path because of that.
Okay, from which way? I mean, if depending on how you look at it,
Well, I posted an
depending on
image.
which side,
Go up
depending on
to
which side of the celestial equator you're on, you can see them as converging or diverging. That's they do both.
What do you mean
Look
by
on stellarium.
converging? I don't see any converging ever.
Okay, I'll post some pictures for you right now.
Please
But
do.
why would they diverge and not converge? That makes no sense. Why would there? Why
Do you
would there not be
understand
the original
geometry, right?
Well, maybe you
It
can explain it
makes
to me
sense, Zach.
in
Like
the
what you're
globe model
proposing.
how they would only
Yeah.
diverge.
You don't gotta hold on. Don't waste your breath with this guy. You're proposing with this globe model that the Earth is wobbling, spinning on an axis,
Right.
rotating around the sun. Also, that rotation around the sun is like oblongated or whatever they say. And then we're like at the event horizon of a supermassive black hole in our galaxy. And then all these other stars are expanding as superclusters, like all the things that they claim, all these different movements and motions. And we don't see none of that in these time lapse videos.
Yeah, because the motion that you're speaking of is negligent.
You were gone. I don't know if
I
you
just
heard,
want to jump
but
in
I was
real
going
quick
over
and
that
say
same exact
that
point.
we actually
Over
can
and
see
over.
those
I'm sorry,
movements.
what's your excuse?
Yeah, so I wanted to just jump in and say we actually can observe all those movements.
You don't. It's in a circle. You see one motion, motherfucker. I'm sorry.
Yeah.
No, I'm talking about like in relation to all the different movements in proportion to what we have. We actually can observe those, but those are comparably minor. So what you need is precise equipment. And indeed, when you get a 6-point tensor, you can actually measure these things. And I've seen some on-the-ground experiments.
His point that I picked up on when he left, I don't know if you heard Electric, but I was going on about your point to them, so they could at least admit that that doesn't seem right, that there's only one motion apparently of these stars And if it was us moving instead of them, it would seem there'd be just one motion to account for,
Well,
rather
here's the
than the
problem.
rotation, dragging along. And it wouldn't take much. You say it's minor, it would just take a smidge of a movement. If you bump that camera, your whole time elapse is fucked up. If you just nudge the camera, your time elapse can show a whole fucked up little glitch in it. So any
Yeah,
movement,
like, good analogy to help you understand
in all
why.
these different directions,
Being shown.
you're going to see,
I've got a good
see all kinds
analogy.
of reasons.
To
It wouldn't
believe
work.
the model that they propose after watching that, you would have to be a fucking jackass. I'm sorry.
Yeah, or just indoctrinated.
So
to the
I've
point
got
where
a
you
good
can't
analogy to help you understand. It has to do with the
No,
distance of
dude,
objects.
you need to understand.
So
I understand everything just fine.
Okay,
You're
wait,
not
don't
making me
interrupt me,
shit
bro.
today.
Hey, I let you guys have a turn, man.
Hey, they're
I let you
burying
have a
themselves.
turn, man. What the fuck?
Don't cut them off. Let them continue. They're burying themselves anyway. Go ahead, Fallen.
All right, so the analogy I wanted to give is, imagine you're standing on a beach and there is a boat that's like 20 miles away, even 1 mile away. It doesn't matter. Once it like reaches a certain distance, it will start to have this effect. Now imagine you have your camera and you're looking at this boat and you start strafing to the right. You know what strafing is, right?
Sure.
Right. So you start strafing to the left and right. Now, what are the chances that this boat ends up out of the camera lens?
Good chance.
Yo, you ignored everything I said to jump to this new fucking example. You're changing the
No,
subject.
because no, this is related. You'll see. This
Let
is
him bury
related.
himself with it because it
This is
doesn't work.
related.
Go ahead. We'll entertain
So
it. Go ahead.
anyway, let's say your camera is aiming towards something far away, a boat, an island, whatever it is. If
so
you
it's far away.
strafe left and right,
You're probably not going to have it go out of frame. Is what your point is. Okay. So.
yeah,
Okay.
especially if you have a wide enough sight of it. And the reason why is because the further away it gets, the more insignificant its size is in comparison to your view. And the same thing occurs with stars. However, if you were to stand there and rotate yourself, even if your movement is comparably small, it has an infinitely larger effect. And that's the point that I'm making with the Earth rotation. All these movements of the Earth are irrelevant, but the rotation, the direction change is what's actually going to get you to notice the difference in the stars. That's the analogy I wanted to give.
There's three of them. We're just working with the orbit, the rotation, and the pulling of the sun pulling it in another direction. Those are
Yeah,
three
yeah.
Here's the thing about the other two direction changes, though.
you're not accounting for. You can
realize the Earth moves less than half a degree in its orbit around the sun.
I'm not saying that. You can talk about all those little things that do appear to be the case, but that doesn't answer the question. He's talking about the stars are making uniform circles in relation to each other, in relation to us. And that's all. It appears, and if it was the stars moving and we were on a stationary Earth, just like it seems 24/7, that would be just the stars moving.
But wait, I just described how if something is far away enough, movement in and of itself becomes less and less significant, whereas change in direction keeps its significance completely. If you turn 90 degrees to the left, it doesn't matter how far away the boat is. It'll always end up out of frame. But if you step left and right, it's going to depend how far away the boat is.
Change in direction does matter. You admitted that, and we're also changing direction when we go around the sun.
All right, now I can address the other stuff. So the Earth.
You didn't address anything. You didn't even answer the first part. Go ahead.
I'm getting to that. So yes, there are other ways that the Earth will change direction. So for example, we will get one additional rotation as it makes its way around the sun. The thing is that takes a whole year. And in fact, that's actually accounted for. Every year we have a leap year. And if you were to count the rotations in the stars, occasionally they'd actually happen 365.2 times. So it actually can be accounted for.
All right, come on, guys, come on. Let's put a cork in this. Let's put a cork in this for just a second. Like, Fallen, so do you know of any time in the past of when anyone's directly measured the axial rotation of the Earth that you speak of?
To that. Don't let him finish.
The axial rotation of the Earth itself, or of things outside the Earth?
Just a minute. Let me get back to the Earth real quick. Orion, real quick. I want to just finish the last point with him and retort, because he was talking about that over a year we go around the sun. Do you know how fast it is that we're supposedly speeding around the sun? What's the speed? Just give me the speed. You know
It's very, very fast. It's thousands of kilometers an hour.
Yeah, what is it?
66,000.
We travel around 66,000 miles per hour.
Do you think it's a little strange, Fallen, that we know that, but you don't know that?
What?
You said you didn't give a specific number, but regardless, the speed of it is ridiculous,
I
right?
gave a specific number.
It doesn't matter about the specific number. The idea that you're going to try to reduce that by saying it's only 1 year for a full orbit, that doesn't make it any slower. And you're going in a different direction than the orbit. And you're talking about.
Hold on. We're talking about things that are extremely large. You do realize that.
Yeah, we're talking about things that are extremely large. Okay, guys, back to the question. Sorry, I don't mean to interrupt. Back to the fucking question, please. Fallen, do you know of any time in the past when anyone's ever made a direct measurement of the axial rotation of the Earth that you speak of?
I believe the ancient Greeks actually did it.
Okay, what is the method?
So what they essentially did is they used shadows. And the way this works is they actually first used it to calculate the distance of the sun.
Hold on, buddy, hold on. I said rotation of the Earth.
Yeah, I'm telling you how we're going to get to that. The Greeks were quite smart, actually. But anyway, the first thing they did is they measured the distance of the sun by measuring the respective difference in angle between shadows. Once they got that, they did something a little more complicated. They measured over the course of a day by using artificial light in the form of flames at the time, what the difference in change of the shadows was from a very great height as the Earth rotated with two respective points over the course of about, I don't know what it was, a week. You could actually look it up in detail. And they essentially...
Okay, so you're talking about some guys a long time ago that were staring in the sky and they got some ideas while they were staring in the sky. That's not what I asked you for.
That's just the first time it happened.
Yeah, well, no, that's what you just said. That's what you just said, was that. That's not what I asked you for. So what I asked you for was, do you know of any time that anyone's made a direct measurement, directly measured and directly detected?
We do it all the time today. We do it all the time today.
How?
I know you're not going to like the answer, but one of the big answers is satellites.
You already know? You can read minds now, huh?
No, we just know that you guys reject anything that's space-related.
No, all right, fine. How can I prove to myself right now that the ground beneath me is spinning? How can I prove to myself?
If you purchase a 6-point force tensor, you can measure the change because the fact that the Earth has a curvature means that there's an accelerative difference in the curve over the change of time.
You're kind of ahead of yourself. Right, so maybe I should not ask you for that. Maybe I should just ask you, do you know of any time in the past that anyone's made a direct measurement of the curvature of the Earth? Let's just start there.
I already explained that the ancient Greeks did it by measuring the difference in distance of shadows from one point to another.
But do you understand that those are two different questions, Fallen? I'm asking about two different things. The curvature of the Earth.
Explained. Open your ears and listen. I'm not trying to be rude, but I literally just explained it to you. So imagine you have two very tall wooden posts, right?
No, not imagine. No, not imagine. Tell me how anyone else did it already. Someone must have already done it, right? Someone must have already measured the curvature of the Earth. Tell us how somebody did it already directly to find the radius value.
You could do that test specifically right now. What are you talking about?
That's not a test. That'd be a measurement.
What?
So, how did anyone come up with the radius value? Do you know what the radius value is of the globe Earth you were taught in school? Do you remember that, Fallen?
Yes, you could get the radius value. You take two wooden posts and you have to spread them out very far because, the distances are quite vast. You measure the difference in length of the shadows and you compare the ratio in difference between those two shadows, and that will give you the curvature.
Okay, so why would that give me the curvature?
Because
shadows. You're just measuring shadows. You're not measuring the curvature of the Earth. You're just measuring shadows.
Yeah, but the shadows are going to be a different length, and there's a reason why. If we have a light source from a distance...
The reason why? Oh, you got a story to go along with it too, huh? So you're going to tell me that the sun is 93 million miles away?
Are you honestly interested or not? Because you just keep cutting me off as I'm trying to explain.
It's not a measurement, dude. So here, let me just
looking at you like you're jumping nonstop.
Let me tell you what my standard of evidence is. Can you hear me, man? So let me tell you where my standard of evidence is so that you don't have to waste any more of your breath presenting things to me that won't fit my standard of evidence, because I got a reasonable standard of evidence, but it's a high standard of evidence. So
Okay.
I'm looking for a direct measurement of an arc segment of the curvature of the Earth. Do you understand what I mean when I ask for that?
That's exactly what this test will give you. You will measure the
No,
Earth
that's not.
from one point
I don't
to
know how
another.
new you are to this discussion, but you know that works on a flat Earth as well as a globe Earth, right? The sticks and
No, it
shadows.
doesn't.
Well,
It
it's
doesn't.
admitted to on your side, so you should just look into it.
Yeah. Even I think Neil deGrasse Tyson. No, Dr. Michio Kaku, one of the two of them
I
even
don't
said that
care what
himself.
Neil deGrasse Tyson or any of them say. They're not my butt buddies. I'm just going to tell you right now. I don't accept any of that.
Okay, so you
It's not
think
about what
sticks
you
and
accept.
shadows
It's
prove
about-
the Earth
it's
to be a
about what your
ball. You
side
think that
is actually
sticks and
accepting.
shadows. But let's make sure we get them on the record here. Fallen, you believe that sticks and shadows, the Eratosthenes methodology, you believe that proves the Earth to be a ball? Really?
Yes, absolutely.
Okay. Well,
Yeah, put me on record. I don't care.
all right, whatever then, man.
Don't you think that's pretty
Sticks and
sad? You're still
shadows.
going back to the
But
sticks
here's
and
the
shadows
thing.
like
I'll
that.
tell you
You don't
why.
think
I
we
already
have
know what the report
we have
is.
better evidence by now? You don't think that if we were actually if it was a curvature to the Earth, that we would have
You
very
don't need
clear evidence
anything
of
more
that?
sophisticated than that. I'm using something simple
Well,
that
that's-
you could try
maybe
at
you
home.
don't.
It's
Yeah,
gonna
this
be a
is
lot of fun.
Stone Age technology.
Maybe
This is
you don't
cutting
need it
edge
because
Stone Age technology.
your simple
Everybody's
acceptance of the
talking over each
simple-
other. I can't hear anyone. What's
Okay, maybe you don't need it, but some other people are.
So you're telling me that let's say we created a small version of this model. You got a parallel light source, meaning a beam of light that creates light in straight streams. You got yourself a ball, and you tested this with needles on a ball, for example, and you measured the differences in those shadows, and then you weren't able to replicate this on a flat surface. That wouldn't be indicative to you?
You can replicate it on a flat surface that's actually is admitted to by many people on your side. It's not
Have
at
you
all
tested it
definitive.
yourself?
Prove it. Show us that it has been. Because right now you're demanding evidence from us, but you're not showing anything to us.
Yeah, of course.
Hey, Hey, I'll tell you right now, I'll do the experiment
making
like
claims.
You guys
I'm
are
not
new to
making
this
any claims.
conversation. Those are 2015 arguments.
So wait, what if I myself actually got a flat surface and a round surface, a parallel light source, which I can access if I have studio lighting, which I do, and I put needles in both, measure the shadows, and demonstrate that the difference in shadow is not different on the flat surface, but it is on the round surface? Would you then be willing to accept this idea?
Yeah. So Fallen, are you watching the live stream voice text? Is that something you are following?
A live stream voice text?
Yeah. So
you mean
above?
Like
above this live voice call, there is a chat going on.
Yeah. I see it. Okay. I see some pictures and stuff.
So when you look at the post from Donato, for instance, it's 50 minutes across the hour. You scroll a little bit up.
The post is invisible for some reason.
I see it. It's the one where you got, and it looks like a part of the sphere on the left side, and you got a flat
50 minutes
model on the
across
right.
the hour.
Yeah. Is it the GIF or the still image?
I believe it's
So
a
I'm
still
going to tag
image
you
because
again.
it looks like
so
what you're talking
Donato
about.
posted it again. Listen, Donato posted it again. It's now 54 minutes. Okay.
That's what I was talking about.
Yeah, this has already been done. So, and admitted by globe earthers that it would work on a flat Earth. You are not the first.
Yeah. So this is being done falsely.
It's been done what? Sorry.
The test is faulty. That's not how you do it.
Faulty. So again, right? This is being admitted by globe earthers that it would work on a flat surface with a local.
I don't subscribe to those.
Hold on. That's funny. Our test is faulty, but their test is correct to prove it's a globe. Okay.
I'm not. So
just by looking at this image, I could already tell by the difference in length and shadow that this is not a straight uniform light source.
No, and it's probably done from a spotlight.
Are you sure it's not your favorite color? Is that maybe the problem with it?
again,
Dude,
right?
are you engaging in the conversation honestly or not? So
Yes,
if you think about
yes, it
the
is.
center point that a light source is emanating
Yeah.
from, if it's coming out in different directions, of course the shadow is going to come out differently. You need a straight light source. There's only two ways to achieve that. One, you need to use a very bright light from a very, very far distance,
Yeah.
similar to what the sun is, or you need to use a laser.
Relax, Linda. Take a breath. Calm down. Stop spiraling.
Don't worry. The vacuum
did you hear
space
what I
isn't going to
said?
take up all the air around you.
Yeah, we do, right? We do, because you are not the first one coming in.
Yeah,
with
so
this
I just saw
argument.
this image of the sun shooting down light in different directions. That's not the case, because the sun is like 93 million miles away.
You don't
So
have,
the light that's
It's
hitting
like 93 million miles away, man. Don't you know?
Yeah, so that is begging the question.
Sorry, what was that?
Right? Yeah, that is begging the question. You will never prove that the light rays are coming in parallel.
Actually, you can. Absolutely, easily.
You can't, really.
If the light ray wasn't coming in parallel, then as you go higher and higher into the air, your shadow would get larger, but it doesn't. It stays the same size. You notice how the shadows of clouds are the same size when they hit the ground as they are when you look up at them?
Did you ever notice that clouds are always hovering above a flat and stationary Earth?
No.
You ever notice that?
Again, right? You are begging the question that the sun is 93 million miles away, shooting parallel sun rays.
But wait, so the only way for the flat Earth model to work is if the sun is really close to us, right?
Local, yeah, local.
Because if the sun was 93 million miles away, the Earth would not be flat, is essentially what you're saying.
Oh, hold on, buddy. There's no flat Earth model. So if you think there's a flat Earth model, there isn't one.
No, looking at the sun doesn't.
Then what do you think the Earth is?
Not a model. And I don't believe the Earth is a spinning ball in the vacuum of space. I'm just saying we don't have a model because models have inherent problems with them. So models are claims. So
I don't think
we
that
could,
falls in the definition of
what I'm trying to say is we're just not trying to get ahead of ourselves making claims. You know, like these globers who got ahead of themselves making claims with no evidence to back up these claims.
I'm not big on globe Earth, flat Earth, or anything like that. I'm just some dude who's asking simple questions, and I still have yet to get an answer to the ceiling fan problem.
I think you need to just flip the switch or plug it in. Maybe try unplug it and plug it back in again.
So that's going to be a not honest answer to the question. I'm looking at all these images, and all of them just have huge issues. The ones that are animated, like that's not how the sun works. It would have to be incredibly close to have that much of a difference in light direction. Even my little brother can tell just by looking at this, just sitting here. This is
Tell us how the sun works. You seem to know, right? How does the sun work? Tell us.
Yeah. So, have you ever flown a drone before? Those little drones that have 4 blades around. Have you ever flown it really high and looked at its shadow?
No, dude. Where are you going with this?
So if you fly the drone really high, no matter how high you fly it, the shadow stays the same size. I've actually done this before. I could get a ruler. It's still 12 inches across. And that's only possible with a light source that's 93 million miles away. If the light source is close, then the shadow will get larger.
Really?
Yeah. Get your phone light, put your hand close to the light, then put your hand far from the light.
That's your proof that the sun is 93 million miles away? Really?
Wait,
okay, let me ask you this again.
Just get your phone light right now. You got a wall. Test the difference in the size of your shadow as your hand gets closer and further to the light. I'll do it right now. Let's see.
Yeah, I'm not arguing with you that shadows do different things different times. I'm just saying that's not evidence that the sun is 93 million miles away. That's what I'm saying. That's not evidence of that. Because it's not. You have to go directly there and come back here and bring a measuring tape with you.
Fallen, let me clear this up for you, Fallen, real quick.
What you have to do
Okay,
if
go
you
ahead.
want to know if something's 93 million miles long is you have to measure for 93 million miles directly. Thank you.
Yeah,
No, you
otherwise
don't.
it's just
You can
speculation.
measure
It's just
exactly how
words.
far a light is from you by measuring the difference in your shadow. So here's an experiment we could do.
No, I
And
wasn't
please
asking.
listen. Please.
I just need you to
So
understand the
wait. This is
information.
important. Please listen.
Oh,
Okay.
it wasn't a
So let's say
question.
you
Go
have
ahead
a
and
light
see if you can
and you do
absorb the
measure the distance
information
to it.
first, and then we can talk later. Thank you.
Okay, so let's say you do the measuring thing. You actually measure 93 million miles. We could do the same thing. Let's say we measure, before even turning on the flashlight, we measure that it is 30 feet away beforehand, right? And what we then do is we sit the light down. We know it's 30 feet away. We turn the light on and compare different shadows on the wall. If you use this shadow expansion and contraction method, you can indeed calculate it. And what the answer is that you will come to, if you're doing the math right, is 30 feet. So if you can use shadows alone, and you know for a fact it does calculate distance, why wouldn't you do that?
Because you don't know how large is the luminary. You don't know how large the sun is.
It doesn't matter how large the light is itself. It doesn't make a difference.
It does matter.
Unless
you
the light
saying it
is a
doesn't
laser,
matter doesn't
which
make
is...
it not matter. It matters.
Then
And how
okay,
does it
why not
matter?
just test
Prove
it then? You could get a large flashlight and a small
No,
one.
what I'm
and
saying,
measure
dude,
the
hold on. What I'm saying is what you're saying is just a bunch of words that don't demonstrate anything. That's what I'm saying. Like, these are just words. They don't actually prove anything to be anything. They're just words.
These are experiments you could do right now. Wait.
Just so you understand, Fallen. The sun, moon, and stars, and wandering stars, which we now call planets, all of those things in the sky, they all fall into the category of unverified lights in the sky until you have direct evidence to the contrary. They are unverified lights in the sky.
So basically,
that's
what
all
you're
they are
saying
to
is
you.
they
That's
may
all they are
have
to
other
us.
properties that we don't know about that can affect the results. Is that what you're saying?
What was the question again? Start over.
So basically what you're saying is that these objects in the sky have unverified properties that would affect the results of this test.
Yes.
What are those properties?
Okay.
Unverified? What do you mean, what are they? That's unverified. Are you deaf?
You just said unverified. You didn't say non-existent.
Yeah, unverified as in unverified. It's a light in the sky and it's unverified. I don't know exactly what the properties are. I'm not going to make any claims and get ahead of myself. I'm not a religious leader like Neil deGrasse Tyson.
Bro, why are you guys so obsessed with Neil deGrasse Tyson?
Well, him or anybody else, whatever the fuck asshole out there that's pushing this globe nonsense.
Well, anyways, whatever unverified properties you think these have, how is it that they're going to affect the results such that all these things just happen to fall in line?
Unverified properties, I think they have. They are unverified lights in the sky. It's not I think they have anything. They are unverified lights in the sky.
Okay, fine. Let's just assume they have unverified properties. Even regardless, even if I grant that, how does that change the fact that when you do the measurements, it just happens to be the case that they all come out to demonstrate exactly equal properties to what the round Earth model says?
What measurements? What are you talking about?
Like, for example, that people say the sun is 93 million.
Are you going to talk about taking around with shadows and lights again?
I'm talking about everything. So just as an example,
mile squared, go prove it to us.
Yeah.
So,
let's get back to the curvature. So, Fallen, I asked you a little while ago for a direct measurement of curvature, and you gave us Eratosthenes. And at that point in time in the conversation, I was just like,
I send you some images.
This is ridiculous. Are you kidding me? Like, so come on, you got something other than Eratosthenes
So
to give me an answer to that question, Fallen?
At home, would you like? Wait, what?
Yeah. So lasers. What do lasers do, Fallen? Let's talk about lasers.
They shoot photons in a perfect direction.
Yeah.
Photons follow the path of the geodesic. Come on.
Yeah. So when we shoot a laser over a large lake, right, 24 miles from point A to B, and the laser at point A hits the target at point B, 24 miles. showing no curvature, straight
You did the
line.
test wrong. I've seen the test done before properly. You have to make sure that you
Okay.
get it exactly right.
Yeah. So
Even the whole geodesic curve thing will not have enough of an effect
right.
for
So
the light to not be on the right path. And
okay.
actually,
Follow.
I saw a small flat Earth documentary in which this
1 second.
test was done,
Yeah.
and they found a
Yeah.
curvature.
Yeah, Fallen. That wasn't. So you don't know what you're talking about. That was from the mockumentary Behind the Curve. They didn't use a laser, so that's a great talking
What did
point,
they
right?
use?
It's funny how he's referring to flat earthers proving the Earth to be a ball. Why would it take flat earthers to do that?
No, well,
Because you're interested in the truth, right?
yeah, Fallen.
Yeah,
So
yeah.
many. Well, 1 second. Many laser tests have been done, right? 10 miles, 50 miles, 24 miles, 30 miles, all showing no curvature. None. Militaries use lasers
Can you
to
show me
point.
one of these tests that's been done
Sure.
where you matched it to be parallel to gravity?
Yeah. What?
Has it been peer reviewed? Has
Parallel
it
to gravity.
actually?
Oh, okay. So I've posted you a document, Fallen.
I clicked on it.
Yeah. So measurement 7. Scroll all the way down. It's on a Dutch lake, 24 miles.
Hey, Fallen, when you say parallel to gravity, do you mean parallel to plumb line?
Plumb line?
Yes.
I'm not familiar with that term.
Okay. Plumb just means...
So lasers, right? The militaries use lasers to.
Oh, are you talking about parallel to the water's surface level?
I was just trying to confirm what you mean by parallel to gravity. Did you mean plumb?
So when I say parallel to gravity, I mean like if you got a ball, a half circle, and you mounted the laser on top of it, the ball will be perpendicular to the laser itself because it's following down to the Earth line. That's basically all it is.
Okay. Plumb is basically an old construction technique where you take a heavy ball on a string and you measure it because it's a 90 degrees from where.
Oh, yeah, that's very similar. Yeah, something like that, basically.
Okay, just clearing that up.
But anyway, so measurement procedure. Once the beam was directly on target, we took the measurement readings. We used optical visualization with cameras and measurement board. Geode undulation, lake elation. This is not loading. I don't know if I have shit in it or what.
I think so.
Bro, look how bad 5G is. This is so like. Oh, there it goes. So it looks like they actually did find a curvature.
No, they didn't.
In the thing that you sent me.
They didn't. So have you ever any notion how much curvature there should be over 24 miles?
Over 24, it should be like 32 inches or something.
No, 100 meters.
64.
100 meters, bro.
24 kilometers?
24 miles. That's approximately 40 kilometers.
Okay, that's good. I thought you said 24 kilometers, but anyway, laser location, measurement 6.
7.
On the 22nd of April, blue laser pointer. So these are 7 separate experiments, or
yeah.
Where'd you post it?
I've already posted it. It's let me see, 6 minutes across the hour. Posted again. And you can go to the laser. Laser channel. We have a laser channel. Posted it at 10 minutes across the hour. If you click that, you can see many more laser tests done over flat bodies of water. all kinds of distances, used lasers, colors of lasers.
Even
All showing
frozen
no
bodies of water. Sorry, go ahead.
Yeah, frozen water. Yeah, I've got one. 1 second. So this is one done over a frozen lake. He put. I posted it 11 minutes across the hour. You can look up the video. He had some traffic cones with lights on it, and he drove away. So he put those cones at different distances with different lights on it. He drove his truck away, and then he zoomed in on these lights. So we have the world distance Guinness Book of Record Guinness Book of Record longest distance photograph. This was done in France. It's posted at 12 minutes across the hour. Post you the original picture.
How high are they up in that picture?
With picture.
The one that says 273 miles away.
Oh, I can post you. So this is the they are. It's all in the picture, right? So let me.
Yeah, but they're not showing altitude, and at least not what I'm seeing yet.
Yeah, 1 second. Viewer height in feet, 9,251.969.
When you say altitude, I think you mean elevation.
Yeah.
Altitude
They're both they're the same thing. They're synonymous.
No,
altitude
they're
represents
not.
elevation
Altitude is the
above sea
distance
level.
above the surface.
Sea level.
No, they're not the same thing. Altitude is the distance above the surface of wherever you are. Elevation is the distance above sea level.
As a baseline, ground zero would be.
Okay, you're right. My bad.
The beauty of it is that you can do this yourself, guys. You can go to a large lake, do this yourself.
There's so many things that you have to consider, though. Like, what's the atmospheric pressures and differences? You got to calculate your refraction with it. I mean, there's a lot more variables than just.
Yeah, tell me about it. Tell me about it. What variables are you thinking about? Tell me about it.
I just told you.
Globe,
Yeah.
Earth, night.
So what? You said a word, but tell me.
Your atmospheric pressure, your density.
Right.
Yeah.
And what would that do? What would that do?
You know that it actually distorts the light, makes it bend differently because.
And.
Okay, well, it's no different than a ham radio. Are you gonna let me talk, or are you gonna interrupt?
My bad.
Okay. We know ham radio operators from here in America can speak to people in Japan, which is supposedly, well, it's not on the other side of the earth, but it's close. It's beyond the horizon for sure.
Yeah, what's flat Earth?
What?
Welcome to Flat Earth.
No, it doesn't happen all the time. It only happens when the atmospheric conditions are good enough to where they refract the radio beam back down. There are times when you can't speak to Japan.
Wait, so now we're going to radio waves? I thought we were talking about light.
No. What do you think a radio wave is? It's all electromagnetic radiation. It's all different forms of light.
We were talking about optics. We were talking about light.
Oh my God. I was trying to explain.
You were saying, oh, you can't trust this picture because of blah, 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 blah.
Atmospheric conditions do affect light waves.
Yeah.
Do you at least admit that?
Sure.
Okay. Now, there are times when we can see really far out, and there's times when we can't due to atmospheric refraction.
Okay, Valerian.
No, not due to atmospheric refraction. Not due to that. Due to other things, but not that.
Okay, what are the other things?
Okay, this team from Brazil, they went to Lake Titicaca. They choose this time of the year with low humidity, and they can see 110 kilometers. Where is the curvature on that lake? Like, prove it. And this was they contract engineers and surveyors. So your curvature doesn't exist. Water is level. Okay? This was 2011.
Yeah, that's actually a good thing to bring up that lake, because when I was doing a lot of research on my own independently about this, when I was still thinking oh, come on, it's got to be a ball. It's got to be a ball. There's got to be some curvature detected somewhere. I was looking at Lake Titicaca. It's got a really strange name, but it's a high altitude lake. It's about 7,000 feet elevation, and it's in South America, and it's a very unusual lake because it's 10 miles across, but there's very little wind there. There's almost no wind in that desert that it exists in, so there's almost no waves on it throughout the entire lake. So it's a freshwater lake, and there's just very low humidity and almost no wind and no waves. So basically what I'm saying is there should be curvature to be observed on this lake easily. It being 10 miles across, there should be a hump of water at the center, 60 feet tall, because over 10 miles there's 60 feet of curvature on the globe Earth. But to the best of my knowledge, you can see from one side to the other, even when you're right there on the beach, right next to the water. You can see from one side all the way to the other. There's no 60-foot wall of water blocking you from being able to see to the other side.
Now, can you see all the way down to the water's edge?
Yes, there's no, to the best of my knowledge, there's no curvature to be detected on Lake Titicaca at all, to the best of my knowledge. If you have any evidence to the contrary, show it to me, please.
I've got my PDF that I wrote when I watched the. Hold on. Let me. Y'all go ahead real quick. I'm going to get this up.
See, that's just it, though. With the low humidity in that desert, that naturally high altitude lake, that natural occurring lake with the natural low humidity throughout the year, it would make it so easy to see, the curvature, the bulge of water that there would be from one shoreline to another. It'd be so easy to observe that.
Hey, how come I can't
but
send
it's
images?
Not been observed. Or measured, better yet.
You can't send
Metabug took down the article.
You can't send images because that is for trusted members who have earned that.
No, that's fine. That's fine.
You can direct message us anything you want us to post. We might.
Yeah, that's what I've been doing.
So
I was looking for the, and I forgot the name of the show, but they had Stephen Hawking commenting. He was never there in the experiment.
Yeah, I know that one.
You know that one, good.
Yeah, with the helicopter, right?
Yes, the helicopter.
Yeah. Awesome. Did you know that they faked that?
Prove it.
Prove it.
Awesome. Yes. If you're going to make a claim that they faked it, you need to prove it.
Let me.
Because I watched the same video in the helicopter.
I'm gonna Helicopter. Fake. Because you can see
Helicopter.
you can see the birds, right? There are flying a bunch of birds through the screen.
I ain't worried about birds.
Yeah.
I was talking about the telescope and looking across the water, and the helicopter
No,
does
you were
dip
talking
below.
about evidence of it being fake. That's what you were talking about. You're talking about evidence of being fake. So apparently, this piece of evidence involves birds.
Oh, listen, Roger was saying it was fake. I'm letting him prove it. I ain't going against him.
Yeah, let me pull it up, bro. Let me pull it up. Where was it? Yeah, I got it. So, I hope you can watch this. So, I'm trying to find the correct one. Marking. Where was it? Oh, yeah, this one would be it. No. So they're looking at the. Oh, yeah, I've got it. PBS Genius. Okay. Awesome stuff. So I just posted it. Look at the. So there are 3 birds flying across the screen when they show that helicopter moving down, and then when it's moving up, the same 3 birds are flying across the screen again. So they copy pasted the same frame and played it backwards. Why would they do that? They even, if I'm not mistaken, they even pulled that particular episode. So now you have to wonder, why would PBS do that, right? Why would they fake that? And we also have another one from Nat Geo where they had this boat with the stripes and the telescope, and they showed the bottom stripe disappearing. And then they said, well, that's because of curvature. And we see the boat on the water, and then we see the horizon behind the boat. Now they claim the horizon is the thing that is blocking boats and buildings, right? But when they show that boat with the blue and red stripes, we can obviously see the horizon being beyond the boat. So it's not the horizon blocking the stripes. So it's not curvature.
Can I ask him a very important question related to the topic?
Go ahead.
Is the horizon physical? Is the horizon physical Earth curvature?
The horizon is just a description of the Earth's curvature.
So yes or
Somebody
no?
asked.
Yes or no? Is the horizon physical Earth curvature?
What do you define physical? What do you mean? Is the horizon like some physical object or something?
No, he's saying, is the horizon real, as in caused by the curvature?
No. Is the horizon physical? Like you can go and touch it, grab it, or is it apparent?
It's apparent.
Exactly. So the horizon moves depending on the conditions in the atmo, which means it's not physical Earth curvature, which means it's not blocking boats and buildings.
Yeah, but see, here's the problem I have with the way we're arguing curvature is you're not taking atmospheric. As a matter of fact, you rejected all atmospheric. So between that, it's hard to do the debate here, because if you're not accepting that atmospherics affect light through refraction, and that it does cause a difference. Hold on, Roger.
I know. We know the argument, and then
you know it, but it's still reality.
No. Then we ask. So one step back. I've showed you the PBS footage, right?
Yes.
Do you concede that was faked?
Yeah, I can see the 3 birds.
Okay, awesome stuff. So that would be for you to think about, why would they do that? Why would they fake that shit? Then the next step about the refraction, right? We know the argument. Do you know, because you are claiming you are invoking refraction, what kind of refraction are you invoking?
What do you mean, what kind of refraction?
So there are different types of refraction, right? You have looming, steeping, towering, sinking. I forget one. Somebody will fill me. So there are different types of refraction causing all kinds of phenomena in relation to the horizon, right? There is no description or test or citation that will tell you something is going on with the horizon. It's all in relation to the horizon. Miraging was the last one, right? So you have all these kinds of types of refraction, all defined. And
wait, are they though? Hold on. I mean, refraction, to the best of my knowledge, involves two media, not one medium. Yes. So refraction has nothing to do with what we're talking about.
The atmosphere has different pressures and densities all over the place. It causes refraction.
Is that one medium? Is that one medium, or
you don't understand what's causing refraction? Then, if that's what you're arguing,
that was a closed-ended question. Are we talking about one medium, or are we talking about two media?
We're talking about difference in pressures in the atmosphere that causes the refraction.
Oh my God, what the fuck? Really?
Yeah, really. You want to say that it's two different
we're talking about one medium, not two media. So there is no refraction here because refraction requires two media, like solid and gas, or solid and liquid, or liquid and gas. Two media, not just gas. We're just talking about air here. Light moving through the air. There is no refraction involved with light moving through the air.
I gotta go because I've got some food cooking, but I wanted to just repose the question I have before I go because I still haven't gotten an answer to it. How literally on Earth can you have a model other than a globe Earth or something that's three-dimensional that would allow for the fan to spin in the clockwise direction above and the counterclockwise direction and the South Pole? I still haven't had an answer to that.
I don't understand that question at all, man. Like, all I can say is it seems like you're confused about something.
Counterclockwise. I just want to know how. How on a flat Earth model can you get the stars to rotate counterclockwise? I'm actually trying to think of like some arguments for you, but I can't think of any.
You're asking me how the stars do what they do? I just told you they're unverified lights in the sky. Why would you be asking me a silly question like that?
How can they rotate counterclockwise specifically?
Yeah, I know. You just asked me that. Do you understand how I just pointed out to you how that's a silly question to ask me? I just told you the stars are unverified lights in the sky. They do this, they do that. They might do all sorts of different shit. That's got nothing to do with the ground. I don't know what they're doing. I don't have any explanation for that. Would you like me to tell you a bedtime story? Should I write you a fairy tale for that? Like, I'm not your fucking father, dude.
So in other words, what you're basically saying is that you can't answer the question, and instead of
what he's saying is
I have no evidence. I have no evidence as far as any claims about it.
Okay, I have no evidence. We don't know what the stars are or what they do.
And you don't have any evidence either.
Anything does or anything. Like, I mean, why don't we just appeal to solipsism and just say
that doesn't make any sense? That doesn't make any sense. You're equivocating things that you shouldn't equivocate.
So wait, if I put unspecified, unverified objects above you in a dark room, and then I made you turn, rotated you, like I physically grabbed you and rotated you clockwise.
No if. Done with if. And we're if.
What do you mean done? What do you mean no if?
Like you go on a million of these, like if we do this or if we do that. No. We're looking for evidence here. We're looking for direct measurements of the curvature of the Earth.
You need to do
which you don't have, which you have presented none of.
All right, so you need to do a test to have evidence. So I gave you an example. When you're in a room, I rotate you counterclockwise and clockwise, and you have unspecified objects above you. And you notice a pattern in these objects, which is that they always, when I rotate you, rotate in that direction. Regardless of what the objects are capable of, when you notice that pattern, it is indicative of something, no?
No, it might be indicative of something, but it's irrelevant. It's completely and totally irrelevant. So what's your point?
It's completely and totally irrelevant.
Yep.
Like there's nothing you could get out of it. Not a thing.
What the hell am I supposed to get out of it?
Well, if you see a pattern and you notice it in relation to a phenomena like rotation, then you know that there is a relation between that rotation and the phenomena that's taking place.
I'm trying to follow you, dude. You're talking like a mad word salad there or something. I don't know.
I kept it very simple. I think actually anybody in this chat could have understood it.
So back to the proof, though. We're looking for direct evidence for this heliocentric model. All right, not what if this or what if that. No more what if. No more what if. No. So
and the only way that you cannot have a heliocentric model is if you could prove how on the flat Earth model that the stars rotate counterclockwise. I need to see how.
Model?
Otherwise,
have you been presented with a model?
I'm calling my own model a model. What's the problem?
Oh yeah, no. You said the words flat Earth model. We haven't presented to you any model.
They don't have a model, really.
Okay, then I'll just use non-globe model. How about that? Like any non-globe model.
Does that work? That doesn't even make sense.
Non-globe model, because you're saying that the Earth is not a globe, right?
Why did you just say... Why are you saying model even to begin with at that point? Like, just forget about models, dude. They're inherently flawed. They're just reification.
Okay, well, you said heliocentric model, like what?
I know. Well, what I'm saying is models don't necessarily reflect reality. What I'm saying is they might make a model about one thing, but that model doesn't necessarily reflect reality. Someone could make a model of the Earth, and it could reflect reality.
Model is usually just a simplified version. The thing in
models don't always reflect reality, is what I'm saying.
Have you watched Stars Through a Glass Dome? Watch it.
Yeah.
Hold up, I didn't catch that. What was that?
Miguel is posting videos. Miguel is posting videos
in
the live stream.
It.
Fallen. So
I have a quick question for Fallen.
Yeah.
Okay. Hey, Fallen. Hey, can you have a Ferrari without a model of a Ferrari?
Supposedly.
No. Let me try again. Can the car Ferrari exist without the model of the Ferrari?
That's a yes or no, because
it's a yes or no question. Yeah. You don't have to think too hard about it, and if you can't grasp that, then maybe learn a few things.
Here's the deal.
Which means yes.
You can have a Ferrari without the company modeling the Ferrari. However, that's a very dangerous business tactic. What they do is they literally model it so that they can see what the car will look like before they invest hundreds of thousands.
Are you saying like the model emblem of Ferrari or like a model version of the car?
Listen one more time. So like you have a little toy model, right? Like you guys like the little globe Earths that you find in classrooms. I'm talking about the same kind of thing, a little toy model of a Ferrari. If I don't have one of those, can I not have a full functioning life-size Ferrari, the real thing? Can I have a real Ferrari without the toy?
Yeah.
Yep. So why would I have to have a model of the flat Earth when it already exists?
Because you might not be able to purchase an actual Ferrari, but if you could get a working-sized model that can replicate all its features, but for a lot cheaper, then you could use that.
No. You cannot make a miniature Ferrari.
Question. What the hell is
that? Are you fucking kidding me? Wow.
What? Dude, you're a pussy. But anyway,
I'm a pussy.
Like I said, not a single person here has been able. I just don't even know what you were going on about there. Like, I don't see what the point is.
Fallen, he was just trying to help you understand that you don't necessarily have to have a model of something.
It's troubling that
one thing and reality is another thing, is what he's saying.
Fallen, it's troubling that he had to explain that to you. Troubling.
Okay,
Truly.
I don't care whether we use model, another word, it doesn't matter. I'm just using whatever it is to describe a similar or smaller, easier to work with version of something. That's all I mean by model.
So using this terminology to our benefit to further the conversation. So you believe that this globe model of the world, you believe this reflects reality, right, Fallen?
Yes.
All right. So there'd be curvature on this globe Earth, this heliocentric model, right? There'd be curvature on the Earth,
yes.
right?
Yes.
So how did anyone ever find this curvature? How did anyone ever measure it? Did anyone ever measure it?
There are lots of different ways we've measured it.
Well, I know, but you don't need to tell me
you
that.
Can actually see it with your bare eyes.
Then why do you ask?
You don't need to tell me that there's lots of different ways. All I need is one good, reliable way that anyone ever did measure it. I don't need lots of ways. I just need one good, reliable way.
Possible way, like the most reliable way.
Yeah, okay, directly.
Hey, Ryan, when I left, you were trying to get this out of him. Actually, my phone died. But the point is, you can get out of the next thing. He's saying that there are ways to do it. So the point is that he believes there are ways. He hasn't done it himself. He hasn't actually measured the curvature. So we can go on to number 2, I think. He believes it's been measured, but you don't have proof of that right now. So go on to number 2.
He was leaving. Fallen, you were leaving, right?
I've got about 2 minutes.
Yeah.
Oh, okay. Well, then what about the spin of Earth? When has that been measured?
That could be measured easily. Actually, you could measure it yourself. Yeah. So if you get a metal ball, a pendulum, if you get a very light piece of cloth, hang it from the ball, you coat that brush in ink, you pull the ball back very gently.
Foucault's pendulum, right?
Yeah, that's what he's talking about.
That's something you believe. That's something you believe measures Earth. It doesn't prove anything. So then number 3, before you leave, how do you have air pressure? How do you have air pressure without a container?
Oh, that's easy.
That's very easy.
Yeah. Can you demonstrate? Can you demonstrate for it? Can you demonstrate that for us?
Yes, I can. Very simple.
Oh yeah, we can. There are large magnets you can use to create the same thing as gravity.
Fallen, 1 second. Let me take over here.
Post something about that. Something that's not like the Earth.
I don't have to post it.
You asked we have air pressure without a container because the Earth isn't
a container. Now listen, please. Okay. Airplanes, helicopters, pretty much anything that flies, even paper airplanes, they all produce pressure differentials. One under the wing, one above it. Or in the case of a helicopter, it'd be a blade. So you've got, depending on, airplanes would normally have high pressure under the wing and lower pressure above it. There is no container. What causes that pressure is a force. So that leads us back to the question. You guys don't believe in gravity, correct?
You forgot this.
Believe in gravity? What is this, church? Believe in gravity?
No, do you?
We got to go back to your example. He really tried to just pass that off and move on to us not believing in gravity.
Straw man bullshit.
Gravity just means weight, okay? It's all it is. It's gravitas. Yeah, that's where it comes from.
Gravity is the force that pulls you downwards towards the ground.
You don't call it a force. It's a pseudo force, and you know it. They call it a pseudo force.
Okay.
It does matter. It matters a lot, actually.
Yeah, because the curvature of space. But hold on.
Yeah. You can't even call it mass attracting mass anymore. You have to call it the curvature of space-time, and that's just a conceptual medium. It doesn't even mean anything.
You're going to try to invalidate.
You're believing in this all. You're relying on this. The gravity, the bending of space-time is keeping our atmosphere in. Is that what you're saying?
I'm saying the apparent force of gravity is real. Do you agree with that?
Explain how the bending of space-time keeps our air pressure in.
All right, I have a question. Do you guys have
theory of temporal uniformity on you?
Explain how the bending of the conceptual medium of space-time keeps our air pressure.
You're moving the goalpost on me. That's what you're doing.
Gravity is the bending of space-time, definitionally on your side. There is no mass in that.
Listen to me. You're applying a selected theory. I did not. I did not say, do you believe Newtonian?
You don't believe in Newtonian gravity?
Stop.
You're a little out of date.
Stop. Okay, you gonna listen? You gonna listen?
Go ahead.
Okay, good. I'm not talking about the theory of gravity that people subscribe to. There's many. You got MOND, you got Newtonian mechanics, you got general relativity. I'm not talking about how gravity works. I'm talking about, do you understand that we call gravity is an apparent force that pulls us to the ground? Do you recognize that?
I know what you think happens.
No,
don't worry about that.
No,
Whether I understand what you think you know is not the point
I'm a
here.
strong man now.
You're asking for air pressure without a container.
I'm talking about simple observable facts.
Of an airplane.
Yeah, the airplane. What about it?
How does that explain how our air pressure is contained?
I gave you an example of air pressure can be contained just by a force alone.
It didn't say it couldn't. Well, it has to be a force. There has to be a container of some sort, right?
No,
that's the only way
it works. What do you think the container does? The sides of the container, the
uniform force.
Apply force to the gases inside.
You're saying there's a uniform force that works as in a spherical way, all at a specific height beyond the moon, keeping our air pressure in. Is that what you're saying? And it's bending of space-time that does that? Because gravity is the bending of space-time, according to your paradigm right now.
How do you know what paradigm? I told you I'm not subscribing to any particular theory.
Which force is it that what force are you talking about then?
Okay, jump up and fall down. That's the force.
Hey, guys, hold on. Can we simplify this a little bit? So if I let go of a rock,
he's a clown.
Yeah. Let's demonstrate that a little further. So if I let go of a rock falls down, hits the ground. Are you claiming that the rock fell down because of gravity?
Because of an apparent force that pulled it down. We call that force gravity.
Force now.
Whatever it is, theoretically, does not matter at this point. We're talking about physical, factual observation. If you something,
okay, just watch that anvil. Why that anvil doesn't sink?
I'm sorry. Say what?
I did post in the live stream. I did post in the live stream. Are you blind?
Talking about Mercury.
Are you blind or what?
Anvil is what I heard.
This anvil, if that gravity exists,
yeah, I see that image you posted. It's because the Mercury is heavier than the Moon.
Oh,
it's about density. Learn it.
I know exactly why density works.
So say bye-bye to your gravity. Where is your force? Where is your force on this observation? Where is your force?
It's simple. I'll see y'all later.
Later, Fawn. It's simple. The Mercury is pushing up on the anvil. The anvil's less dense. What happens when you remove the Mercury?
Don't worry, I'll come back to destroy you.
Are you going to make the claim that the rock fell down because of gravity? Are you going to make that claim?
Of course, the force of gravity pulled it down.
Okay, all right. So now that we've established that, you're making the claim the rock fell down from my hand to the ground because of gravity in the medium of air. So if you're going to make that claim, do you have a scientific experiment to demonstrate that to be the cause?
Yes.
All right, what would that be?
Vacuum chambers.
Where did anyone ever do that? Because you'd have to manipulate gravity. You do realize...
No. I know what you're going on.
The independent variable, which is gravity.
Stop.
So do you know if anyone...
You want to listen, or are you going to talk over me?
I haven't Ryan, real quick, he said vacuum chambers as if that was the experiment that proved it instead of Cavendish, which isn't an experiment either.
Vacuum chambers do prove that density is not the reason why things sink, float, or fall. Do you understand this? Are you going to let me explain it?
It's not about us understanding anything that you believe.
And you can give me an answer.
If you talk and explain it, then I will just go on to something else.
Did you just come here to explain things that you think you already know? Because we understand what we understand what you think you know.
How can density cause motion? Explain that.
Is this microphone kind of breaking up for other people?
Your microphone's really bad, but yeah, we could talk about the acceleration. And you already admit relative density is a thing, right? So the acceleration is a different thing, right?
Why does buoyancy occur?
Because I didn't get a proper answer. We established he made a claim, so I asked a clarifying question, a reasonable clarifying question. So
Yeah,
you're
and I
making the
responded.
claim that the rock fell down in the medium of air because of gravity, due to gravity.
Yes.
So do you know of any scientific experiment where anyone can manipulate an independent variable, and this independent variable in this scenario would be gravity? Do you know of anyone to manipulate gravity and remove it from the situation and allow us to observe the rock floating in the medium of air without gravity, and then put gravity back into the situation and observe the rock falling down to prove that the rock went down because of
But
gravity?
you don't
Do you know
have
of
to
anyone
do that.
conducting a scientific experiment to prove that
You
the
can
rock
use a
fell down
simple
because of
vacuum
gravity?
chamber to disprove that density is what's causing stuff to fall or float.
That's not the cause. That's an observation of an effect. You're
Wait,
pointing out the
I know
effect.
what you're talking
let me
about
ask
with
you,
experiments. You
Valerian,
want to
you're
vary
making-
gravity.
Valerian, in the vacuum chamber, did you change the medium?
In the vacuum chamber, there is no medium. You suck all the
There you
atmosphere
go.
out.
There you go. That's what you changed.
Okay, so
So there's no medium for it to fall through, right?
correct.
So how is that giving us any kind of example of the medium that we
Okay.
live in?
It's simple. You know, let's say, well, balloons are bad examples, but we know a ball will float on water, right?
Do we live in a
Like
vacuum
a
chamber?
basketball. No, quit it.
Yeah, buoyancy is a
it.
thing. Yeah,
Let's have
buoyancy
an
is a
honest
thing.
discussion, because that's what you're
Yeah.
saying. Because
Buoyancy
of
is a thing.
buoyancy,
Yes.
yes. Do you know what causes buoyancy?
Air pressure.
No.
Or no, the density.
How does that cause buoyancy?
Well, if it's a very
Stop. I'm asking a simple question.
Styrofoam has a different density than a rock, which will sink, but the styrofoam floats.
It's a state of equilibrium.
Sure.
It's just another
So-
word for a state of
Stop.
equilibrium.
The medium itself is exerting a force on whatever object it is. So if the object is less dense, the water pushes it up. If the object is more dense, it falls through because the water can't exert enough force on it to make it float. Do you agree?
I understand. Yeah, I understand the explanation that when things are falling through the air, it's not because
It doesn't matter if it's air, liquid,
it's
or
because
whatever.
the other things are moving up around it. Yeah, helium balloon. We've all been through this many times. Are you
Okay.
new to this conversation? Are you new to this conversation, by the way?
Apparently.
Seems like it.
But here's the deal. What happens when you remove the medium that's causing the force? So you're saying density causes everything to fall to the ground that's more dense than the air. That's more dense to the air, right?
What you already agreed that density makes things find their equilibrium. You're already agreeing to that.
We're not talking about that right now.
You're talking about the acceleration, right? You moved on to the acceleration. Is that what you're talking about?
I'm talking about density does not cause motion. The buoyancy force is what causes things to rise or sink in
That's your
relation to the
interpretation of it.
medium it's in. Now, when you go to a
You're
vacuum
interpreting
chamber,
the air like water, right? You're making
it
the air
is. It's
water.
the same thing. Air, water, it's all
Similar.
They're similar. They work off of a lot of the similar principles in mathematics.
Right, and you've reverse engineered it in your mind to think that, okay, that's why density has nothing to do with it? Is that what you're saying?
No, listen. When you're in a vacuum chamber and you release a ball and a feather, they both fall at the same rate, correct?
Right, so you're talking about the acceleration now, right?
Yes. Now,
right. That
there's
could be
nothing-
electrostatic, by the way.
Listen, you can do experiments to prevent electrostatic. Don't go there. You're just muddying.
You can just complete. No, you can just
muddying the waters, dude. You're muddying the water.
You can never eliminate electrostatics from, and even in a vacuum chamber. Look it up. You can't. You can never eliminate electromagnetism ever.
Okay, so you're straw manning or moving the goalpost now, right?
No,
yeah, you're introducing a topic that we ain't even discussed. It has nothing to do with electromagnetics. No, it doesn't.
Electromagnetics, you can never. I'm saying there could be an electromagnetic effect that's going on. You can't eliminate that in a vacuum chamber.
Oh
you
my
can say it's gravity. You can say gravity is the acceleration, but you can't prove that.
That's how much denial you're going to have with this. You're going to move the
Where's your
goalpost.
independent variable? You can't. There's all you have is Cavendish, and that you can't.
No, listen.
You can't do an isolation on gravity, bro. we've been through this with many people many times over. You're new to this conversation. You're not going to get
How
anywhere.
come the feather and the anvil or the hammer or whatever they have, why doesn't it just float inside a vacuum chamber? There's nothing to cause buoyancy. There's nothing to cause it.
Why they don't attract each other?
Say what? I'm sorry, it's hard to hear you. Your mic is
Gravity, mass attracts mass. Why don't in that experiment? Why they don't attract each other?
Okay, hold on.
Gravity's a very weak force. If you're going to study physics and stuff,
Gravity is a fairy tale. Gravity is a fairy tale.
You ask why wouldn't they float in a vacuum chamber?
Yeah, because there would be no force acting upon them. If gravity doesn't work the way...
What, are they still denser than the medium inside?
No, you're confusing stuff because it's buoyancy. The force of buoyancy.
Buoyancy.
No, that's what it is.
Why would they float? Why would they float? Because there's no force acting on them. If you believe that it's density and that the buoyant force is what causes things to float, fall, or whatever, when you remove that buoyant force by removing the medium, then there should be no forces acting upon the hammer or the anvil or the feather. So why do they fall? You are new. Did you remove the density from the hammer?
How does density cause something to fall?
Density from the hammer?
How does density cause something to fall?
The hammer's still dense inside the vacuum chamber, right?
But there's no buoyant force acting on it. There's no medium to make it like the feather. Feathers fall very slow because
it's still denser. It's still, regardless. You can't have a perfect vacuum to begin with, and
it doesn't matter.
It's denser than whatever medium's in there, so it still fell. What are you talking about?
That's ridiculous. That's completely illogical.
Can I say something, guys, really quickly? Can I say something?
Totally backwards. You don't even realize it.
Really? So it fell because of density? I've got dense things all over the place. They're not moving around on their own. A force would have to be required.
Oh wait, are you under the impression that without gravity we'd all float? Is that what you're saying? Everything would just float?
Without gravity? No gravity at all? Probably.
See, that's how dumb you are. You think that heavy things like a rock on the ground would just start floating because no gravity? Like it still doesn't have density?
They'd clump together, wouldn't they?
Ridiculous.
Don't you know that's what happened before they invented
is that your knowledge of physics is so twisted that you don't understand what density is. Density is mass per volume. That has nothing to do with it moving or falling or any of that. It's just how much matter is per volume. It's simple.
And you think matter doesn't exist because the little g goes away? Is that what you're saying? That matter has no weight?
You are doing. Why are you moving the goalposts and doing straw mans?
You're saying things would fall. So you think like a big anvil and a little tiny
feather
would both float, right? No, not a feather because that has. Regardless, doesn't matter what you think. Everything would float. Would they all float at the same height? Would they all float to the same distance? Would their mass? Would the amount of matter not matter any longer?
What do you think would happen if no forces?
Guys, can I say something very quickly? Valerian, we are not making any claims as far as the cause of why the rock fell down. I mean, you and I have been told lots of different claims. I was taught it was gravity. You were taught it was gravity. You believe it's gravity. I
was demonstrating how you can verify that it's gravity. But you guys want to go on and say,
claiming it.
Let me talk. You're claiming that, one, buoyancy and density is what caused stuff to fall and float. But when we remove that, the medium completely, you just act like density causes it to fall.
You're misusing the word cause. You gotta boil it down to the word cause.
Physics, it's simple.
Do you understand that we're not claiming a cause? Do you understand when I say that, Valerian?
And I'm trying to correct your understanding of density, buoyancy, and how you can determine it.
Your example, though, is
So from here on out, I'm not going to hear you say the words. You guys claim this is a cause, or you guys say that's the cause of the rock falling down. I'm not going to hear that from you, right, Valerian?
Orion, I want to make sure you know that he's buried himself already with this. He's saying that we have completely removed the medium. And he's talking about a vacuum chamber, which he also admitted We can't have a perfect vacuum chamber, so we haven't completely removed the medium, whatever that medium in the
How about we put you in a vacuum chamber and see how vacuumous it gets?
regardless, the density hasn't been removed from what thing that's falling. So whatever the density is, it's still heavier than whatever medium's in there, and it still went down. So what have you proved? I don't know why you're using this as an example.
Okay, good. You said it yourself. We removed the medium. Why did the object still go down? So explain
the object still had density. Because the object still had density, bro. You didn't remove the density.
Density is just mass per volume. It doesn't make
it almost seems like a philosophical question. Why did the rock fall down? I mean, if you don't have any evidence for it, it's just philosophical.
No, there's plenty of evidence. I got a rock on my desk. It's not moving by itself. A force has to be applied to it to make it move. So in a vacuum, there's no more force of buoyancy. It's gone. So why does it still fall?
Because the hammer still had density. You didn't remove the density from the hammer.
That's idiotic. What you're saying is completely crazy.
His question is idiotic. No. Forget about his answer. His question to begin with: why did it fall? That's an idiotic question. I mean, okay, why did it fall? How would you suggest we go about proving why did the hammer fall down in the medium of air?
We're not proving the gravity in this situation. What we're doing is, you guys say that it's because of density. I gave you an argument where we remove the buoyant medium around it, regardless.
But not the density, right?
You don't have to remove density.
You don't have to remove density to prove that
density doesn't cause motion. Why do you not understand that?
The density of the hammer is still heavier than the density the density of the medium that's in the vacuum chamber. So it still went down. You proved nothing.
There is hardly any medium in a vacuum chamber.
It doesn't matter. It could be no medium. You can have a perfect vacuum. It's still denser than whatever the air is in there.
Okay.
Whatever's in there.
That doesn't make sense because
nothing. You have to remove the density from the hammer.
On density, the force of buoyancy works on objects with varying densities, whatever they are, and they can cause things to float, like we talked about, like a basketball in the water. The water will push the ball up because the ball has less dense than the water. You guys understand that and you agree with it. However, listen.
You're new to this. You're very new to this.
Why do you claim that density is causing the motion? Because density doesn't apply a force. Just because something is hanging in a vacuum chamber doesn't mean a force is being applied to it.
Let me help you out here, Valerian. When people talk about the vacuum chamber, they're talking about proving the acceleration is a constant, okay? They're not talking about removing the buoyancy, and that's the reason that we can't say density is the cause and all that. You're just totally getting this wrong. You're new to this. Let me help you out. Talk about the acceleration. That's what the vacuum chamber is all about. Your side uses the Cavendish to try to prove gravity, and that doesn't have the independent variable, so you can't prove gravity. You can't.
It does have the variable. We're changing the mass.
Could be something else. We do not know that this gravity force that you're
then I guess we're super lucky because everything matches experiment.
And it's in space-time. There is no mass attracting mass admittedly on your side any longer, so everything is about this conceptual space-time being bent. You guys are fucked on gravity. I'm sorry.
Well, I would say you guys are fucked on density, claiming that's what's causing things to fall down.
The hammer was more dense than whatever was in the vacuum chamber.
That doesn't matter.
I'm not saying it's the cause. I'm saying you can't.
No, stop.
You can't. You haven't removed anything if you don't remove the density from the hammer. I don't know what you're talking about.
That's ridiculous, man.
Hey, wait, new perspective. Can I talk with him for a second? So you just said we made a claim about as far as why things fall down. Valerian, did you just say that we made a claim as far as why rocks fall down in the medium of air?
Density, right?
Yeah. No, nobody claimed that. I did not claim that. Did anyone else here claim that?
I heard News Perspective claiming it.
So Valerian, let me help you with this. That's an observation. So what I'm saying is, Valerian, what we're talking about, it's important to distinguish the difference between an observation of a natural phenomena and a claim. So when I drop the rock in the medium of air and I observe it fall through the air and hit the ground, find its equilibrium on the ground, that's an observation. I am observing the rock falling down.
Sure.
That's not a claim. All right. So that's not a claim. That's just an observation.
In that case, the observation would be a claim. It depends on how
What?
you're using it. Yes. If
No,
you're saying
no.
I observed this to
The
fall.
observation is not a claim. That is retarded horseshit, Valerian. Like, are you really? Are you going to really say that right now? An observation is a claim. Are you really going to fucking say that?
Give me one second.
No, you're not going to fucking say that. An observation is not a claim. That's retarded. Anyway, now I just wanted to point out the difference so you can understand there are observations and there are claims. Be careful not to get them confused.
I'm reading up real quick. You're talking about claim as in a scientific claim then, correct?
A claim.
No, you're talking about a scientific
or otherwise.
claim.
Yeah, you don't need to put the caveat on it. You don't need to put the
Okay, let's move past this, and we'll just call them observations, if that's satisfactory to you.
Well, that's what they are.
Or go on, I'm listening.
Well, yeah, so I observed the rock falling down in the medium of air. I have made no claim as far as the cause of why the rock fell down in the medium of air. And the Earth is still flat and stationary, to the best of my knowledge. Do you have any evidence to the contrary?
I'm sorry, say that again, I was reading. I'm trying to figure out the difference of what you're talking about with observation and claim.
All right, now that you're answering my question, I don't have time to listen.
Well, I would.
Why would you need to look that up? Like, I don't understand why you'd even need to be looking that up. An observation is an observation. A claim is a claim. I mean, isn't English your first language?
No, I get it. I get it now. Go ahead.
Well, so yeah, we observed the horizon being more than 10 miles away at 1 foot observer height. This observation falsifies the radius of the globe Earth that we were taught in school of 3,959 miles. On a globe Earth of that sort, on a ball with that radius, the horizon must be no further than 1.22 miles away at 1 foot observer height. But it's more than 10 miles away. So why would that be, Valerian?
There's a lot of different variables besides just straight curvature calculations. Come on, let's move past this. We know that that's a argument that's not ever going to get settled. It's pointless.
Well, if you want to be
I was talking about the apparent force that pulls us down to the ground.
And which force is that? Can you tell us what that
Well, yeah, it's a curious thing, but it's not a claim that has been validated, or it's not something that has been validated to be one claim or the other to be true. It's just an unverified.
We're not
claim.
talking
It's
about
an unverified thing. That's what it is.
We're not talking
like
about any theories of gravity, which would try to define the cause. We're talking about just the apparent force that pulls us to the ground.
Well, yeah, it's an apparent thing.
It's an observation, right? I'm not claiming some mathematical model that describes why that happens. I'm just saying I observe whenever something gets thrown in the air, it always falls back to the ground. Do you agree with that?
Yes, that is self-evident, except with the helium balloon.
Roger, don't worry about it, but we're talking about the apparent. Now, you said a helium balloon. Now, why would a helium balloon float?
Because it's less dense than the medium it's in.
But that doesn't explain why it floats. What would cause it to move up in the air? There has to be a force applied to it to make motion.
Yeah, now you're asking me a philosophical question, Valerian.
No, we're talking about simple English language. Force is defined.
No, you are, though, because you're asking me a question. You're asking me, you're basically asking me, why does the rock fall down, right?
Yep.
I'm asking you, why does the helium balloon float? You said density.
Well, I mean, I'm not saying there isn't any way to demonstrate what the cause is.
But we know there has to be a force,
I don't know of any demonstration so far.
All I said is that for a balloon to move.
Because alien is more dense than the air. The density of the air.
But what you're ignoring is that there has to be a force applied to it to make it do
dense.
that.
Sorry, less dense. Okay.
How am I ignoring what? Who's ignoring what?
Okay, you guys correctly know that density will cause things to float, sink, or whatever.
No, wait, hold on. Valerian, you're using the word cause there incorrectly again. No. Don't misuse the word cause there. Be very clear. We're not claiming anything to be the cause of when the rock fell down.
I understand.
We were taught plenty of claims. We were taught, the claim of gravity. Yeah, we all grew up with
I'm
that.
not going about that. I'm using simple language to describe stuff.
Observe.
You observe. Okay, that's going to be the preferred choice of words. That's fine. I will adhere to that or try. If I say cause, just know that I meant observe unless it's something else. It gets tricky talking to you guys because you're not versed very well in the language of physics, so it's complicated for me to try to relay simple causes.
Oh, listen to this guy, man. He's got a real wow.
Oh, really? So what causes? Oh, wait.
What causes water to stick to spinning balls?
Stop. I messed up again. We observed that helium balloons float, correct?
Yes, we observe helium balloons going up.
Yep.
In the medium of air.
Float up. Now, we also observe that in order for an object to move, a force must be applied to it. Do you agree with that?
Can you focus
No.
on more?
Why not?
Because you could just change the medium around it. That'll move it.
But what's the force moving it?
There isn't one.
Density.
Okay, now hold on.
You took it out of its state of equilibrium. Hold on. You took it out of its state of equilibrium and it went and sought its equilibrium. That's it. I'm not going to stop just because you want to keep train wrecking with some bullshit here.
Yeah, Valerian.
Train wrecking this.
And Valerian, I really need to ask you an important question, Valerian. This is the most important question that's ever been asked in this entire live stream's history.
Okay.
Do you know of any time in the past of when anyone has ever made a direct measurement of the curvature of the Earth and the method of how they did that to find the radius value? How did anyone find that radius value, Valerian?
Give me 1 second.
Oh, good luck on that. Take all the time you need, partner. Take all the time you need.
There's lots of different sources. I'm trying to find one that you guys would accept.
Well, you should be focused more on the methodology more than the source. Do you know what I mean by that?
Yes, I do, because I can post you a PDF, but I don't think you would understand. It's all in math.
That's not direct physical measurement.
You might not get it.
Sorry.
Yeah, it's like
you need to listen. Here's what it is. You need to have personally taken a direct measurement of drop over distance and arc segment of the Earth's curvature, and not give us math. It needs to be data.
Yeah, I know that. That's what I'm looking for.
No. Yours. Your data from your measurement, or it's invalid. Thank you.
Well, then it'll be invalid because I never measured the curvature of the Earth directly.
You would, because nobody has, because that doesn't exist. So, yeah, you get a pass there.
Wait, who gets
Happy
passed?
4th of July weekend.
Yeah, it's kind of redundant because it's been falsified, the radius. So it's redundant even me asking you that.
Do you guys realize how big the Earth actually is, though?
Yeah, well, I realize how big they said it was.
Apparently you don't.
Did we just misrepresent how big?
No, I realize how
we didn't
big.
think of that, guys, did we?
We're lost.
We just didn't think of that.
I realize how big they said it was. So, I mean, if you're now going to claim that it's too big to measure any curve, then how would you have measured any curve? You kind of just shot yourself there.
Hold on. Mathematically, we can actually determine what the apparent curvature is.
We
I'm
don't
sure
need
you
to
guys
do it.
know the. Okay, we don't need to go there.
No, we
But
could
you
just
see how
directly-
we did a moving the goalpost? We were talking about density.
No, there's no goalpost.
And yeah, there is, because you guys said objects should move without forces interacting with them.
This guy's psychotic, isn't he?
Yeah, so you just change the medium, and then something will seek its equilibrium in the medium. right? Which has been changed.
How does it do that?
Well, can we go back to how big the Earth is, please?
Because I wanted to stay with what we were discussing, because you guys finally hit on the point where you're flawed. And you're saying,
let's go back to the question. Remember that very important question?
Stop.
I do want to ask really quick. I'm so sorry. Who's the guy talking again? I'm so sorry. Who is he?
Valerian Root. His name is
Valerian Root. So he's a calm guy. Cool. Well, you did say that Valerian, that you've never taken a direct measurement of the Earth's curvature, correct?
Can we go back to what we were discussing?
You can't change the subject.
We don't care about your red herring.
You guys changed the subject originally.
Please, hold on.
That's insane. You guys moved away from the density buoyancy argument because you hit on the biggest flaw that you guys have, and you're saying that things can move without forces.
Hey, Valerian. You don't sound very calm. You should take some Valerian Root.
I probably should.
Yeah. So here, the last thing, I just want to let you know that you don't need to talk about density or buoyancy if you don't have a radius. Thank you.
That does not make any sense.
All right, so I'm back.
No,
Hey, Fallen. Hey, Fallen, check this out. Hold on, let me catch Fallen up real quick so he understands where we're at.
Okay, I'll get to that. I will. I promise. But first, I want to restate the question. How is it that on a flat Earth model, you can get clockwise rotation at the North Pole and counterclockwise rotation?
Fallen.
I love this one. This one's really fun. You just need to
we're changing the subject again. We're moving the goalposts.
I can just answer that real quick for him, though, and then
do it, please.
You sound like Professor Dave.
Yeah. So here's what you do. You stand and you face north.
You keep getting more, even though you're full.
You stand and you face north, and you see apparent counterclockwise rotation. Or you stand and you face south and you see apparent clockwise rotation. It doesn't matter where you are on the plane when you do that. That's what happens. But in reality, all that's happening is the stars rotate east to west. So, yeah, that red herring's done. Let's just get back to the curvature.
All right. Guys, hey, Fallen, hold on. Fallen, let me catch you up. But I just want to say to everybody in here that I'm not trying to be mean or an asshole, which I am an asshole, but I'm very passionate about, discussing stuff. Now, let's get back.
Still haven't answered this question. I agree with you, Valerian, but
Fallen, it's okay. But hold on, Fallen. Fallen, I've hit on a major flaw that I would like to discuss.
Hold on, but Larry, you said you're passionate. So how passionate are you about evidence and facts?
Very, but hold on. We just hit on something a long time ago. You guys moved the goalpost to talk about something else, but it's very important that we discuss this. Now, let me get Fallen caught up. Fallen, we were discussing densities, buoyancies, and vacuum chambers. Now, it boiled down to this. What causes things to actually, we observe helium balloons to actually float up. I asked them why that happens. They said because there's a difference in the medium and the densities between the two, which is half correct, but still half wrong. And I asked, well, movement is caused by a force. We observed that.
You see the problem there? You just said you asked us what causes something. I just told you we didn't claim anything.
I get it, but you said that the helium balloon is observed to float up. Now, for anything to move, a force must be applied to it.
Okay, what force?
Stop. You guys disagreed with that. No.
You stopped. Because you just said that the helium balloon essentially has a force being applied to it. So what force?
Buoyancy.
Okay, fine. I'll take that.
Okay? Buoyancy is a force that was applied because the difference in the density. It has nothing to do with anything else at this point in time. Now, earlier, you guys were saying that things could move without forces. And I asked you how.
If you change the medium.
You observe it. You change the medium, you're changing the buoyancy force.
Okay,
yeah, fine. I'll take that. I was trying to bait you into saying a gravity.
Now, here's the thing. I get it. You guys bait a lot, and I understand.
Again and again.
We can
change anything.
Let's get there. Now, if you agree that a force.
Are you?
What? Why did you interrupt me? That
How are
was
you ever going to get there, bro? It's like yada 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 yada, and then we're like, okay, yeah, okay, let's go on. And then you're like, but don't move the goalpost again. Like, dude, just get on.
Hey, Valerian, so you have a balloon and you fill it with half helium and half air. And where is that force of gravity?
Worse.
I was going to say, if we're talking about forces, let's talk about pressure, like actual forces, not unicorn forces and, that stuff, like actual forces. So pressure, requires something to press against something else.
No, pressure requires a force. I explained that to you with the airplane wings.
Told you he was going
to. Well, yeah. And so that's a solid object, the metal airplane wing pressing up against the gas, the air, right? Correct?
Yeah, that is true.
All right. So we have gas pressure here on Earth, right?
Sure. But it varies.
Well, yeah, I'm not denying the gradient. I'm not denying the fact that the air gets thinner as we climb a mountain. I'm not denying that, but that's the gradient. That's not gas pressure. That's the gas pressure gradient. That is delta X. Delta X comes after X.
I know exactly what it is.
Delta requires X. The gradient requires pressure.
We can't tell him. We know.
How do you have pressure?
Look, you guys are moving this shit all over the place. How can anybody have an honest debate? Listen.
Well, yeah. So basically, we're asking you, how can you have gas pressure? How can we have air pressure? How is that possible?
Force. It doesn't matter where it comes from. Forces will change pressure in the air, period, or in the liquids.
Well, how do you
I agree with you that it doesn't matter where it comes from, because that's true. It doesn't matter where it comes from. But nonetheless, the pressure is coming from somewhere.
Yes, now listen to this. In a vacuum chamber, we remove the buoyant force because there is no medium to cause a force to act upon an object.
Incorrect. There is no perfect perfect vacuum. That
does not matter. You're fucking doing.
You stopped him on the side of the road and just had a chat with him, did you?
Yeah. So back to the question: how is it possible that we have air pressure, gas pressure here on the surface of the Earth, 14.7 pounds per square inch at sea level? How is that possible?
Dude, stop talking through him. Like, wait for him to finish and then respond.
You guys are the ones that are...
No, you're responding the whole time Orion's talking to you. You just keep going. Wait until you're done listening to what he has to say and then give a response.
Oh, so I'm not supposed to bring up my own topic.
No, you're just not supposed to talk through people while they're talking to you. You complain about how the conversation is coherent. You're doing it right now. You're doing it right fucking now. So cut it out. Listen.
So yeah, we can talk about other subjects later, but right now the question at hand, question we're all dying to know, is how is it possible that we have gas pressure here on Earth, air pressure, which is gas pressure, 14.7 pounds per square inch at sea level? That's our X value.
Okay,
how is it possible that we have that pressure?
I'll answer that. We have an observed apparent downward force, correct? We talked about this. We observed rocks falling, correct?
Yes, rocks fall down in the medium of air, and
that is caused
I'm talking
by
about gas pressure.
Yeah, because that force applies to the gas.
Oh, can you demonstrate that?
Sure, climb a mountain. You'll notice the air pressure
That's the gradient. Do you understand what I mean by gradient? Do you understand the word gradient?
How the gradient forms, do you?
You don't, because you're going to say gravity, and there's no ball, which gravity is supposed to have made.
Hold on.
So that's not.
Let me demonstrate.
At what altitude does pressure become zero?
No, yeah, well, at what altitude does the pressure become 10 to the negative 17 torr? Grab us that measurement and be right back with it, please.
Yeah, that's a very good question.
Negative 17 torr?
That's all we got to say.
Yeah,
that's what the claim is.
Do I have to educate a Glober on his outer space claim again? Is that what has to happen here? Yeah, that is the claim. So grab us the measurement, 10 to the negative 17 torr pressure, and come right back and show us that the gradient goes to that.
I wouldn't waste my time if I were you. Just hit.
I'm not going to because that's ridiculous.
Yeah, I know you're not going to because it is
Exactly,
ridiculous. It's a ridiculous
you know
claim.
it's ridiculous.
That's your claim. I do know it's ridiculous.
Welcome to contained Earth. Flat and stationary and contained Earth. Welcome to flat Earth.
We know it's hard to understand. It's hard to live with.
It's not hard to understand.
Sorry, it just happens to be true.
A force is required to make something move.
This is so funny. He just said that you know that it's ridiculous, and what he's talking about is his claim. Yes, I do know that your claim of outer space is ridiculous. That's why I said it like that. Now you know it. Now we all know it. That's
now
great.
we know it.
I think it now too.
You guys just want to fucking shut me down, don't you?
Well, you talk.
If you had some evidence to bring us,
we want you to think for yourself. We want you to think for yourself.
Sit here and go, oh yeah,
I want to empower you, buddy.
I have thought for myself. This is my own thought experiment. Why are you guys doing this?
You want to know something really ridiculous?
Wait. Whoa.
Everybody just believes we're shooting through ever-expanding space.
We didn't come to you, dude.
I came to you guys.
I know.
Right.
Welcome, man.
You came in here telling us you know all about it.
Welcome to flat
You're educated and that we're not. We just don't understand.
Please
So
stop.
now we've shown you why we have evidence to show you that we're not just crazy people. So now that
But
gives
your
you
evidence is
to do like
flawed.
what a real man would do and go out and research what we just told you. That should give you some incentive to say, you know what, maybe I'm wrong. Maybe there's something there that I missed. That's all we're trying to tell you, bro. We're not trying to convince you. We don't care. It's up
really
to you,
hard to
bro.
get
We're
people to
showing
do
you
that.
what we have here.
We don't care.
I know it's hard for
You
you to
came-
just keep cycling around in a circle. I'm sorry. All right,
You came to us, like you said, and the only thing that we're looking here for is an Earth curve measurement. So how about it?
All right, I'm back. Hey, Central Earther. So I'm going to repeat the question. How is it that looking at a rotating object that you could see a difference in rotation?
You're going to repeat the same question you already got an answer to. You're going to
no, you didn't answer. Your answer was wrong.
They're sidestepping it. They're moving the goalpost.
Okay, here's what you do. You stand anywhere on Earth, you look north or south, you see either apparent counterclockwise or clockwise rotation. That's it. You're going to repeat the same red herring after what I just told you, which is that all we're looking here for is a direct measurement of Earth curve. You can just go on mute.
I want to
You're
keep
an
it
idiot.
down here where we live, man. Check it out.
Well, guys, the only way to really show you the curvature is for you guys to learn some geometry, like 3D
we
stuff. Okay,
we have
find that.
Wait.
Then take some time-lapse photography.
Okay, so we did the geometry that you probably haven't learned. Where is the horizon supposed to be at 1 foot observer height?
Yo, who keeps on muting
Answer.
this guy?
Answer.
1 second. Hey,
He hasn't done geometry. He just told us to learn the geometry that he himself hasn't learned, so he doesn't even know where the fuck the horizon is supposed to be on his globe that he just
said
told
that
us
at the
to
beginning,
learn.
remember?
Right.
Yo,
Why'd you
Central,
do that,
are you
Larry?
muting him before he's done talking?
He did. He admitted
Yeah,
it at the
no,
beginning.
I heard what he had to say. I'm gonna mute
No, you haven't heard. You're just going on with what doctrine that you're subscribed to.
You keep saying 1 fucking second. You gotta go look shit up. You're supposed to know this shit off the fucking rip.
Really? Do you expect someone to know every single fucking fact in
You
physics?
claim to, motherfucker. Shit.
Shit, bitch. You don't even know.
Yeah, if you're going to claim to a model that you have no real evidence for, then yeah, we kind of expect that a little bit.
But you can put the shoe on the other foot with you guys. Now,
I have evidence.
Dude, we're sick of you guys coming in here and not being prepared. Okay? If you're gonna come in here, have your shit together. It's annoying, man. This is how the shit.
Homework, bro. Yeah, it's like, come on.
I vote. We have a one-on-one with Fraud and this guy. I vote. None of the other flat earthers talk. So let Fraud talk.
All right, let's go ahead.
All right, I'll mute up. Shit.
Sure, yeah, I'll let Fraud take it.
Hey, man.
No, I want him to begin because he left off with the Earth was too big or some dumb shit he said. Do you know how big the Earth is? How big is it, dude? Tell us.
what unit do you want?
Man, dude, stop fucking. Don't play coy, bro. You come here. You gotta
He's
have.
buying himself time.
You know what I'm saying? I don't want to sit here and debate and argue. I want you to have your shit together, man. So what's the size of the Earth? And you should know the curvature, everything, all these equations you should have ready to go. Okay? Buddy asked you at 1 foot observer height, where's the horizon? You want to look it up. Why don't you know that, bro?
Give me 1 second here.
Somebody
You've been doing
have
that the whole
silly
time, bro.
music.
Yeah, I mean, guys, you guys are such shitty. You guys realize I do have
Whoa, wait
a
a
really
minute.
hard time with
We're such
retaining.
what?
Oh my gosh! Now you're gonna give us some sob story?
No, I'm not.
All right.
You asked me why I look shut up. I told you. If that's not acceptable, I don't know what else would be.
Who said why you won't shut up? We want you to actually talk, but have some substance to your conversation.
When I give you the substance, you deny it.
We deny it.
Yes, you did.
You don't even know what the hell the horizon is.
Maybe not you particularly, but I wanted to go back to the density, and you guys keep moving the goalpost from that, and you talk over me when I try to get into it.
How does that prove
I'll give you $5 to not say that word. That's crazy.
What does the density of the media have to do with the curvature of the Earth, Valerian?
Exactly.
No, we were talking about gravity, buoyancy,
Can I-
and stuff.
1 second, I want to clear something up because Valerian is constantly saying moving the goalpost. I've posted something 25 minutes across the hour. Can you read that out loud?
Let me, is it moving the goal? Yeah, demanding from an opponent that he or she address more and more points after the initial counter argument has been. No, that's not moving the goalpost.
That is moving the goalpost. So you are using it wrongly.
Now that you've read the definition of it, you're going to argue and say that no, that's not what it means. Like what?
The nihilism.
That is moving the goalpost. You probably are trying to say, well, you're gish galloping or scattergutting, right?
Beating a dead horse.
You are using it wrong. Anyway.
Did you
Stop
see I
using it
posted
wrong.
this? Shifting goalpost is an idiom, which means changing the terms of a debate or a conflict after it started. We were talking about density, buoyancy, and vacuum chambers. You guys kept moving the damn goalpost. Quit it.
Okay, but aren't you trying to defend the globe model? So why are you talking about gravity? Density?
Gravity's very important because you guys were talking about, well, what about the air pressure gradient? Okay, well, that's caused by a force, and it's apparent force that when we throw things, there's a force pulling it back down. I don't give a shit what you call it.
So how do you go from that logic to the concluding premise, therefore the Earth is a globe?
Because if I can convince you that gravity is actually an observed force, then perhaps you will start thinking, well, maybe it does coalesce into a ball like every other thing out there. No, there's so many flaws that I hear in your statements, and you won't let me try to explain them.
Well, you don't know half of the model that you claim to believe in, though. That doesn't make sense. You're not making any sense.
You said convince. Why can't you prove? Why can't you prove it?
Because you can't prove shit in science. You can prove mathematics because they're theorems, but you can't prove anything in science.
With Einstein's head on.
What you can prove. It's not.
Valerian, that's epistemologically erroneous. You use science to prove many cause and effect phenomena.
Science does not prove anything. Science doesn't prove anything.
That's the whole point, Valerian. That's wrong.
Go open a church,
You want to go visit all those people in prison and tell them that, that science doesn't put them in jail and it doesn't get you.
Go open a church, dude. Find a following. Get some believers, bro.
So,
find a different religion, bro.
If anything that we were discussing with density, buoyancy, and a vacuum chamber at all. That's what we were discussing earlier.
Because Valerian, when you appeal to all these things in your inductive argument, it does not follow. It's a very weak inductive argument to go from density and buoyancy and gravity and try to substantiate your concluding premise or justify your concluding premise that therefore the Earth is a ball. The Earth could be flat with gravity, with density, with buoyancy, with vacuum chambers. It just does not necessitate that conclusion.
Okay, then what? The observation of gravity. You know that a force requires mass and acceleration, correct?
Sure. What does that have to do with the conversation?
When we were first talking about the helium balloon floating, I asked why a force is required for it to float. Now, initially, some of you said that no, a force isn't required for something to move or float in this case. And I was like, yes, it is. And later on, I don't remember who it was. Was it Central Earther? But he said, well, okay, yeah, I'll accept that buoyancy is the force that was causing this based upon differences of density between the object and the medium. Is that correct? Do you guys recall that?
So we're back to the medium.
Yeah, we never really supposed to have left it. You guys keep moving away from that.
Yeah, well, we don't care. Gravity isn't a factor because gravity was supposed to have formed the ball that you can't show us the curvature for. So
okay, but
when are we getting to that?
Here's the deal. In a vacuum chamber, there is no buoyant force. I don't care if there's still little particles inside it. Come on, let me explain.
But wait.
Well, why are you explaining? Why aren't you just showing us the Earth curve? That would just settle all of this right now.
Like with Central Earth is trying to do.
But you don't accept the evidence.
Valerian, what Central Earther is trying to do is get back to the central point. That's the whole point of this live stream. So why do you keep not talking about the curvature of the Earth, but rather focusing
because at this point, I don't really care about the curvature of the Earth. I want to know why you guys think density is what causes things to move.
Well, that's a question. That's a question that you may never get an answer to.
And I may
feel comfortable with that, or does that make you feel uncomfortable?
Really,
at that point, but it doesn't matter. It doesn't matter if it makes you feel uncomfortable or not. The point is, you may never get that answer. Do you see the problem with continuously asking us, why does the rock fall down in the medium of air? Like you could ask us that all day long until anybody has a demonstration of why the rock fell down in the medium of air, a cause to the effect. Until someone has a demonstration of a cause and effect relationship. What the hell are you asking us that question for? Why would you ask anyone that question?
What force is acting upon the objects in the vacuum chamber that causes them to fall?
Okay, are you presupposing that it's a force that was supposed to form the Earth into a ball?
Of course.
Where you're going with this? Okay, then show us the ball, and then we'll rule out whether or not that force could be acting on anything. Show us the ball.
I gotta ask one question.
Okay.
What lifted the rock up in the vacuum chamber?
Probably a person.
Oh, a person. So what did you do to that object when you did that?
I'm sorry, say, what did they do to the object to cause that?
Is that a rock and you lift it up in a vacuum chamber? When you lift it up, human, mechanical, robot, whatever, I don't care. What did you do to the rock?
You applied a force when you lifted it.
Exactly. What is that force called?
Potential energy.
Well, you're talking about potential as being above the Earth. When I'm lifting it, I'm actually using a...
The rock was chilling down on the ground. You picked it up. That's why it falls, man.
What?
Rocks don't fall by themselves if they're laying on the flat ground.
Sure, there has to be a force acting on it, right?
There has to be a magical Disney force on it.
That's not necessarily true. The only reason you keep arguing that way is because in the history of the globe model, they had to give an account, an ad hoc account, for how the Earth is functioning at all in a vacuum, flying in the midst of a void as a ball. That's the only reason you're appealing to gravity. That is why the theory, the mass attracting mass gravity theory, was made, to account for all things staying on the surface of this supposed ball, supposedly flying at untold speeds in various directions in a void. That's the only reason. It's not because you actually observe a force pulling anything down. That's not a part of your human experience, nor anyone else's.
Yeah, and it's not because anyone ever demonstrated gravity to be the cause of anything falling down. You never observed anyone demonstrating that to be the cause, more importantly.
Right. But we do observe things falling down in a vacuum chamber. For that to happen, a force, not potential energy, that's wrong. A force has to act upon it.
That's wrong.
Okay, so hold on a second here. So let's just say, yeah, sure, a force. Are you going to call it gravity?
We can name it whatever we want at this point, but we have to at least acknowledge that we observe the object's fall. So there has to be a force acting upon it, correct?
Yeah, what I'm saying is...
You said no? That's ridiculous. Don't you know the definition of what a force is?
That's because you think in a void, things just float. You still got Star Wars on your mind.
What? I remember when you guys moved that to that argument, but no.
Here we go.
If there is no force acting on an object...
Why do you say that a force must pull the object down in a vacuum?
Or pull it.
What force pulls anything? Forces push, don't they?
Well, we've named this apparent force that seems to make everything fall.
Where she stops, nobody knows.
But the question, why do you believe that there must be a force that pushes or pulls the object down in a vacuum?
You mean a vacuum chamber on Earth, correct? Let's be clear.
Correct.
Okay. For an object to move, a force has to be applied. There's no buoyancy force to act on the density of the object, but yet it falls. It doesn't just sit there and float when we let go. So observation shows us that a force is acting on the object. And by force, I'm talking about literal push and pull observation. Newton formulated his laws for it, but I'm not even talking about that. I'm talking about a simple fact that things do not move unless you apply a force to it. Doesn't matter what that force is. Now, you guys were saying density. Buoyancy is what causes that force to make things float or sink or whatever, right? Well, when we remove that medium altogether, and no, it does not matter if it's a true vacuum. That's just, ad hoc craziness. But we do observe the feather and the hammer falling at the same rate towards the ground. Now there has to be a force that causes that because we removed the entire medium that would apply any type of buoyancy. Unfortunately, a balloon wouldn't work in a vacuum. The air pressure would expand and pop the balloon. But let's say we had one that would work, a helium balloon. It would still fall to the ground at the same rate as the feather and the hammer. Now,
Valerian, have you I'm sorry.
No, this is simple observation, guys. We're not talking about theory here. Now, what I'm trying to say is we observe this force. We know it's not caused by buoyancy, has nothing to do with density at this point in time. So we named that force. We call it gravity. Now, I don't understand why you guys are hung up on our English definitions for forces, like the various types. You got electromagnetic, weak, strong, nuclear, and this apparent gravitational force, which that depends on the theory you subscribe to, doesn't it? MOND is modified Newtonian dynamics. It says Newton was correct but had a slight problem at the far edge of the gravity range for the numbers that are input. Relativity comes by and says, well, look, all of this works, but we've got to add dark matter. So those are theories, and we're not talking about the theories when we're talking about gravity in this case. We're talking about the observed force that pulls it down. You can name it whatever you want. Don't call it gravity. I don't care. But it exists, and it's observed.
Valerian. Okay. So have you considered that when you jump up and down, or when you have the rock in the vacuum chamber, the artificial vacuum chamber, that nothing is pushing you down nor pulling you down, but your body or the rock in the vacuum chamber is simply trying to find rest in the medium that it is in?
But how does it do that? Because it can't move.
How does it do that?
If there's no force acting on it, then it can't move at all. Right?
Well, you asked the question. Wait. You're like a boulder down a hill. Just pause. Slow down. Okay. You said, how does it do that? Do you ask that question in the sense of how is it choosing to do that? Because it's not choosing to do anything. It simply functions the way it does.
That is not a good explanation, Gregory.
But that's the question you asked. Okay, so when you ask me, pay attention to your words. I'm very calculated with my words, and I pay attention to what people say. I just answer what people say. So when you ask me the question, how does it do that? What do you mean? Elucidate that question.
Okay, hold on. Let me try to remember everything that was said in this case. We were talking about the objects in a vacuum chamber and they fall, correct?
Mm-hmm.
And you said it just happens because it does? Is that what you were saying?
I said, have you considered that nothing is pushing it down nor pulling it down, but rather it is simply finding rest within the medium that it is in?
But hold on. Now, I want you to understand from what I'm talking about. A force is a definition for a word that we describe when we push or pull an object and it makes it move. Do you agree with that?
Sure, that's what a force
Okay. There is no pull. There's only push.
But wait. Don't misunderstand. He's just defining what a force is. So yeah,
Yes,
force does.
I'm trying to keep it simple. Now, when you release the object inside a vacuum chamber, there has to be a force pulling those objects down, correct?
Right there. You keep stipulating that supposed necessary premise in your argument. But why do you say that there must be a force?
Because the objects move. They change from a rest position to an inertial. Well, the rest is inertial, I'm sorry. They go from a rest frame of reference to one that is in motion. For that to happen, no different than you pushing your mouse around, a force is required. I don't care if you call it gravity or not. Now, I'm asking you, since we know that it's not buoyancy that's causing them to fall, what would you call that force? Because we don't want to call it gravity, right?
That's the problem with your question. You see, you keep stipulating this supposed necessity, but the problem is that it's not a necessity for the object to fall and find rest. So
yes, it is. That's the problem that I disagree with you on.
Wait. So you're attempting in this inductive argument to appeal to the fact that things fall, even in a vacuum, to try and, again, this is an inductive argument. You're trying to appeal to the fact that things fall, even in a vacuum, to then justify the concluding premise that there must be a force in order for anything to move, including things to fall down in finding rest.
That's not a fallacy. That's an actual fact, an observation.
Gregory, he already told you that force must be gravity, the thing that was supposed to have formed the Earth into a ball in a vacuum. So how about you just get to the part where you show us the ball and you show us the vacuum?
Because when I show you pictures from outer space, you say they're all photoshopped. You reject all evidence that we have of that.
Yeah, right. They can't be real because we're not measuring curvature of the Earth, so the Earth can't be the thing that you're showing us in those cartoons. So get back down to brass tacks, get down to the ground level, measure some curvature there, or fuck off. It's that simple.
Now, Central Earther, he's getting a little impatient, which I understand, but I like to go through the process. Valerian.
Sure.
So since you suppose that there is this force that is necessary to pull things down.
Push. In this case, yes, pull.
In this case, it is pull, right? So what evidence? How do you ascertain knowledge that there is this force that is pulling things to the Earth?
Because I've measured it, especially when I was at the University of Oklahoma doing physics. It's not a very hard thing to measure, and you get consistent measurements. Have you guys not done any of those?
You say that you're...
Hold on. Have any of you actually measured forces before? Answer me that.
I haven't done that. So
he's trying to reverse the burden on you again. He's trying to put you on the defensive again because he can't show you the ball that his downward force was supposed to have made.
Central Earther, it's okay. Nobody can show you that because you don't accept the evidence.
Okay, show it to us. What's the evidence? Are you going to show us a picture of a unicorn? That's not evidence. That's a cartoon. We need direct curvature measurements from the ground. Go grab those for us. Please stop wasting time.
So you're saying if I can give you those measurements and you can go out, are you going to actually go out and verify? Because I will go conduct experiments. I'm not shy about that.
All right, yeah. But this evidence of the ball, you think that pictures from space are evidence, right?
Well, they are. Unfortunately, you guys don't accept them because the way NASA does the photography, but, that's neither
so
here nor there.
So just let me ask you a few simple questions. Have you ever seen a horse in person? Yes or no?
A horse, like what you ride?
Yeah, the animal.
I grew up on farms and ranches.
You did say
Yeah, all right. So if I showed you a picture of a horse, you would have a reference point to use to whether or not to tell whether or not the picture of a horse I'm showing you is a realistic picture of a horse or not, right?
Yeah, because I know. Go ahead.
So you'd have a reference point, right? Yes?
Sure.
All right. So my question is, what reference point do you have to use to tell me whether or not pictures from space are real or not?
Any answer I give you would be unsatisfactory.
Well, the answer is none, right? I mean, the honest answer is none, right? You have no reference point to use. So would you concede that the answer is none?
I could talk about the lunar range mission where we actually put mirrors on the moon, and you can go down to an observatory and schedule hopefully to do that experiment, and you will see that the light actually gets reflected back and you can measure the lunar range, but that's all taken theoretically because of the speed of light being constant and all is dependent upon relativity theory. However, they have taken photos. They went to the moon. They placed mirrors on the moon, and we did take pictures of the Earth. Now, the problem is you guys don't accept that as evidence, which is fine if you want to do that. So what you're doing is rejecting actual evidence and then asking for something that is extremely difficult by taking it from the ground.
All right, pictures of space.
All right, so let's focus on the Can we have a little discussion here briefly about the standard of evidence? So your standard of evidence for the vacuum of space being real is pictures, right? Like you see pictures from space and you think space is a real place, right?
Right.
The pictures?
I believed it for a long time. Yep.
But it's more than just pictures, though. We've got satellites up there. You can actually see the International Space Station.
You got astronauts. Well, yeah. So what I'm trying to say is it boils down to two categories of evidence. You have eyewitness testimony, astronauts, and you have pictures. So you have pictures and eyewitness testimony. So with these pictures and eyewitness testimony, you believe in the vacuum of space, right?
Hold on. Yes, I actually do believe in the vacuum of space.
Okay. So now my question is, there are pictures of Bigfoot, and there are plenty of eyewitness testimony to support the evidence, to support the claim that Bigfoot exists. So do you believe that Bigfoot exists?
He might, but I haven't seen any evidence for it, no.
So do you believe that Bigfoot exists, though?
Like I said, he could. I'm agnostic about him.
All right.
Get agnostic about
meaning there is no direct evidence one way or another to support the existence of Bigfoot. Chances are it's just a guy in a freaking
or the vacuum of space.
I want to ask Valerian about gravity because this is a very key, a very crucial premise in the ACP, the academic cosmic paradigm. Now, you say that you've measured gravity, correct? Can you define what you mean by gravity?
The apparent force that pulls things towards the ground.
Okay, so is the Earth pulling things to itself, right?
Well, according to the theory, mass attracts mass. But I understand that you guys do not subscribe to that and you reject all experiments that show it.
Okay, what in the world, what is the observed phenomenon, and what is the experiment after the phenomenon was observed?
The observed phenomenon would be an apparent traction between mass. The Cavendish experiment, which again I know you guys rejected, But it does measure the force of that attraction, and it does agree with the theoretical equations predictions. Now, there's a reason why I applied those words theoretical is because we have equations that predict what the force of gravity should be at various points.
Natural observed phenomena, please.
Well, he said supposedly that they observe the masses attracting to each other. So is it a macroscopic object that is attracting it, or is it the atoms or the subatomic particles?
It's anything with mass and energy.
Okay, so even the subatomic particles.
Of course. But you got to understand, gravity is so weak.
So mass is actually just like how Gregory was telling you a few minutes ago that gravity was a word just made up to help brainwash you and I and Gregory into believing in this heliocentric model. So they made up the word gravity. They also made up the word mass too. So the thing is, there's no coherent definition. No,
Ryan, I'm sorry to interrupt you, but I disagree with everything you said.
Okay, so define mass. This is a challenge then. Define mass.
Is the amount of energy condensed into matter. Now that's as simple as I can get it, but mass is complicated. You guys want to get into quantum dynamics, we can go into that, but I doubt any of you would understand it. Hell, I don't even understand it as well.
The definition you just gave is contrary to.
So there's this many. There's like what, a few calories, like 6 calories or something, in a peanut or something. It sounds like you were just describing calories, not mass.
No, that wasn't describing calories.
Well, it sounded like that's what you were describing. You certainly weren't defining mass for me.
I actually did.
What is mass? Let's go with that first, because we're trying to get somewhere. I'm trying to learn something. So, what is mass?
Hold on. I'm trying to find a definition you guys would accept.
He's got to go and check Google again.
No, because you guys are very picky about definitions.
Well, we have to make what we're saying intelligible. If what we're saying is meaningless and unintelligible, then you haven't said anything.
Yeah, we have to have a basis for language. I mean, yeah, I agree with you. What's wrong with that?
Of course. You guys didn't like the energy explanation, so I'm trying to find something that would be acceptable.
I know you're trying to find lots of things. You're a real go-getter. We're all surprised.
Here's another simple definition. Mass is the quantity of matter in a physical body. But that's not necessarily true, though, is it?
What's false about it?
Well, it's not considering the energy effect.
The energy effect? What effect does the energy have?
Energy also has a gravity field to it.
Yeah, but that's two different kinds of science.
Okay.
It's not two different science. It's explaining the same thing.
So matter and energy has a gravitational pull. Okay.
Of course.
Now, with what you've told me, that implies that in one of two scenarios, I've said this before, if all matter and energy has the same, if all matter and energy is the same massiveness, right, the same gravitational pull.
Okay.
They don't, right? Okay. So, but if they did, then nothing would move because nothing is pulling anything toward anywhere.
That's not true at all. You're talking about the arrangement of the matter would have to be in such a way that all forces cancel. So what you just said is false.
Wait. It's not false. If all matter and energy has the same mass, then nothing is pulling anything else.
What if we arrange the mass differently? Let's say I put a little bit over here, more to the left, and even more to the right. Everything has the same mass. Yet the stuff that has more mass concentrated in a volume will pull everything towards it.
But the pull depends on the quantity of mass. But if everything has the same quantity of matter, which then would have the same quantity of mass, which would have the same...
But there's another factor there that you're ignoring, which is space.
I'm not ignoring anything.
Well, you're trying to say
Space,
if everything...
that thing that you couldn't show us the 10 to the negative 17 torr pressure measurement for.
I didn't even look it up. Why are you saying I couldn't show it?
You didn't look it up, so you don't even know your own claim. You didn't look up your own claim. You also can't show us the ball that's supposed to exist in the vacuum of space.
You just love to move goalposts, man. I'm not even talking.
I'm not moving the goalposts. This is exactly where the goalposts have always been, and you are trying to run away from them. The goalpost is prove your fucking
come
ball.
on, dude. Learn some physics.
You guys are being mean to me, man. You keep moving.
Okay, learn some physics. What physics should I learn that will point me towards seeing the Earth as a globe? I want to see this globe. What physics should I learn?
It's pointless. Gregory, go on, please.
It's pointless because you don't have a curvature measurement to show for this ball. You can't show us this ball. The only way you can do it is as you already tried to by showing us cartoons.
Well, prove to me that the entire Earth is flat. You can't do it because you'd have to have a picture from space.
Well, we've measured enough of it to know that it's not curving the way that a 39, 59-mile radius ball... Hey, shut the fuck up. We've measured enough of it to know
because that's
dishonest. The way that it would have to be a 39, 59-mile radius ball.
Because you can tell in your local area that everything appears flat does not mean it applies to the entire global area.
10 miles, it would have a 66-foot vertical drop.
And what are you measuring that from?
And there would also be, I'm getting it from your globe geometry that you told us to look up because I guess you yourself haven't. The very thing that you're here trying to argue for, you haven't even looked into it. So another thing that we would have is a 1.2 mile sagitta or a ball edge at 1 foot off the ground, or a 3 mile sagitta at about 6 feet off the ground. We don't have that. The horizon is consistently seen way too far to be the leading edge of a ball. So the geometry that you're here claiming doesn't work out, and you're just trying to waffle around and around and around it for hours, and I just can't believe these guys are letting you get away with it.
Because I'm making some valid points.
You're not making any valid points. The only thing we need from you is a curvature measurement.
Now, back to gravity. So what I was trying to say, Valerian, please listen to the end of the sentence, is that if all matter and energy had the same amount of mass and the same amount of gravitational pull, nothing would move because nothing will be pulling anything else. Now they don't in your paradigm and in reality. And so the most massive piece of matter, the most massive particle, and the most massive packet of energy would be attracting all matter to itself. But that's also not happening. So
yeah, but what you're saying is a false premise. It really is. Because all that matter that you're talking about...
What do you do, have a cheat sheet in front of you or something, and you're just going back and forth between the different arguments?
Ricky, I'm not talking to you, I'm talking to Gregory. Gregory, now, I enjoy talking to you, you seem calm enough.
Thank you.
Now, what I'm trying to get at is, if everything had the same mass, regardless, it would also have to be equally distributed through space. Okay, do you understand that? In fact,
not necessarily.
If we had a hollow globe, the equations, and I get it, you guys don't like that, but if the globe was perfectly distributed in mass and density, but
He muted himself.
Thank you so much.
Hey everybody, happy 4th of July, and shout out to everybody here tonight. Thank you.
Thank you, dude.
Thank you. Sorry if I get a little crazy, but there's a lot of misconceptions.
I got to jump in and just let everybody know that it's midnight here. It's actually the 4th of July finally here where I'm at. I don't know where you're at, but here in America, we like to blow shit up on the 4th. I don't know what that's all about. I have no idea. I live in America. It still makes no sense. It's some kind of crazy thing that Americans do. Woo! All right. Cheers, everybody. Keep going.
Cheers. Okay, Valerian, as you were. Valerian.
Oh, he's muted.
He must be doing something.
There we go.
Oh, there you go.
Oh, no. He's muted again.
He's trying to figure it out.
We got him.
Okay, I can speak again?
Go ahead.
Okay, what were you saying, Gregory?
You were saying that there was a false premise in what I said.
He got muted again. Or there you go. Okay.
What's going on over there, Valerian?
Sorry.
Why you keep...
I had somebody else muting him, man, I think.
Can y'all hear me?
He wasn't.
I can hear you now.
Okay.
You're back. Go ahead. Carry on with Gregory.
Okay, Gregory, what I was trying to say, it doesn't matter if everything had the same mass. It also has to be spatially distributed such that the forces between the masses would cancel out. And that's why I gave you the hollow sphere example, because that is a configuration of mass to where inside the hollow sphere, you wouldn't feel the force of gravity.
Why does the amount of space between the particles or the location of the particles have an effect on the gravitational pull of the particles? Because I thought what is pulling the particles to one another with the gravitational pull is the massiveness of the particle. So the where they are is irrelevant.
Hey, Valerian, did you choose to call yourself Valerian because your voice makes people sleepy?
My D&D character's name.
So Valerian, if you could hear me, what effect does the location of the particles in space have on the gravitational pull between the particles? Is it not irrelevant where the particles are in space, because the gravitational pull between particles depends on the massiveness of the particle, not where they are in space?
It also depends on where they are in space.
But how does that make sense? How does the space affect the gravitational pull of a particle? How does the location affect the gravitational pull?
It's the distance. Hold on.
Okay, that's
the force of gravity acting between any two objects is inversely proportional to the square of the separation distance between the object center. So yes, where they are located, the distances does matter.
But if all particles have the same amount of mass, and all packets of energy, as you like to call them, have the same amount of mass, it doesn't matter where they are.
Yes, it does. Why are you saying that?
But it wouldn't. Have you thought this through, the implications of these physical premises?
Yeah, this is just a very simple... Sorry, go ahead.
If all particles and all packets of energy had the same mass, nothing would pull anything else.
That's not true.
But you appeal to the location of the particles in space, but if they had the same amount of mass, it wouldn't matter where they were. Nothing would move, and nothing would be pulling anything else.
That's not true. Explain why you think that.
I just explained it.
No, you're just telling me what happens. You're not explaining it.
That's a distinction, not a difference. If I'm telling you, I'm explaining to you. So the reason that would be the implication is because in your paradigm, the motion, the gravitational pull of one particle to another is dependent on the massiveness of the particle or the packet
and
of energy.
The distance that the objects are separated by.
But you're appealing to this equation in a world where the particles are not of the same massiveness. Okay, so that would be a factor.
No, you're not understanding what I'm saying, are you?
No, I understand. What you just appealed to is presupposing a world where the particles and packets of energy have different quantities of mass. But in a world where the particles and packets of energy have the same quantity of mass, nothing would pull anything else. Nothing would move.
That doesn't make sense to me. I don't understand why you think that is true.
That's the a priori, in principle implication of the premise. Okay.
Well, that might be your premise, but
no, it's not my premise. The premise, you follow me. I'm explaining the implication of the premise.
Look, you're saying that if everything had the same mass...
Don't interrupt.
Okay, I'm sorry.
Just hang on, so that you can finally get this, because it's for the 6th time now. So if, there's the first premise, all particles and packets of energy have the same quantity of mass, and the quantity of mass is what determines the gravitational pull of the particle and packet of energy, then nothing would move, because everything has an equal amount of massiveness, thus an equal amount of gravitational pull, thus nothing is pulling anything else, thus nothing would move.
Now, what I'm trying to bring to you is the spatial separation does matter. So are you talking about a configuration of matter?
But not in this logic sequence I just explained. You keep trying to refute me with another premise in another world where particles and packets of energy have different quantities of mass.
No, I'm not. I'm still going with your premise.
No, you still don't understand what I'm saying to you. You keep going back.
I really don't, because you're not making sense.
No, you don't understand yet. I can't. You need to listen. You're not listening well. Okay? I just explained to you the implication of if all particles and packets of energy had the same quantity of mass. Now, what you're trying to do is you're trying to refute me by appealing to space in the equation, and the equation presupposes a world where the particles and packets of energy have different quantities of mass. So yes, the further away you are in your paradigm, the further away particle B is from particle A, the less gravitational pull particle A will have on particle B. Yes.
But they can have the same mass. You get that, right?
If they have the same mass, like I just explained, if all particles and all packets of energy had the same quantity of mass, nothing would pull anything else.
But what you're failing to mention is the spatial configuration that mass is in. If you don't understand that, then I don't know how we would ever come to an understanding.
The location of the particle does not matter if all particles and all packets of energy have the same quantity of mass.
Okay, is all matter in the universe spread out equally?
No.
It's in clumps and chunks, right? Like galaxies and solar systems, correct?
Not like that, but yes, it's not evenly distributed.
Explain to me what you think all that stuff is out there. Because we can clearly see that matter isn't equally distributed.
That's not the point. Just matter is not evenly distributed through space. There isn't an equal distance between every particle.
Of course not. So, what I was trying to get clarified is you're saying if everything had the same mass, then nothing would move by the force of gravity, okay? What I'm trying to say is that's not true, because you have to take spatial locations of all that mass into consideration. So, for instance, like a galaxy has a lot of matter, a lot of mass in the area, or volume, should I say, of that galaxy. So that mass is pulling on other galaxies, and the mass of the other galaxies is pulling on the mass of whatever other galaxies it's. Even if all that mass was the same, there would still be an attractive force between them, unless you have distributed that matter equally throughout space. Then it would cancel.
But then it would cancel. Does not make sense. That appeal in this logic sequence doesn't make sense.
Why not?
I'm telling, do you hear me in the middle of the sentence? You already stipulated that the cause of the gravitational pull is the massiveness of the object, not the space, not the distance.
Gravity is not a constant force throughout the entire universe. So a single mass doesn't exert a force 50 billion light years at the same as if you were next to it. You know that, right?
Let's start over. You believe that everything is made of materialistic atoms, correct? Material atoms?
is full of shit. You know, space. What space? How
So
can we
anyway,
have
actually,
how can we have gas pressure without a container? What
I'm
space?
gonna get off.
Second law of thermodynamics violation. What space? It's a fairy tale. This guy, you know, he just came here and talks the same old shit. Nothing more. Okay.
So rather than talking about the
I mean,
equal mass part,
1957, Russians were at Antarctica and talking about flat Earth and the firmament. And it is now a CIA declassified document. And this guy comes here to talk what? 1958, NASA starts 1 year after this. I mean, and this guy is full of shit. Coming here, Mr. I didn't mute him, but I know I enjoyed the moment. You know, Mr. Physician, show me a gas pressure next to a vacuum without a container.
A vacuum without. He said vacuum without.
You want gas pressure at the.
That would be just great, man. I'm here 24/7, 365. Bring it. Next.
rather than talking about the equal mass, in reality, you know, in his paradigm also that particles are the same amount of mass. So, in his worldview,
and by the way, I did post, a rat, a mouse on space. How can that be possible? And this I did post, I did quote him, but he didn't answer. So how can you have directly from NASA YouTube channel, a rat on space? I mean, how can that be possible? A rat on space? Are you kidding me? I'm gonna post again. Because these guys come here with fairy tale stories.
Okay, I can talk again, correct?
Just stop it. I don't.
I was going to explain how you have a gas pressure, but you don't want to hear it.
Just stop it. Come, because I'm gonna post. How can we have a rat mouse on the space? Let's see.
Yeah, gas pressure.
Okay, let me get the rat.
If you got a working model in your shop or laboratory, whatever you want to call it, I'll be right there. Let me know. Shoot me a DM. Thanks.
Bob is unmuted.
Okay, let me see. Okay. I'm gonna quote him.
Can you hear me?
Oh, shit.
I hear you, Essential.
Okay, that's what was going on. Every time I talked, you talked through me, but it's because nobody heard me. Sorry about that.
Oh. I didn't hear you at all.
No, I know you didn't. I just realized that I wasn't being heard at all. So it's not your fault. Sorry.
So Valerian, go watch this rat mouse on the space and explain to us. And this is from directly from NASA channel. Okay, go watch it first.
Good grief. The other thing I was trying to say to Valerian concerning gravity is that in his world where particles and packets of energy don't have the same quantity of mass, everything would just condense to the most massive particle. And then nothing will move anywhere else except to the most massive particle. So the implications of the gravitational mass attracting mass theory would either be the lack of motion of all particles, no matter where they are, or everything would just rush to the most massive particle.
Why are we talking about 1915 out of date gravity?
Because he is. That's the premise he holds to, maintain the globe model.
Right when he brings up gravity as a force, you just easily destroy it by that's not even the right. It's not even the right paradigm in his model.
So, what would you define the force? The observation that things fall towards the ground. That has to be a force, right?
Wait. To answer what Northern Rebellion said, even if he is late behind the ACP, we just address what he says about his worldview.
No. You don't talk about mass attracting mass for 20 minutes. That's a waste of time.
Well, we have to address his arguments. If he's not saying what he's not saying, then we can't argue against what he's not saying.
No, but
well, Gregory, here's the thing. His argument.
Wait. First, you have to make sure they're parroting. You have to make sure the Glober is parroting the right model, and he wasn't. But
well, no, you have to argue against what the person is arguing. Can't argue against an argument they're not saying.
The foundation of what he's arguing is a ball, a globe, so Earth curve. He needs to show that. And the ball being in the vacuum of outer space, so he needs to show his gradient thinning out to at least a pressure of 10 to the negative 17 torr. He's got to substantiate these things before he can go on and start talking about these vast distances between celestial bodies in his infinitely expanding vacuum.
Yeah, that's true. My point and what I was trying to say was when the globalist tries to hold the mass attracting mass gravitational theory, it implies one of two things. If all particle has the same massiveness, nothing would move. If there is a particle with more mass than all other particles, all particles would just condense down to the most massive particle, and then nothing would move after that.
And what I was saying, go ahead. What I was saying is that's a false. That's not true at all, Gregory.
But and I know your counter argument keep appealing to the distance, but the distance is not a factor. The location of the particles is not going to have an effect on the gravitational pull, because what's affecting the gravitational pull? The massiveness of the particle.
You do know that the force of gravity tapers off as it gets further and further away, so it's not a constant force all the way out,
but
right?
That would only happen if something else is pulling it away.
No, that's not true at all.
No. You're not thinking through. You're so hell-bent on trying to defend this premise, you're not paying attention to your own premise.
I'm trying to understand why you are saying that all things that have equal mass cancels out.
You're saying the further away the particle gets, then the less gravitational pull would occur. But the particle B is only going to go away from particle A if there's some other entity pulling particle B away from particle A.
But you're not, and I gave you two examples of this spatially, okay? If those particles are in such a configuration where the force or gravity on them, hold on, I've got to turn off this video that I was watching, it's crazy. Where did it go? It's that one video that you wanted me to watch.
The rat.
Here it is, sorry guys. Okay, I muted or paused the video. What I'm saying is this: it doesn't matter if if everything had the same mass, okay? If you had one clump to the left and one clump to the right, and it was all the same mass, they would still collapse in on each other.
I love making up shit on the fly.
Valerian, you keep appealing to particle B moving away from particle A. That would only happen if another entity involves itself into the situation and pulls particle B away from particle A.
Sure. Now, that's spatially dependent, correct?
No, you don't understand what I just said. You're not listening carefully enough. You keep trying to refute my reductio ad absurdum argument by trying to say, well, that would only happen, but that wouldn't happen if the distance between the particles increased. That will only happen if another entity entered the situation and pulled particle B away from particle A, the most massive particle. But you don't hold that world.
But what you're failing to understand is that you could have both particles being the same mass, and they will collapse in on each other. They pull towards each other.
What's causing that?
What's causing that? Because mass attracts mass. And what I'm trying to get across is that in one way you are correct.
But the only reason they're being pulled to one another, in your worldview, the only reason they're being pulled to one another is because one particle is more massive than the other.
That's not true. They can have the same mass. They will still pull together unless, like you say, there's something out there that is stopping that. And the only way you can achieve that is if you have configured the mass in such a way, spatially, that the force of gravity cancels out.
So then, if that's what you want to argue, then okay, say that your worldview still reduces to absurdity. In both instances, all particles would just collapse in on one another. But we don't live in that world. But that's not the case.
But the gravity's more complex than that.
Can I jump in real quick, Gregor?
Yeah, sure.
Yeah, go ahead.
One problem I've always had with people that believe in space that are still stuck in the brainwashing of it, if you really want to hold on to this theory that mass attracts mass, then there is like plenty of just fundamental problems with that in it, altogether. But one thing is, okay, so if mass attracts mass, and the sun would be in your world, the sun is the largest mass out of all the planets. In your logic, okay, I know you guys jump into a lot of bullshit to explain this, but in the logic of it, before you guys go and take the illogical route, all the planets would have crashed into the sun already. And why would a larger planet such as Jupiter in your world be farther than the smaller planets such as Earth? Because in your logic, thinking of things with an actual brain and not a brainwashed brain, you can realize that it wouldn't make sense logically for something larger to be further. If the original rewind your billions of years, whatever, if this was your...
Can I cut you off for a second?
Yeah, go ahead.
They actually have a magical explanation, counterpoint to what you're saying.
Oh, I'm sure
they do. In the heliocentric model in their fairy tale, they state that the more dense, more heavy materials, elements are closer to the sun, and the lighter ones are further away. And so they basically claim that the reason why Jupiter is so big and Earth is so small is because it's just a bunch of lighter material than the Earth is made out of.
Okay,
but it's just a story.
Yeah, because obviously we can look at a light that's X amount of miles away, and we know exactly what it's made out. Obviously, that's just obvious, right? We're good like that. But we can look at a rock, apparently, that's X amount of miles, apparently, and know exactly what it's made out of. Even though if I was to put a rock 100 yards away from you, you wouldn't be able to tell me what it's made out of here on Earth, in reality, on the ground.
It boils down to spectroscopy.
Yes, there you go, Ryan.
Spectroscopy requires isolation, so in order to use spectroscopy to figure out what something is, you have to isolate it.
That's right. And then the spectra that they get off the planets and the stars are not even the right kind for them to be made of gases, so it's all fucked.
Again, if I can't set up something a football field away from you, and you can tell me with certainty what it is made out of and all of this beautiful description of what it is, then how do you expect to do that on something that's a trillion miles away? It's just like logically, like at this point, ballers, when they talk, like my brain just like it wants to just shut off and just bounce.
Twilight
Zone. So what both Apocryphon and I have been trying to explain is the logical implications of this gravitational mass attracting mass theory. It implies, especially out of the mouth of Valerian tonight, it implies the implosion. It implies all particles zipping back together.
Yeah,
but we don't live in that world.
It doesn't actually imply that, though.
Yeah, earlier you said that gravity is more complex than that. So what's the complexity that we're missing?
Because you got to consider speed of the object as well, like the Earth going around the sun. We have enough speed that the gravity doesn't pull us into the sun.
Great time to mute him. If he's going to continue, he's not. Okay, cool. You made a claim that the Earth goes around the sun, supposedly as a ball, right? Valerian, it's a ball that's going around the sun at 66,000 600 miles per hour.
That appeal to the motion of the Earth around the sun doesn't add to the supposed missing complexity of the gravitational theory.
But it does.
Gregory, the question is what motion though? What motion and what ball is supposed to be in motion? Like you can't show us any of these things, so it's just sophistry.
Yeah, so let me think about the implications of what he's saying. So when he tried to appeal to the motion of the Earth around the sun, that's irrelevant to the question, to what he supposedly said is the missing complexity of the gravitational theory. What he was about to do is appeal to the motion of the Earth around the sun, which would have just presupposed the mass attracting mass theory. But he's saying that there's something missing from my understanding of mass attracting mass gravity. So what else is missing?
May I talk?
Well, what's missing from your explanation of this whole story is the globe, Valerian. That's the only thing that we're trying to get you to show us ultimately. That's what's missing from this entire paradigm that you put forth is the globe, and then everything else that you build on top of that with your outer space fairy tale with all the stars and galaxies and so forth. And
I did post a picture of the eclipse moving across the surface of the Earth as taken from space. Did you see it?
What kind of eclipse?
The solar eclipse, man.
Okay, well, what space? Do you have that pressure reading for us?
Do you realize that when you say space, you exist in that space?
Well, yeah, there's space between things. There's
space. Now, this goes back to me trying to demonstrate that there is an apparent force. Remember all that bullshit with the gravity and the buoyancy and the vacuum chamber that I was talking about? Well, if there is an apparent force pulling us down to the ground, it also pulls the atmosphere down. So what's happening is as you climb higher on a mountain, you will notice that air pressure gets thinner and thinner and thinner. It's a pressure gradient, correct?
Okay, does it thin out to an outer space vacuum? Yeah, of course.
Yes, it does.
To that vacuum. Okay, we got that positive claim, so now we need to see the outer space vacuum. I'll take a pressure reading of 10 to the negative 17 torr, please, to substantiate your outer space vacuum that this gradient goes to.
But you don't have to, because you know the observation. As you get higher, the pressure decreases, correct? So listen, it doesn't matter what your measurement was at this point. Okay, so when I use numbers in math, I'm...
Okay, look, it matters because you can't just get like a quadrillionth of the way there and then go, yeah, it probably just fades out the rest of the way. So you have to show us that it actually fades out to this outer space vacuum that you're claiming. Can you do that?
The pressure does decrease.
Wow, he talked the entire time. Yeah, I know it decreases. But does it decrease to 10 to the negative 17 torr, to near zero? Is that what it does?
Yes.
Okay, let's see it.
Go climb a mountain and you'll have evidence that air pressure decreases.
Okay, on top of a mountain, the pressure isn't 10 to the negative 17 torr. So why are we going in circles like this? You know what I'm asking you, don't you?
Oh, yeah, I can talk again? Yes, I know exactly what you're asking.
You can talk if you'll give us the answer. So yeah, okay, you know what I'm asking? Let's hear it. You're ready to go. You're unmuted. I'm just wanting that 10 to the negative 17 torr pressure measurement that you keep dancing around.
Well, let's look at a weather balloon atmospheric measurement, shall we?
Yeah, okay, yeah, shall we? Let's go.
No,
I'm sorry.
Yeah,
Valerian,
yes.
Could you tell me, Valerian, if I'm right or wrong, the gravity that you're talking about is mass attracting mass, right? Am I missing something? Is there more that needs to be added to what gravity is?
No, I think that's a simple definition that we should maintain.
Okay.
Not in the correct pseudoscience.
Oh, well, yeah. I'm sure some people may have agreed at one point in time with you, but most of them don't. And that's the point we're trying to make to you, is that you're saying mass attracting mass. What we're saying is most of the people, like if we go to an actual college where they're teaching this nonsense, they'll say, no, that's been superseded. Mass attract mass is out the window.
I get that because you're talking about relativity theory. I'm leaving theories out of this. For instance, we could talk MOND, Newtonian dynamics, relativity. I mean, choose your theory, but we're not doing that because you guys don't accept them.
Yeah,
let's it doesn't matter. The point is it's nonsense. It's nonsense is the point. It doesn't make any difference. Either way, it's nonsense.
Valerian, Valerian, stop choosing arguments depending on what we will accept. You're supposed to give everything you have to supposedly prove your position.
Of course. And I'm trying to find data for weather balloons measuring atmospheric pressure near the top.
Valerian, why don't you ask yourself this question right now? Do you think that there's a 10 to the negative 17 torr environment that a weather balloon has ever been sent into?
I would actually have to research that.
Okay. Well, I think the answer is pretty obvious, but okay, go ahead.
It might be obvious to you, but you've never researched it or done the experiments for it, so how would you know?
Well, I've talked to a lot of people like you who can't show me a weather balloon that has ever gone to an outer space vacuum of 10 to the negative 17 torr pressure, so I'll take that as an indication that no, that doesn't happen.
Hold on, I think it's hard to get these. Let's see.
Are you seriously entertaining the idea that weather balloons are sent to a near perfect vacuum of 10 to the negative 17 torr?
They probably can't even get there.
I would think that weather balloon has been there in that Narnia space vacuum.
What I'm trying to find is at what
and Narnia's far more real than that.
At what elevation would you get that number?
I don't know. It's weird how you came in here defending this claim that you're just Googling now. But yeah, carry on.
Look, guys, I don't know what the actual measurements are, but we can agree that air pressure decreases the higher you go in elevation.
We don't agree that it decreases to 10 to the negative 17 torr, because that's what I'm asking you to show me.
That's the number. That doesn't matter at this point in time.
Not just the number, it's your claim. That is the pressure that is claimed of outer space, and that is the adjacent vacuum that you say exists next to this high pressure system that we're in. So we got to see that, because even if it fades out to a tenth of a psi or something, and you can get us a measurement of that, you're still like trillionths or a quadrillionth or something like that off from what you're trying to prove.
While he looks for that answer, can I ask anybody here, what is their explanation for Venus spinning backwards opposite? I mean, logically, I think we could all use our brain and realize that if everything's going in motion in one direction and then all of a sudden there's like this just oddball just spinning the opposite way, it would have a different trajectory. It would have a different, it would probably even like come to a halt to go the other way eventually. Like, I don't know. I try to use my brain when I think about these things, as opposed to like brainwashed ballers who what's their response? I'll stop.
The presuppositions and the implications of the assertion. Yeah.
The response is, oh, hang on, I'll just Google my argument for you.
Hey, Gregory, it's good to hear from you too, by the way. It's been a while.
It's good to hear from you too, brother. God bless you and that family of yours.
Hey, man. Yeah, same to you, man. Hope all is well.
All is well.
Yeah, good. It's interesting because I like to find out if like ballers believe in creation.
What do you mean by creation?
Meaning the creator, when he said, "Let there be light," and then there was a great light and a lesser light put into the heaven, into the sky, and then stars and the planets, the wandering stars, they were all put into the firmament. Like, I believe in that, but I wonder if
the personal supreme being who created the created world.
Yeah, and then there's no such thing as we are the center of a universe, because I think that kind of gives you this description as if like it's us and then like all these galaxies that circle around us. I don't even think it's that. I think it's just the firmament, and then we as large and as big as this Earth is or can be, in its basin, if you will, like a swimming pool, a little kiddie pool that you could put your dog in when it's hot in the backyard. Like, there's water, and then just put like leaves on top. That would represent the continents, if you will, but there is a surrounding barrier. But then you would have to like create, like, how we're gonna have air for them, and how we're gonna have this pressure gradient of different layers of this air and then you would have to obviously enclose it somehow to have that. Otherwise, all the air would just escape my little pool that I built in this vacuumless, or vacuum, empty void, whatever you guys believe in. But anyways, I think that's why most people who finally see the truth, are shown the truth, revealed, the truth is revealed to them, and you're pulled from that brainwashing, and then it's much easier to see, oh, that this is how the creator made it, if you will, and it makes sense. It makes more sense actually than all your
the container for the liquid and the gas.
Yeah.
So you're saying there's a dome, right, over the flat Earth?
I'm saying
the hemispherical, but a container.
I'm saying there's a firmament, and somehow it's enclosing our ground here. Because
okay, define what the firmament is, please, because I really don't know what it is.
Well, I mean, I can be truthful with you. I don't know what the creator made the firmament out of, but
it is made out of something.
He does say that like a tent being stretched over. So, what does that mean to you? If I was to say, I took a
solid container over the face of the earth.
How does the firmament stay clean, though? That's what I would like to know.
Yeah, hey, believe me, there's billions of questions there's things that baffle all of us, people who study it, people who looked into it, people who don't know about it. But there's questions that are only the creator can really answer, unless it's revealed to somebody through some type of vision or prophecy, and they could write about it, they explain it. There's people that documented even the beginning origins, and you either have to believe that happened, that this person actually wrote this and was inspired by the creator himself, or you don't, and that's fine. That's your prerogative. That's your that's your free will. You can do what you want. But what I'm saying is, I think there's plenty of evidence that we can see with our own eyes that there is a creator, simply by looking around and seeing creation. And that's it. It's really, really simple.
That includes you also. That includes yourself.
Exactly. Think about
so let me ask you this too. Now, is your creator supposed to return to the flat Earth? Or let's not even call it flat or round Earth. Is the creator supposed to return to the Earth?
Yeah. Yes.
Yeah. I mean, according to the scriptures, I believe.
No. I'm just asking questions here.
That's a stupid question. Do you understand how that's a stupid question?
Well, the next question would be, is if you believe he's coming back, how would you recognize him?
Are you talking about Jesus? God? What are you talking? Just this incoherent nonsense.
Kind of like how the air pressure decreases the higher you go.
Anyway, here, forget about that, dude. I was just going to ask you, what is the cause of pressure? Can you tell me that?
Yeah, it's caused by a force compressing the gas, correct?
Well, it's caused by one thing pressing against another thing.
That's a force, right?
Yeah. And we have gas pressure here on Earth, right?
Yeah, it's pretty pressurized here at the sea level, but as the higher you go, it thins out to where it actually goes to a vacuum.
Okay, so where does it press along?
But I'm asking, why do we have gas pressure to begin with? What is the gas? Let me ask you this. Is gas omnidirectional? Yes or no?
In a small container, it would be. All the molecules would be bouncing around everywhere. So.
Why did you pause for that answer?
Hold on a second.
Why did you pause for that answer?
Well, for instance, if you're talking about wind blowing across the Earth, most of that gas does have a single direction. If we're talking about molecular gas, down to the molecular, it bounces all over the place, even if it's moving in a common direction. So what are you referring to?
Omnidirectional, correct?
The molecules, yes, they bounce around, they're omnidirectional.
And gas fills the available space, correct? Gas pressure.
That would be correct, yes, because liquids and gases fill their volumes.
So what is the volume that is around the globe Earth?
Well, we do have this apparent force that pulls everything down, so that force would literally start compressing the gas of the atmosphere. We would have a stronger pressure down at the surface than we would at the top.
So do you have any demonstration of gas pressure without a container due to gravity? Yes or no?
Yeah, you can climb a mountain. Air pressure thins out. That's simple.
Well, that's the gradient. Still pointing at the gradient. That's not what I asked for. I'm asking for
How do you get the gradient, Orion?
I'm asking for X. I'm asking for gas pressure without a container due to gravity. Here, I'll give you an example. So you and I, let's pretend we're a second.
I gave you a simple example. The higher you go, the less pressure there is. What's not to understand about that?
Example, that's the gradient. Do you not understand what a
gradient form? It's formed from the force compressing the gas.
Yeah,
the gradient forms every container.
You're totally missing the point, dude.
Yes, I am.
Gas pressure requires a container and a gradient air pressure system. Anytime you have the word pressure, you need a container. So where's the container? How are you getting all this? Answer the question right.
First of all, you got it wrong.
Bullshit.
Gas pressure is caused by a force compressing the molecules together.
The walls of its container. Read it properly.
Yeah, look at you.
But that's when you're talking about the atmosphere and how it interacts with gravity. You should know that the force is compressing the gas down.
Go all over the place.
That's the error of your
all over the place. You're not going to go all over the place in this conversation.
What you guys are talking about is, yes, you need here anywhere. You would need a container to contain the gas. The container adds applies a force to the gas, which of course pressurizes it inside.
But
right. So
why is it called? Why is it called 14.7 pounds per square inch of air pressure at sea level? Why is that? Why isn't that called atmosphere pushing on your face? Why is it called air pressure? Pressure requires a container. You already said that. So welcome to Flat Earth.
I didn't say pressure requires a container. You guys are that. When I say that it doesn't,
you're deliberately missing the point. This is not difficult. You just keep skating around the obvious point.
Okay, let me ask you something.
Wait.
Okay.
We know how gas behaves. It expands to fill the available space. So it's not condensing down, it's expanding outward in all directions. And the only way you can press on something is if there is a thing present to press against. But if there is no thing present to press against, then you can't press against it. But you're coming to the very opposite conclusion.
I want to ask him, this gravity force, the alien and the less dense gas goes up. What happens? Why they stay there? What force is gravity? I mean, gravity pulls and gravity sucks.
Right? That's my point earlier.
So why this vacuum of space doesn't suck this alien, and other less dense gas? It has to be a container. So
especially in their naturalistic framework, their anti-theistic, atheistic, metaphysical framework, where it's just impersonal, supposed quote-unquote natural forces moving things in a law-like manner in a world that is random. So if the entities in reality are the so-called laws of nature and the forces that make the cosmos behave the way you believe and suppose that it behaves, but the implications of these entities, these forces, these so-called laws of nature in this random world imply a reality which is opposite what we experience, you rather would maintain the a priori theory, which is implying this falsehood contrary to reality, rather than forsaking the a priori theory that is contrary to reality. That's what we're pointing out.
Can I ask you something? I want you keep speaking about a gradient, But do you realize how that pressure gradient is even able to be the gradient that we're even talking about? Like, for instance, can you have that pressure gradient without it being contained to form that gradient? Like, imagine Earth being this giant pressure gradient going on, right? Like, as you go higher, like you keep saying, you go higher, it gets thinner. You go higher, it gets thinner. But I want you to think, where can we replicate that? And that would be at a refinery, because we have cokers that they use this different, the gradients to produce different byproducts of what they're producing, so that way they can sell the byproducts, as whatever they turn into, using the heat and and the pressure. So using like that, being that we can replicate the pressure gradient, but the key component to that is it's contained, because without it being contained, we would never develop that gradient. Do you like I get you're brainwashed, but can you just step away from everything you think you know, and just think of it logically real quick, and just think like, well, okay, if there's this pressure gradient and the main component to it is not just the heat, but it's also the container that's holding this product, allowing it to thin off and become a byproduct as it goes higher, which is why we find different gases at different levels, right? Because it's a natural thing that happens, and we can recreate it, and it's in refineries. But do you get what I'm saying? Like, just thinking with your brain, can you see it? Can you get what we're saying?
In other words, in short, Valerian, do you understand that the necessary antecedent to supposed gas pressure is a container for the gas to press against?
What does the container do?
Valerian, yes or no to the question I just asked you, that we just asked you?
You need a force, correct? And the container provides that, so yes.
Valerian, see, this is where we get indignant, because you obviously are skipping past the question, which is a close-ended yes or no question.
My last response was yes. I understand how containers apply force in pressurized gases. I get that.
Okay, so if you understand that the necessary antecedent to gas pressure is a container, then your supposed explanation for the gradient of the atmosphere upon the face of the earth is the very opposite of that necessary antecedent, which then reduces reality to absurdity.
I disagree.
You just said, you conceded that that gas pressure necessitates the antecedent container, but you subscribe to a cosmic model that doesn't have said container for gas pressure to occur. So your theory concerning how the atmosphere is behaving around the surface of your supposed ball is against the necessary antecedent for gas pressure to occur. Therefore, gas pressure could not be occurring in your cosmic paradigm. Therefore, reality would not be what it is in your cosmic paradigm.
Okay. However, all I was saying is that you need a force to generate the pressure, correct?
Well, but the force
the force comes from the container, right?
Yeah, the force that you said right now is actually what is the only thing that's being measured is the gases bouncing off that container. And
you are correct.
That's the force that you're speaking about. So, but now if you're going to invoke, well, gravity replaces the container because it's this force that squeezes it down and create. No, you actually did, because earlier you said that gravity creates the force by squeezing it down by pressure, by this pressure, and it makes it come down? Because you said earlier that things come down.
Yes, that's true. It does compress the atmospheric gases.
This is what you're saying, though. This is what you're saying, that that gravity is a force. But why are you stuck on that when the people themselves that came up with this gravity theory say it's not a force?
Hold on.
So what's
You're
going on
saying
there?
gravity theory. That's wrong. I'm talking about the observation of a downward force that we can all observe.
That's the problem.
You
That's your
don't throw
presupposition.
something. It all falls down to the ground when you throw it.
You don't observe your supposed mass attracting mass gravity. What was the experiment to ascertain this knowledge?
Well, we tried varying masses in the Cavendish experiment,
and none of that worked. Remember,
it worked. You just want to throw it away.
It's not an experiment. So
okay, if you want to deny it, then that's fine.
Call it the Cavendish dinner plate for all I care, but it's not an experiment.
Well, you see, it's not just the atmosphere that gets compressed. Even the oceans, you get deeper you go in the ocean, the more water pressure there is. So what force is causing this? Because there's no container over the ocean, yet it gets more pressurized the deeper you go.
Electrostatics, if you have to know, go research it then.
No, because I know all about QED,
no, you don't.
Electrodynamics, and
then if you knew about it, you wouldn't be arguing in here.
The
Earth is called ground. It's not called ground because they decided to call dirt ground. Ground is a ground plate that electricity uses. So it's called ground for a reason. All electricity goes to ground. That's what forces things to the ground. Now that we have that out of the way, you can unmute him.
Valerian,
because now we're getting into a whole nother world of where everything is about that electromagnetic, and now we're getting to the sun and the moon. There's this positive, negative, and then it goes off to a whole nother world that is more explainable, makes sense, and it's reasonable, because then you get into a world that it makes sense logically, and that I think that's what he's missing. But it's because he's brainwashed.
But let's back up again. We got to stop being irritated with the process. We have to back up and let Valerian explain the supposed experiment, because there's this supposed force in the world called mass attracting mass gravity. How did you ascertain
I just explained that we're not even dealing with that anymore.
I'm not trying to cut you off or anything, but I really do have to go. It's 3:00 in the morning over here, and just to leave you guys and whatever, it was fun debating with you. No, I do not agree with a lot of the premises that you're talking about, because I understand that a force is required to generate the pressure. That's what pressure actually is.
That's what you believe.
You can experiment. Take a bottle of air, put air pressure sensors along the side of it inside, cap it off, and start spinning it. The centripetal force will show a gradient inside the bottle because the force is compressing the air. So at the bottom of the bottle, you'll have a higher pressure than you do at the top. Now, with that said, I want you guys to think about that. I know you'll reject it. At least I assume you will. No, we're not talking about the container.
I didn't even hear what you said. I was still typing. I didn't even hear what you said because it doesn't make any sense anyway.
It's okay. If you don't want to accept reality, that's fine with me, guys, but I do have to go. I really do.
I don't accept beliefs.
I accept observation and facts, so...
I gave you the facts on how I gave you the facts on how it works.
Electrostatics, right?
Okay, I give you a declassified document released year 2000, and it talks about flat Earth and firmament. They are studying this on Antarctica. So what do you have?
I'm sorry, I'm actually pretty tired right now, so...
Yeah, go sleep to Narnia.
Yeah.
Good night.
Better.
Good night, guys. Hey, no hard feelings. I know we have different beliefs. Because
you're the only one that has a belief around here. Everything knows the facts.
You guys haven't presented any evidence that actually makes sense.
I gave you how things go down, and you don't like it. You want a magical unicorn that pulls it down. and it's not that way. Everything is pushed to the ground.
What? Okay, guys, I'm out of here. It was fun debating.
Yes, your brain just blew up.
Just go away.
No, the brain didn't blow up. I'm tired. Come on, quit being mean.
Yeah, evidence. I mean, I did show you a document from the CIA. Okay, and these guys, this was guys from the Russians. They were in the
Miguel, I want to cut you off
1977, before NASA. They were on Antarctica studying the firmament, the container. And you come here to say bullshit, so forget it.
Okay, it's fine.
Okay,
I won't trust the evidence that you post. You don't trust the evidence I post. Guys, it is late.
You don't have any evidence.
Those horses you were playing when you were younger.
Good night, guys. If I don't leave right now, we'll just keep going. So,
Just
guys,
go,
it's
man.
been fun.
Just go.
Have a happy 4th of July to all the Americans out there. It doesn't really matter what we believe.
That's a
so
cringy
enjoy.
statement.
You're the only one with beliefs.
Okay.
Belief is the enemy of knowing. So you don't want to know.
I'm the only one that's actually done measurements, right? Is that what you're saying?
What about the measurements that... Oh,
He's
just
done.
gone. He's done.
See how easy they are?
He's trying. If you're going to leave, then leave.
Yeah.
Not just repeatedly say goodbye.
I mean, he wants to talk about measurements, but in the year 2011 and 12, Brazilians, they spend money and time going to Lake Titicaca and other places, and they did the measurements with the lasers too, with a flashlight in, next, to the sea water level, and the other team saw this light on the other side of the lake, and these guys, man, and they contract engineers and surveyors, and these guys who don't want to accept it, it's their problem, And these guys, these engineers and surveyors, they were Globers at first, but when they did the measurements and observations on the field, they accept the reality. The truth, there is no curvature on water. And even between two buildings, they are not tilted. I mean, if they want to accept this, what they want? Just wasting our time. But they don't, they just come in here talking about the old shame bullshit, same bullshit, but they don't want to go to the field and do the experiments or observations and measurements. They don't want to do that. They just came here with talk.
A second ago you said experiment, but it sounded like you said excrement.
No, I corrected. Observations and measurements. Okay. But yeah.
Go out to the field and do the excrement.
But they can do this experiment, with the water level. They can do, with a tube and water, they can do a long distance water level and show us if that water is curving or the two sides is level. So if water is level, no curvature, no globe.
I mean, at this rate, as you said before, the globalists should have the argument prepared. They should have the experiments, the data prepared to substantiate their various arguments that are the aggregate, summation of their position. I mean, when I ask what is the evidence that substantiates this premise of mass attracting mass gravity, it should just be, boom, here's the link. The experiment. Here's the observation, here's the experiment. But the only reason like in the beginning of all of our human experience in our generations, the only reason we think this notion of mass attracting mass gravity is because we were told this, because we were indoctrinated with this doctrine, this physical, rather metaphysical doctrine. We never went outside and said, wow, look at all these things attracting to one another. No, we just saw things fall. But then someone else came along and said that mass attracts mass. And then we try to make sense of this notion, and we realize that the implications of the notion imply that all material would just condense back to one another. But we don't live in that world. And so the premise implies falsehood, and so it is false. That which implies falsehood is false. And then we ask them, okay, what is the supposed experiment? What is the observation, and what is the supposed experiment that substantiates, that justifies the assertion of mass attracting mass gravity? And in these conversations, and they come in here, rarely do you get a coherent, cogent explanation of that.
He was talking about the vacuum chamber, and I did post this. And this guy talks about buoyancy inside the vacuum chamber, and talks about empty space, and goes up. So density and buoyancy still exists inside. And when they release two objects inside this vacuum chamber, if there was a mass attracting mass, why these two objects don't attract each other? Because they are, that experiment they do, they are close to each other, so it doesn't happen.
But yeah, and that's an excellent thing you just did, Miguel, that you've done repeatedly. So that's what I tend to highlight when investigating, when scrutinizing an assertion. Is the description, the explanation, the a priori theory coherent in the first place? What does it presuppose? What does it imply? If it presupposes that which is an unjustified presupposition, that if it implies an absurdity, if it implies falsehood, then that demonstrates that the assertion itself is false. And so that can't be substantiated. You can't give an experiment that substantiates this. You can't give a justification for this assertion if the assertion reduces to absurdity.
And I don't know, Matthew learns or never learns, because we did show to him a lot of stuff about fake pictures from NASA, and this guy keeps coming with new Earth pictures from NASA. I mean, he did bring one. It has pixels, red pixels, and so at that time he was speaking to Clay Underseal, and he said it could be faked, but he just keeps doing the same thing, bringing the same things. And these guys, when I present this rat in that space rocket, they, the cognitive dissonance is so big that they prefer to say it's ice or debris. They just don't want to accept the truth. It was made on a studio, and half on a studio and half is CGI.
Mm-hmm.
Ice in the vacuum of space.
Yeah, Mickey Mouse. And we have, those guys, Rammstein, those guys from Germany, and they have a video, a song. We all live in America. America, I think, is the real title, and they are showing to us how to fake the moon landings. I mean, literally,
Wickedness.
it can be made on a studio. So, I mean, and Germany never went. They never claimed that they went to space because they know the truth and they don't want to spend money on fake.
And I'm just some average working poor person. Like, I'm not in these laboratories. I'm not in the academic halls. So there's plenty of things that I don't know. And so these persons who have been through academia, who are in the industry, right, and have gotten their graduate degrees, you should have this prepared, like been prepared years ago. Like, you should be able to cite to me on a dime what the supposed experiment is that demonstrates the supposed reality of this supposed law.
Exactly. They talk to us in documentaries the theory of gravity, and this guy is saying there is not it's not a theory. It's an observation. I mean, if it is not a theory, then it was supposed to be a law,
Right.
like the law of thermodynamics, and it's not a law. Why?
And correct me if I'm wrong. The experiment is supposed to be, you got the independent variable, dependent variable, controlled variables. The independent variable, isn't the independent variable supposed to be the manipulation of the massiveness of the particle or the object, whatever you're holding, and then the dependent variable is, right, the effect it's supposed to have on another object. So when was that done? Because if the cause of the effect is the massiveness of the particle, then the massiveness of the particle, whatever object, must be manipulated, increased, decreased, so as to see whether or not it will affect the other object to pull it towards the particle, the object, under the manipulation of its massiveness. When was that done?
They present this, this. Let me post it. They present this, but then sorry, I'm waiting. These planets crush each other in the middle.
That's why I don't let people talk about gravity and magic mass and Cavendish. Can't even talk about it because it's just imagination talk. So we don't talk about imaginations too much.
I mean, is it even possible to increase or decrease the massiveness of any object? Is it possible for us to do that? Because if that's not possible, then of course the experiment can't be done. And so it hasn't been experimentally, mass attracting mass gravity cannot be experimentally verified or falsified.
That's correct. Unicorns cannot be falsified or verified. So we just leave it at that.
In this vacuum chamber, this link I just posted, does a vacuum chamber wake less? I think, but it changes around the objects, so the medium around. So and there was a a physician. Sorry, let me get it. Gravity. So this guy, he says gravity is a theoretical physicist, Eric Verlind. So he says gravity doesn't exist, and he talks about buoyancy and density, even magnetism.
We have long known that Einstein's theory of gravity doesn't work with quantum mechanics, though all other forces do. Gravity simply doesn't exist. It was designed along with dark matter to support the centric model. Density, buoyancy, and magnetism react in the medium air, water, helium can adequately define gravity. Verm Blotter. What is this quantum mechanics stuff? I have yet to have heard a cogent explanation of what it is. And how much of quantum mechanics is observational and experimental? Or is it just a priori? Is it just theoretical? Because as far as I know, right, no one has yet to observe, let alone grasp, either with their hand or any other tool, a single subatomic particle. We don't have any empirical sense experience of a subatomic particle individually.
That is interesting because 20 years ago, a Portuguese physician, and there was a teacher there, physician too, a teacher. In Portugal, we say physics and chemistry. We have the same the same teacher. He did ask to her, did you ever saw an electron, an atom? And so how can you claim you know what you are talking? So that was interesting.
And I'm not an empiricist. You can give a rational explanation of things, but it must be justified. So, if you haven't had any empirical experience of the thing in question, okay, fine. Then how else do you know that this thing is real?
By the way, I saw something talking about, in the school we learn about these electrons, circling around, but in nowadays it's like more a wave, so there's vibration. So yeah,
right, vibration, oscillation, perturbation, right.
And they even found between the stars there when they use I don't remember the device, but they are connected is with something between them. So, and we watch this firmament and these stars all the same distance between each other. So yeah, and something is going, it's holding this. And even the Egyptians, they draw. Let me get it. Firmament. They draw a woman, curving, and in this woman there was the stars.
Yep.
Let me
Yep. The
get
sky
it.
god and the polytheistic worldview. Yep.
So
Yeah. The nations throughout the millennia, throughout the ages, knew that there is a container, that the sky is the container.
So I have this. So this was the representation of the firmament,
Right. Yep.
and you can see the stars, and you even see it blue in this firmament. And there was an helicopter pilot. I talk about this guy, and he talks about this blue sky ice. They are studying in the white ice samples. They just study that when the National Geographic are going there to film. So because the real thing, the sky ice is what they are studying there.
Well, Miguel, thank you for your company.
Okay.
God bless you all, and good night.
Cheers. Nice to talk to you. I'm going out. See you later.
Earth to Rocket Man. Earth to Rocket Man.
Rocket Man, go for Rocket Man. Rocket Man here. We're nominal.
How's outer space treating you, brother?
Well, every time I pass gas, I don't have to deal with smell and it dissipates.
It fills the available space.
Yeah.
Which is a pretty big area. My good hell.
Yeah. I got farts all over the car.
Passes right by Uranus, don't it?
Oh, yeah. A lot of gas in there.
Or rather, it comes from there. Pretty slow, I guess. I fell asleep in my right recliner. My headphones hit the floor. And I was trying to test my mic because I forgot I put my headphones up. And I was like trying to hear it on the speakers. And my mic was muted and my headphones were plugged in. And so I'm sitting here talking to myself, going, I wonder what's going on.
Oh, that's funny.
I know. I just woke up out of a dead sleep. Like, duh. A little dazed and confused, I guess, for a moment.
Sure, man. I'm just up here running around.
So, Matt, I don't know. Do I know you? I don't.
Not really. God rocking. Probably spoke to you a few times, but yeah.
Right on.
Dog, I think you're up there in Utah, right?
Yeah.
Yeah, we talked about like the drought and stuff we got before.
Oh, I see. Right on.
Oh, then I'm down here in Tejas.
Tejas, huh? Right on. It's been pretty hot down there.
Yeah, last week or about a week and a half ago, it was really hot. It seems to cool down maybe 5 to 10 degrees, but it's still pretty warm.
How hot did it get?
The index was like 110.
Oh, damn.
Yeah, I can't remember the actual temperature. But I'm kind of one of those people, I don't watch the weather or anything. If I want to know what it's like outside, I'll stick my head out the door.
Yeah, I don't ever watch the news or anything, but I've got this little weather app on my computer that's well, when I click on it, it brings up my area. So it gives the daily and weekly forecast. You can just read in temperature, expected temperatures, all. You know what I mean? You've probably seen little thing that flashes up, and you got the forecast on it. So that's where I get my weather info, off my little computer app. So I don't watch the news either. I can't stand the news anymore. It's been I turned my cable off about 3 years ago. So the only stuff I watch I got my TV's hooked up as a second monitor on my computer desk here, so it's drag and drop onto my big screen up there, and sometimes I'll watch a YouTube fight or something. Watched some of the fights yesterday. Saturday night was the UFC 276. I don't know if you're into UFC fights or not, but Do you watch cage fighting at all? UFC stuff? No? Yeah, no, maybe.
Sweet.
Huh?
And
Yeah?
I like boxing. I don't follow the UFC too much. Say what?
I was
Can
just
you hear
wondering
me?
if you, yeah, I was just wondering if you watched UFC fights, is all. Yeah.
Oh, I
You're breaking up.
don't watch. Man, sorry about that.
It's all right.
Boxing.
Yeah, you're into that more.
Yeah.
Yeah, I watch
Yep.
both, but there's, yeah, I watch both. I was a boxing fan for many, many, many years before. Back when, I don't know how old you are, but back in the day when Sugar Ray Leonard was the champion and he was fighting Hitman Tommy Hearns and Marvin Hagler and, all those, and Mike Tyson was fighting. And I used to go to the closed circuit TV, go down to the Salt Palace in Salt Lake City and pay, $50 or whatever to go in and watch the fight live. 'Cause they didn't have computers back then where you could just watch it on pay-per-view or anything like that. So you'd had to go to a stadium and watch it on a TV screen, pay $50 to get in and watch it. I used to do that. I watched almost every Mike Tyson fight live. That way, would go rent or pay to watch it at a sports bar or something like that.
Yeah, man. Yeah, I guess I'm pushing 40, so I know all those old legends. Did you watch that? Well, I guess you like Tommy Hearns. Tommy was something else, man.
Yeah, he was. Yep, Tommy Hitman Hearns.
Yeah.
Him and Marvin Hagler was something else too. Yep. Roberto Duran,
Oh, yeah.
Hands of Steel. They used to call him.
Yeah. Yeah. What is it? I can't remember how to say it in Spanish. The Hands of Stone.
Yeah.
He was awesome, man. Very,
Hands of
very
Stone.
underrated.
Yeah, Hands of Stone. That's what it was. Right. I said
Yep.
Steel, but yeah, you're right. It was Stone. I stand corrected.
Yeah, a lot of great fighters from back then, man. I think Larry Holmes is really underrated. People don't understand how
He was
awesome Larry Holmes was.
Oh, he was awesome. I mean, he defended his title probably more times than anybody else that I can think of. I don't know, but he was around for a minute. Let me tell you.
Yeah, he was the champ for like 10 years.
Yeah, that's what I'm saying. Yep, he was really good. No, but it was almost some of his fights were almost like they couldn't touch him. He'd just go the whole fight, just beat the shit out of people, and nobody could even touch him for the longest time. Really good. Yep, he was one of the good ones. Big, tall, lanky dude. He was good. Oh, you're chopping up really bad, dude. I can't. I don't know what it is, but you're still
got some
chopping
favorite
bad.
UFC
Oh, there you go.
fighters now.
I can't. You're breaking up bad, bro. I can barely. What's up?
Yeah.
You're roboting real bad. Test. Okay. Hey, Flatterday. I heard you try to say something, but it was roboting real bad. I couldn't understand you, brother.
Yeah, I accidentally had it on.
I heard something, but couldn't understand it, bro. Sorry.
Can you hear me?
I did that time. Yes, sir. I did that time. Maybe it's me. I'm
indicator that the Earth is moving and it's not stationary.
No, I don't think I need two Earths. I think I just need the modus tollens, which is that if the Earth is stationary, it will not diverge, and it does diverge.
Yeah,
therefore, it
but
can't be
how do you
stationary.
know? How do you know it doesn't diverge on a stationary Earth?
Due
What
to
if there is?
Newton's.
What if there is some magnetic phenomena that we are not aware of, or we don't know? I mean,
What if it-
literally ask the illiterate people, because the literate people, they do know. What if there is some magnetic phenomena which actually makes that pendulum deflect? I think you mean deflection, not divergence.
Diverge and
Well, they are
deflect.
driven by motors and magnets.
Diverge and deflect are the same thing. They're synonyms. And plus, the pendulum isn't made out of a magnetic material.
Yeah, it is. Read the
No, it
manual.
isn't.
It's driven by
Diverge.
magnets.
Diverge means to spread.
Yeah.
It's synonym with spreading.
Yeah.
But deflection means to change direction.
Yeah.
It's not a synonym.
As I am using them, they're the same.
Well, as you are using, yeah, but
Yeah.
you're using it wrong. Anyway.
No, I'm not.
You guys are desperate for a Glober.
Yeah.
Right.
So
it diverges or deflects from a straight line.
So is there anything else that the Earth rotates under, or just this one pendulum that's driven by magnets?
The pendulum isn't driven by magnets.
Yeah, it is.
You don't
If
know
you-
it very
hold on,
well.
hold on.
Some are.
Look at-
Some
hold on.
You don't know your globe proofsy very well,
Guys,
do you?
Guys, hold on. Brenda, would you please look into the live stream voice text if you're
Yeah,
able?
I see it.
I
I see
just
it.
posted a link from the Smithsonian Institution about the Foucault pendulum they have there. They say there's an electronic device, an electromagnet in it, and you're saying there's not. So who's wrong?
I'm not talking about that one.
Which one are you talking about?
Yeah, can you tell me the
Brenda.
name of the pendulum you're talking about?
Any pendulum.
Where is it? Okay, well, I tried to make a pendulum, and what happened was it ended up diverging in different directions when I.
Therefore, the Earth isn't spinning. Then,
But
I mean,
he's
the
changing
Earth is
the
stationary. If it diverged, then it's.
You know, the Earth has a electromagnetic field that could also be the reason why a pendulum.
Well, not if the pendulum is non-magnetic. It can't be.
So do these pendulums start themselves, or do they have to be started, Brenda?
They eventually just come to rest, right?
That's not an answer to the question.
That is an answer. He said. He asked
No,
if
he
they.
asked,
I
he
said
asked,
they
do you
do.
have to start them, and you said, well, they eventually come to rest.
No, he asked
you
if
have to
they
start
stop.
it.
No, he asked if they stop.
No, you might have
do they
misheard the
start?
Scottish accent.
Yeah, I did
Yeah.
misunderstand him.
Okay, so how do these start? Do they start themselves?
No, you have to start them.
Right. So, and then if you look at what's been posted, you'll see magnets and more energy is needed to continue them on their swing. Or
I'm
they
talking about
come to stop.
I'm talking about pendulums that don't have magnets.
No,
Okay,
you're
so
talking about
saying,
Foucault's
hold on,
pendulum.
hold on.
That's
Okay.
what you said
Can I
to
ask him
start
to-
with.
can I genuinely ask him something, please? You're saying that whether it's the rotation,
Well, he's lying.
what are you saying is happening, causing the pendulum to swing back and forth?
Well, there is a Coriolis force applied to the pendulum, which causes it to
Coriolis.
diverge from a straight line.
Coriolis is a
Right?
force. When did
Coriolis
it
effect.
become a
Yes.
force?
Coriolis is a force,
No,
right?
it's an
not.
effect.
It's an apparent deflection.
Yeah, it's a pseudo force.
not a
Yes, you're right, but it's still a force. It's a pseudo force, but it still counts as a force.
Pseudo
No,
force
it's an
is.
effect.
How can you say
So wait, is
a
Coriolis
pseudo
is this
force is a force?
gravity? Is Coriolis
People are-
density, gravity, magnetization?
No.
What is it?
Coriolis is conservation of momentum.
But so then you have
Um,
to initiate the movement for it to keep going. You're talking about perpetual motion.
I'm not talking about perpetual motion. I'm talking about the motion of the bob on the pendulum,
It
right?
should be. Surely, if it's affected by the Earth, then surely it should be perpetual. We should be able to harness this
Why would it be
energy.
perpetual?
Because the Earth's constantly moving. It's in your model.
According
Welcome to Globe Earth.
You cut out there, sorry.
According to the Coriolis force, wow. Okay, I just don't believe that at all. Honestly.
Coriolis is Coriolis. It's a pseudo force.
Brenda.
Well,
rotation, orbit around.
You're roboting. You're roboting.
Yeah, you're roboting hard, Sasha.
Can you hear me now? Can you hear me now?
Yeah. Yeah.
As always, as soon as you ask, "Can you hear me?" now, people stop roboting. That happens every single time.
Listen to this. This is what Google says. If you don't like Google, I'm sorry, but it says in physics, the Coriolis force is an inertial or fictitious force that acts on objects in motion.
Yeah, that's
within a
correct.
frame.
Yeah.
So that means this is a theory, right? Because this is literally using the word fictitious.
Yeah. Yes, it's a pseudo force or a fictitious force. Yeah. That doesn't mean it isn't real.
But is this? Are you subscribing to this? Are you willing to look beyond this?
No, they say I will raise my hand. I will raise my hand. My hand is upraised. I don't have a Bible with me. I will swear that was accurate. It's an accurate. The Google definition that the guy just read is an accurate.
You can swear on the globe.
Definition of a Coriolis force that I subscribe to.
Can I tell you something, man? You don't have to swear on anything. This is just like we're just exploring stuff. Like
I'm just being
I have
a
a
little
quick question for the audience.
When you hear it,
Dude, I'm just being a little lighthearted to sort of cut the tension. That's all.
That's great, and that's fine, and that's fun. I just have a quick question. I'll go away. Listen, I'll have a quick question, and I'll go away. Brenda, what's the opposite of fact?
A fiction.
Thank you.
Right.
As you were.
I don't
Yes.
even like using Google, but you know, the fact that they put the word fictitious in the definition of it is crazy to me.
It started out here that your proof was Foucault's pendulum. You found out that they're driven by magnets, and then you shifted the goalposts to, I'm not talking about that pendulum. So which pendulum are you talking about?
I'm talking about all of the pendulums that don't have a magnetic device attached to them.
Foucault's pendulum. What you started with. So not that.
Those are Foucault pendulums. They're just ones with.
Okay.
Okay.
One moment.
So-
One moment, please. Brenda, you said you're talking about all the pendulums which do not have a magnetic device attached to them. Now, I personally debunked the Foucault's pendulum, and I can teach you how to do it
When are
very
you?
easily.
Sure.
You make a pendulum, and
When are you picking up your Nobel Prize? When are you picking up your Nobel Prize in physics?
no, I'm not interested in
Oh,
Nobel
you'll
Prizes.
do that if somebody can prove.
Well, because you refuted Foucault.
What? When are you going to get yours?
If you want to get one, you do so. You try to
You
do so.
refuted a major conservation
I'm not going.
physics.
Look, listen.
Why don't you measure some
I tell
Earth
you what
curvature
to
and go
do.
get your Nobel Prize?
Can I finish at least?
Sorry.
Yeah, I've got a question
Yeah.
after you. Go for it, bro. Go for it.
Now, when you change the pendulum's weight, yeah, if you use like iron balls, lead balls, yeah, you will observe that pendulum deflection. But
The pendulum
if
what?
you put,
I didn't hear you. I didn't hear you. Could you repeat that?
when you use a pendulum which has a iron weight or lead weight metal, yeah, which you are swinging, you will observe that deflection. And the funny thing is, iron, gold, and lead they don't deflect at the same rate. They show different deflection ratios. Now, the thing is, when you change the weight with two opposing magnets, yeah, you glue together two opposing magnets and you use those as the pendulum weight, you will see that you swing them from left to right and they will swing in that way and they will not deflect. How
Why
do you
would I?
explain that?
Yeah,
How do you explain this?
yeah. I would not use magnets because they could be affected by any magnets or metal that's around it, and I
So
wouldn't
you would not
use.
use the proof
No,
that
you
you
are not
cited, which is
around
Foucault's pendulum.
metals.
Well, suppose I don't know that. I could be.
Magnets can be affected if you have some metals close enough to
Or
them,
they could be
or
affected.
strong magnets close enough. But if they are not close enough, yeah, they are just magnets.
Could they be affected by the Earth's magnetic field?
Aren't
Wouldn't they? Wouldn't they be?
all magnets in the world in direct?
So I wouldn't use magnets because they would be affected
They
by the
are
Earth's magnetic
present
field.
in. Listen.
So then you wouldn't use
When
Foucault's
you hold the
pendulum, which is the
magnet
thing
in
that you
your
cited.
hand, when you hold the magnet in your hand, that magnet is being present in the world's gigantic magnetic field. So it's already present in the magnetic field.
Right. So I want to eliminate that variable, so I wouldn't use
You
magnets.
can't. You don't
that
have.
eliminates the
You
proof.
don't have a place. There is no such place in the world where you do not have
I would just use like
the world's magnetic field.
I would just use a material that isn't affected by magnetism, like say concrete.
Yeah, but then you wouldn't use
okay.
Foucault's
In
pendulum.
a concrete chamber, a room, a concrete room.
Concrete plumb, the concrete, the ball at the end.
And you make this pendulum. You make this pendulum with you glue together two magnets. Yeah. And you hang them on that wire and you swing them and you will see that they are not deflecting.
I would not use magnets because they would be affected by the Earth's magnetic field.
Why the magnets do not deflect?
Probably because they're affected by the Earth's magnetic field.
Well, I'm not asking about probably.
You did.
I'm not
You
asking
did
about.
ask me.
No, I ask you if you know.
I would say that's
How do you explain if you know?
I'm saying that's most likely the explanation.
Well, obviously you are not an expert in Foucault's pendulum to know that it's actually a scam. Yeah.
How is it a scam?
Yeah. Official scientists, they explain how Foucault's pendulum is a scam.
Who?
Scientists.
Which
Physicists.
scientists?
Quantum physicists.
No, they
You
don't.
just agreed that it's
Yeah,
not
they
proof
do.
anyway.
No, they
He just
don't.
agreed that it's not proof anyway, though, because he says that he wouldn't use a magnetic pendulum, which is what Foucault's pendulum is. So next.
Foucault's pendulum is not magnetic.
It is, buddy. Read the manual and
isn't.
check the live stream voice text.
No,
it is
it
driven
isn't.
by magnets. Yes, it is. You're just wrong. You don't understand your own proof.
And
Brenda,
Read the manual for it.
that's just for their pendulum. That's not for
that's for Foucault's pendulum. That's how that works. That was your proof.
That's not how
you didn't
things
know
work.
it was magnetic. You've now admitted that you wouldn't use a magnetic pendulum, which is what your proof is. So you got to move on now.
Proof isn't that
Brenda,
it's a magnetic pendulum.
Brenda,
It is driven by magnets. Check the
Brenda,
live
you
stream
said,
voice.
And more.
Brenda, you said in the beginning that you're not talking about the Smithsonian pendulum, and then you said you are talking about all other pendulums except that one. Yeah,
Right.
the
Those,
Smithsonian.
I said
And
not
now, when I presented you,
just a minute,
when I presented you a pendulum, which does not use magnetic devices, it uses two simple magnets. That's all it uses.
I would not use that one because in science.
Well, you will not, but you have to explain what's happening.
Because
why? And listen, when you put two magnets, listen, Brenda, when you put two magnets which attract each other, yeah, and you swing them, those magnets will deflect like any other metals, like all other pendulums. But only when you put them the way they repel each other, that's when you do not observe that deflection anymore.
I would not use magnets, period, because
you will not use magnets.
Okay.
Yeah, because it debunks
because I want to do a proper scientific experiment where I eliminate all possible confounding variables.
Okay,
yeah,
Brenda,
you haven't eliminated the magnetic field and the electric field, yeah?
I've
ground is
eliminated
negative.
things that are affected
Listen, we live
fields.
Between two Gaussian planes, yeah? The ground negative and the sky positive.
You haven't got, that's not what I'm testing for. And we don't live between two planes.
Listen, you exist inside a magnetic and electric field.
That's your claim.
No, it's not my claim.
That's
this is
measurable.
scientifically explained.
That's why I wouldn't use magnets.
Fact.
That's why I wouldn't use
fact, Brenda. No, thunder strikes from the cloud.
That's why I wouldn't use magnets.
Brenda, basically you're saying that if you don't use magnets, then you're not using Foucault's pendulum as one of your proofs. You're using what, John Smith's pendulum, or
that's not what I'm saying.
Or like who?
That's not what I'm saying.
You're saying, well, basically the information for the Foucault's pendulum is in the live stream voice text. You could take a look at it and see that magnets and motors are used, and it has to be
That's just the Smithsonian. That's just the Smithsonian one.
No, I just posted another one. Hold on. I just posted something. The original Foucault pendulum was a lead bulb with brass. And then I posted a link from an educational site saying lead can be affected by magnetic field. So the original, the original Foucault pendulum used a material susceptible to being influenced by magnetic fields. The end.
So did he have
but all those metals, all those metals, lead and brass, they are both very good electroconductors.
Yeah, but they are not affected by magnetism.
Electricity. Well, they are affected by electricity, by the electric field that they are present in.
Okay, let's move forward. Let's move forward, because now we realize that one device can how to say, we can with focus pendulum we can realize that it's earth rotating. Let's go out and find out is that true.
Well, Brenda,
I'd like to point out a logical fallacy.
How do you explain? Sorry.
Brenda reduced his own argument to a lie.
She tried to use the modus tollens, as in, she actually used an inverse fallacy. If not P, then not Q.
It's not the. I didn't make a fallacious argument.
Yes, because you did say.
I said if P, then Q, not Q, therefore not P. That's what
Hold on. You inversed it. Just let me finish for a moment, please. She inversed it because she was trying to escape assuming the consequent fallacy.
Modus tollens is not fallacious.
You inversed it. It's an inverse fallacy.
If P, then Q, not Q, therefore not P. That's modus tollens. That's the argument I presented.
You are saying it as in, if not P, then not
That's not what I said.
Great.
Yes, it is.
P, then Q, not Q, therefore not P.
Thank you, Brenda.
Yeah, electric. Okay, he told you. Maybe he misspoke. Yeah. So it's been clarified. Get over it.
Brenda, hold it. But can you explain, Brenda? Can you explain the Elias effect with these pendulums during eclipses?
I don't know what that is.
That's where during eclipses, supposedly these pendulums alter their swing. And
has anybody been able to reproduce that?
Well, I mean, Google's
no, have they? Nobody's been able. Has been able to reproduce. I understand. I'm familiar. I'm familiar.
I thought you never knew anything about it.
Nobody has been able to reproduce it, have they?
Apart from who?
Elias.
So just one person.
Right.
Then
so it hasn't been.
You know every person in the world has done this.
It's been tried. Nobody's been able to reproduce it.
But so why is it even a thing? Why is there people arguing it?
Well, people aren't. Not real physicists aren't. Nobody's arguing it.
What's a real physicist?
Yeah, nobody's arguing that.
No, but what's a real physicist? Like, as long as they believe in gravity that can't be proven experimentally.
Right.
That these pendulums swing by themselves and like all these things that you have to have faith in.
So the definition of science is repeatable, right?
That's a method.
Repeatable. No, the scientific. Yes, that's right. Repeatable, falsifiable, verifiable. That's what science is. Repeatable, falsifiable, verifiable.
Brenda, if that's the case, then where's the experiment for gravity?
What? Oh, people do that every day at Cavendish.
That's not an experiment.
Yeah, it is.
Follow the scientific method.
Yes, it does.
What's the independent variable for Cavendish?
The distance.
The distance.
Yeah, the distance between.
Your distance is your cause. That's what you're saying.
Yeah, you vary the distance,
your
and
cause
you
was gravity. You may be proving gravity, no distance.
Gravity varies with distance between the centers of the two masses. So you vary the distance, and you vary the strength of gravity.
Oh, did you prove gravity before you claim see, before you actually do claim gravity does things? You can't just say, well, gravity does this, so I'll do this experiment because gravity does this. You can't just
it's a formally valid experiment, right?
Okay. How did you isolate gravity from the electromagnetic forces?
The independent variable is the cause. If you're proving gravity, then that's your cause, obviously. No, your distance.
Well, the IV doesn't have to be the direct cause. It could be an indirect cause. So indirectly, by varying the distance between the two masses, you'll vary the effect of gravity.
Well, you never proved gravity in the first place. You can't claim
gravity is defined. Gravity is defined as proportional to the distance between the centers of the two masses.
And was it defined?
You're defining the thing you're trying to prove.
That it was defined before it was even backed up by experiment.
Right, because Newton was a genius, so he came up with. Yes, Newton.
Fuck Newton. It might not have even fucking existed.
So Newton defined gravity as a force that varies with inverse proportion to the distance between the two masses.
But it's not a force. It's not a force. According to Einstein, you've not got a force anymore. It was supplanted by Einstein, I say, over a century ago, man.
It's a inertial force. Yes, you're correct.
So it's not a force, but it's a force.
It's a pseudo force. Gravity is a pseudo force.
Again,
so Brenda, what's the difference between a force and a pseudo force then? I mean, this language is very confusing and very hard to follow. What's the difference?
I can explain it to you. It means that it's not fun. This means that it's not fundamental. That it is caused by other underlying physical properties going on.
Okay, so what's the underlying thing for gravity? What's the real force underneath the pseudo force of gravity, or whatever you're
the bending of space-time.
Whoa, concept. You're giving concept.
For me, it sounds like there's a ton of questions, and for every question, you have another explanation, and that needs an explanation, and that needs an explanation. It's like it's just never ending with the fucking.
That's true. Well, it does end. It does end at a certain. There is an ending.
Brenda, where did space and time these do concepts? Where did they get physical properties and be able to stretch a conceptual medium?
Space-time is not a concept.
Space is a concept. Time is a concept.
Yeah, but
space-time together. Who proved this?
Space-time is a different from space and from
proved it?
time.
Who proved it with experiment? Following the scientific method, tell me.
Eddington.
By?
Observing the bending of a distant star past the sun at the prescribed amount.
Does that include the photographic slides from the second telescope where it didn't bend around the sun?
No.
So, right. So
there were two telescopes,
he showed
right?
it doesn't matter, right? So they
Yeah,
showed
it does matter because they had a bunch of photographic slides and they selected the ones where the light was bending according to their theory, and they threw out the ones that didn't match. That's called cherry picking. It's bullshit.
No, that they were thrown out for other reasons because they were just not good. They were just not good
What
slides.
reason?
Come
I'm
on,
just saying that
Brenda.
space-time
Take
is
a
a
moment
real
to Google. How about that?
I mean, like,
I do
I
not
just
have Windows open.
dude. Like,
Well,
you're
that might
So
be
being
we have
presented,
space-time
you're being
being a
presented
real
with
medium.
information.
I
that kinda
can't hear
can't
when
apply.
everybody talks at once. I can't hear.
I'm just trying to say one thing. You're being presented a ton of information that doesn't align
people, please. One at a
with
time.
like the basic model of the globe Earth. Like, you have to try to look past this shit for a second, bro.
Gravity doesn't have anything to do with the globe Earth or the geometric shape of the Earth.
Reasons, by the way.
Of course
What
it
reasons
globe
did
needs
they have for throwing away the slides? You said they had reasons. Can you specify?
No, I can't.
So why did you say they have reasons?
Because I just assumed that they did,
All right, fair enough.
and because they did subsequent
Brenda.
observations afterwards. There have been other observations.
But can you remember when I asked you for experimental evidence for space-time bending and you gave me an observation? That would just be an observation. It's not an experiment. You cannot manipulate what's up in the sky,
Observation.
trillions of light years or whatever away. An observation's not an experiment, Brenda. Come on.
Sure,
It's part
sure.
of the process, but you can't just say, oh, I saw something and I assume this and it backs up what I already believe, so fuck it.
Well, there have been plenty of other observations, and observations are used.
Bro, so sorry, Brenda, I'm asking you specifically for an experiment following the scientific method that proves the existence of this space-time.
Right. So observations are perfectly good for
You're still not
giving
giving me
contradictory.
Can you give me an experiment rather than waffling
I don't.
about
Observations are perfectly acceptable for giving confirmation evidence, confirmatory or disconfirmatory evidence to support or otherwise refute or disconfirm a theory.
Brenda, come on now. I asked you for an experiment.
I don't have to give you an experiment. I can give you observation.
You don't have one at all for either gravity. You literally have nothing apart from
That's not true. No, that's not true.
Dependent, independent variable and a viable hypothesis. No,
I already gave it to you.
Distance is the independent variable. Come on.
I already gave it to you. It's the Cavendish.
The IV is the cause.
Yes.
When the distance is not the cause, you're trying to prove gravity, not distance.
If the force varies with if the force varies in inverse proportion to the distance, then varying the distance would be varying the cause.
What force?
The force of gravity. It's a pseudo. It's a pseudo force. It's a pseudo force.
Exactly. So
I'm a pseudo doctor, Brenda.
It's a different sense of the word.
Right, but what the problem is, what he's basically doing is saying there are invisible pixies pulling things down. If there are, then my lighter's gonna drop. Here, look, it dropped. So there must be pixies. This is literally the argument he's making.
That would be affirming the consequent, which I've not done.
Which is what
that's what you've done.
I used modus tollens. I used modus tollens, not affirming the consequent.
You're affirming the consequent if you're saying that the
no, I'm not.
If you're saying the distance is the IV, and you're claiming that distance,
Not affirming the consequent. That's the IV.
Your IV is your cause. You're trying to prove gravity, not distance. I never
Yeah.
asked you for an experiment to prove distance, did I?
Well, we know that the distance,
You
or
don't
at least
know. You've not proven anything. You can't claim shit before you've proved it.
that's the hypothesis. The hypothesis is that the strength of the force varies in inverse proportion to the distance between the masses.
And the hypothesis has not
There
been
is
proved
no
until the
force.
experiment is finished.
So then, if you vary the distance between the objects, you are varying the IV.
Wait, hold on. That's
never
not
proved
true.
this
Wait,
in the
isn't it?
first place.
Isn't I thought it had to do with like wind and air pressure. That's what like the amount of density in the object doesn't change how fast it's going to fall to the earth. It's supposed to be like the amount of wind or something. Am I incorrect?
I'm not talking about things falling. I'm talking about gravity.
Oh, I'm sorry.
Why
I
do
thought
things
gravity
fall?
is the property that makes things fall.
Gravity is the property of two objects having
Imagination.
mass being
Gravity is a
having.
theory, by the way.
Just
So none of
please.
this is
That would
Yeah,
be
it's a scientific theory. It's a scientific theory. It's not
Brenda,
just something.
No, it's not. It's not scientific
Okay,
whatsoever.
the scientific
There's no
experiment.
scientific experiment. You've not got science in either gravity. Neither of them are a theory.
I
just wanna
told
speak
you.
just real fast. Hold on, Brenda, just real fast. I want to put something in there. So, flat earthers are the ones that claim that things fall down, right? What the globe earthers are claiming is that balls circle each other in the sky like a perpetual motion machine without ever like falling away from each other.
No, that's not
and they fall
perpetual.
like- oh, really? When's it going to end?
Eventually,
Millions of years. Is it like 5 million years or some shit like
yeah,
that?
some shit like that. Yeah, something like that. Yeah.
I'll put that on my calendar, man, just to make sure.
Yeah, it takes a very long time, but eventually orbits decay, right? And the object will fall to the heavier object.
When did anyone ever prove anything of the sort when you're talking on time
With the
scales?
Cavendish experiment. With the Cavendish.
Okay, how does Cavendish isolate gravity?
Doesn't
How does Cavendish isolate gravity from electrostatic forces?
Nah, he thinks
by using non-magnetic materials. That's how.
You know the laws of
What
natural
was
density
the
explains
observed natural
everything.
phenomena?
Like you don't need all this like explanations of gravitational pull and buoyancy. Like you don't need all that to explain it when you have natural density.
And
Density is not a force.
Forces are present in all intermolecular interactions.
Yeah, but nope, that doesn't matter.
What did you do to
So
isolate? Yeah, what did you do to isolate your Cavendish from that?
from matter,
buoyancy is a force.
Buoyancy literally contains gravity in one of the terms of the formula.
Yeah, even though you've not proved gravity.
Prove it.
Yeah, it's literally in the formula. Another word for buoyancy is another word for
made up formulas.
It's not made up. It's based on observations and experiments.
Observations.
Who made the formula?
You've not got
I
experiments.
don't know who
though.
came up
All
with
you've
the
got is
formula for buoyancy.
Man wrote it. Isn't that the same reason why you don't believe in historical books, right? Like the Bible.
Well, humans do science. That's what humans do. Yeah.
Globers don't seem to want to do any science.
So
we do. What are you talking about,
Brenda?
Yeah, well,
can we
gravity?
On the same page?
You're trying to say
Well,
Cavendish is
if I
scientific.
could not be interrupted for once, gravity
I'm not
is
trying
an
to interrupt
apparent.
anyone.
Gravity is an apparent force of attraction between objects having mass.
Would that be Newton's version of gravity?
Yeah,
So what about Einstein? He supplanted Newton.
it's more or less the same thing, except
More
that
or less.
We got three space and then four space. Is Newton got a four space continuum space time? You said it's the same thing, right?
I said it was.
Is Newton got four space? So
no.
here's the deal.
So you ask me questions and then you keep talking. Could you let me answer
Make
you?
him answer that. What? Make him answer
Go
that.
ahead.
Right.
Go ahead.
So I don't think Newton had the idea that space and time were separate. Einstein unified them into a new thing that's separate from both, called space-time. It's neither space nor time. It's neither space nor time.
Okay, so it's a fabric,
It's
right?
like a super concept.
It's a fabric. What is this fabric made out of? The space-time continuum.
Well, there are people that think that space-time itself could be the result of underlying physics properties going on, but that hasn't been confirmed yet. Basically, there are people working on theories that would explain space-time as an emergent problem.
You're willing to accept all these changes to these scientific theories?
Yes, because that's how science advances.
So what exactly? What your like stream of information? Who do you trust? Like you're just trusting whoever is just giving you heliocentrism?
I will trust official sources, and I will trust physics books and
official sources.
Okay.
Yes.
So appeals to authority.
So what about
No.
reality?
Nothing empirical.
Brenda,
No,
Brenda,
I
do you
appeal
not
to
trust reality? Do you trust the fact that you experience a flat stationary Earth, that you've never seen any curve and no one experienced motion? Do you not trust your senses?
I don't experience a flat stationary Earth.
Well, you do. You've never seen curve.
No.
Apart from on
Yes,
TV
I have.
and on
Yes,
images.
I have.
You've,
Okay.
Where? When?
You've seen
At what
curves.
height?
Yeah, let's get those measurements.
Boats go over the horizon. Boats go over the horizon. That's curved.
The apparent optical horizon that is not geometric, that we can zoom the boat back in after it goes over.
You can never zoom. You can never zoom the boat back in.
Yeah, you can.
Seriously,
Check the live stream voice
Brenda,
text
see
right
if a
now.
boat, if a boat disappears at 3 miles, how small do you seriously think the Earth must be for it to go over the horizon? That is insane.
I mean, that's
all you have is incredulity.
I'm going to give you a new rule.
He just said that. He just said that you can never.
They shoot beams perfectly straight and level.
Said that you can
When
never
they're
zoom a boat
communicating
back
with
in.
other boats, whether they're 50 miles out, 100 miles out. These radio signals do not try to follow any curvature of the planet. So, like,
actually, they will bounce. They will bounce back and forth between the ionosphere and the surface of the Earth.
That would have to happen on a flat plane for a radio signal to hit an object and actually come back. It would have to be on a flat plane.
That's not true.
But now he's.
Yes, it is. You can look up the science of radio signals and all that. It'll tell you that. It's fine.
They bounce. Radio signals will bounce from the ionosphere to the land and back.
Atmosphere. I'm talking about objects.
Show us your dome. Show us your dome, Brenda. What dome? You call it the ionosphere? What's it made out of?
Electric, can I ask a question?
No.
I want to know what the ionosphere is made of.
I don't know what's going. I don't know what's going on.
Dome. Brenda's invoking some sort of barrier that these radio waves are bouncing off of.
The ionosphere. The ionosphere.
Is that like a dome?
It's no, it's not a dome.
But the radio waves bounce off of it.
It's a layer in the atmosphere.
What shape is it?
It's a layer in the.
Sphere, huh?
It's a sphere.
Do I get to answer your question? Do I get to answer your question? Or are you done yet? Just let me know. Let me know when I can talk. Just let me know.
If the atmosphere is circular, spherical. Sorry, I apologize. If the atmosphere is circular, wouldn't that be like a dome?
No, it would be like a shell.
It'd be like a sphere, but wherever you're looking up,
it would be like a sphere.
Semi-spherical dome.
Brenda,
over your head.
It would be a shell. So when do I get to answer his question? Can I answer his question?
You just said
the ionosphere.
I'm sure you could have said the question.
He asked me a question.
Well, answer it instead of asking if you can.
Well, if you could be quiet, please.
What do you mean? I just piped in because you're like whining that you're not getting to speak while speaking. But the point you made about boats going over the curve of the Earth, multiple images, zooms have been put into the live stream for you to take a look at if you want to go back to that, where these boats are brought right back into view again, and there's no obstruction whatsoever.
I'd like to answer the other guy's question first.
I know you'd love to just avoid the boats and images.
No, I'd just like to answer it first.
It's been nice talking to you, man. Maybe I'll run into you again.
So can I do that? Can I do that now?
Stop talking about it. Just do it.
Well, just let me know when I can talk.
You just could have said it there just now, but you're still whining. Why not just ask or answer whatever you want, mate?
Okay, so the ionosphere is a layer of charged atmosphere.
Particles.
It has a charge, right, in the atmosphere, and it reflects radio waves.
And it's a positive charge, yeah? Is that right? And then down on ground, the ground's the earth, like the ground part of the
Negative.
circuit.
Thanks for proving the dome, Brenda.
That's not a dome. A layer of charged particles isn't a dome.
Have you been up there?
You can fly a plane through it.
What is the speed of ionosphere?
I don't know. What the fuck do I know about it?
Well, it's keeping up with the Earth, so it must.
Is it ionosphere something around the Earth?
I guess so. Yeah. I don't know if it goes all the way around the Earth, but I guess so.
Okay, great. Because it's ionosphere. That means it's spherical. That ionosphere.
Yeah, just like the Earth.
Okay. What is the speed of ionosphere?
I don't know.
Well,
the radius.
For all I know, maybe it doesn't move at all. The air in it probably moves.
It's got to be keeping up with the spin of the Earth, surely. And if the higher it goes, it must be spinning. It must be going even faster the higher up there you go.
Can I try again? If ionosphere doesn't move, that means that air will go out from ionosphere.
Why?
Because there is something else, or everything is ionosphere after atmosphere.
I don't know what you're talking about, but the air.
Let's go back. Is it ionosphere something around Earth's sphere?
It's a layer in the Earth's atmosphere. The Earth's atmosphere is held to the Earth by the force of gravity.
That's not a force.
It's a pseudo force. Yes.
That's not a force. A pseudo force.
Yeah, but it's still a pseudo force.
So it's not a force.
Doesn't mean it. It doesn't mean it.
It's a pseudo force.
It's not. It's a different sense.
Demonstrated still.
That doesn't mean that
It means that it's. It means that it's not foundational.
So it's not a force.
Yeah, it means that I'm really not a doctor.
No, it means that it's
I'm an
not.
actual doctor.
It means that it's not a fundamental force.
It means that it's not a force.
No, it's still a
Literally.
force. It's a
not.
force. It's just not a fundamental force.
Oh,
It's the cool story.
my
That's why you
God.
weren't able to demonstrate it.
No, it is demonstrated with the Cavendish.
No, it's
You
not. We
demonstrated
didn't isolate from
distance.
confounding variables.
I did. We did. That's why the balls.
Distance. Brenda,
Okay.
you do it blatant, but you can rewind it on the live stream if you want. You said your IV was the fucking distance.
Yes,
No, the
you
cause.
vary the distance.
So that-
You vary the distance
not
between the two
cause.
weights.
Well, that's
What's
not
the
the
natural
cause, is
observed
it?
phenomenon?
The cause is the distance.
The force.
not
The force is inversely proportional to the
It has
distance. So
to be.
yes, you're varying the force.
No,
has
you're not
to be
varying
gravity.
gravity
Observed
from
natural
exponentially
phenomenon.
stronger forces.
If the strength of the force depends on the distance,
But-
and you vary the distance, you varied the strength of the force.
But
It has
it's
to be
not a
gravity.
force.
It can't be
Cause is
anything
a-
else.
Cause is an angle.
Where's the hidden camera?
Not
Is this a hidden camera show, Brenda? Because what you're saying is like absolutely outrageous. I don't know how you can think.
Well, it's
these
just
things.
your incredulity. That's just
What was
incredulity.
that? Mine. You're telling me
Brenda.
your IV in a scientific experiment is the fucking distance. So you're not
Yes.
proving gravity. All you're doing is
Well,
proving distance. You're
the
claiming
force-
distance is related to gravity that you've not even fucking proved in the first place. You can't claim something
Right.
does something till it's been proven, surely.
The force,
Begging
the
the
force
question.
varies with inverse proportion to the distance. Therefore, if you vary the distance, you're varying the force.
And how did you
What's the
prove
observed
this?
natural phenomenon?
What is the unit?
That's the hypothesis. That's part of the
What's the
hypothesis.
observed natural phenomenon
Well,
then? What's the observed natural phenomenon?
The observed natural phenomenon is an apparent attraction between objects having mass.
Where do you?
I didn't understand that.
So you're assuming that
No,
that's
it's-
what you're observing.
No, gravity is an observed phenomenon.
Can I ask a question? Can you give me an example of an observation where two things are pulling each other? As an
Well, what we
observation of a phenomena
observe,
in nature.
right?
Well, this is
So
what you said. You said the apparent attraction of two things. Where's
Yes,
that?
yes. So Galileo conducted experiments with rolling objects down an inclined plane, and he discovered that objects fall down the inclined plane at the same speed regardless of their composition. Therefore, he hypothesized, or at least Newton did, that there is a force or an apparent force of attraction that attracts all objects with mass equally.
Oh my god.
So
Because that's what the gravity is. All objects, you can have a basketball and a
Hold on,
cannonball. If you have a basketball and a cannonball, they will fall. They will fall at the same speed. A basketball and a cannonball will fall at the same speed.
The same.
And
Why do
have
things fall at
cannonball-
different rates at all?
They don't fall at different rates. They all
Yeah,
fall
they
at the
do.
same rate. That's
I
not
can give you
true.
an example right now.
No, you
drop a-
can't.
Yeah, I can. I can drop a feather and a bowling ball. They're not going to fall at the same
You have to eliminate confounding
Well, you have
variables.
to
So you
eliminate-
eliminate.
Hold on,
Yes, you have to
pretend like
eliminate
the air
air
doesn't-
resistance. You have to
Also,
eliminate.
You have to pretend that the air doesn't exist.
That's just doing a proper experiment. You eliminate confounding variables.
Wait a
How do
minute.
you eliminate
Now,
the air?
now Brenda understands. Hold on, hold on. Let me point something out. Everybody be quiet. Everybody be quiet just for a second. Just for a second. Just for a second.
All right,
Yeah.
that's the end of that,
Just for a second.
Holmes.
Just wanted to say that now Brenda demonstrates that Brenda completely understands how the variables work in a scientific method.
but won't use them in our explanation.
I just want to know how you're eliminating the air. If the air can affect how things fall, then how would you ever demonstrate that things fall at the same rate?
Well, you would eliminate the air by putting the objects in a vacuum chamber.
That's not eliminating the air. That's minimizing the air.
Yeah.
Right.
Below the
Right.
tolerances of the instruments that you're using, that's good enough.
Oh, it's
Well,
good
that-
enough.
That's good enough.
Yeah, it's good
You know
enough.
what, just roll with it anyway. Fuck it.
Yeah, if you
Well,
can't
that's-
measure, if
hold
you
on.
can't measure the difference, then you've effectively eliminated it because, right? You can never eliminate anything absolutely.
So, so where is the observation that you've got for Cavendish? The apparatus was built on a naturally observed phenomena, and you've not got one.
So the observed phenomenon is Galileo's experiments on an inclined plane that showed that objects of different compositions fall at the same speed. Therefore, the hypothesis is that there is a force or apparent force of attraction between all objects having mass, and they fall at inverse proportion to the distance between the objects.
But you never proved this in the first place. You can't
That's the
just assume-
hypothesis. That's the
Right, but you-
hypothesis.
But that's not been proven. You've never actually given us anything that proves.
The Cavendish confirms the hypothesis. It measures.
You claim Cavendish proves this.
Well, it doesn't prove. Science doesn't prove things. Science doesn't prove
You
things.
just used the word prove, so I just
Yeah,
reiterated
there's a
that.
colloquial definition and there's a
Right,
proper
so
scientific definition.
I'm surely I'm allowed to use that word if you just used it, and I replied
No,
specifically.
I can understand by context. So yeah, I can understand. I can understand what people mean, but sometimes
so-
people think that pedantry is. Sometimes people think that pedantry is what intelligent people sound like, but that's not true.
So again, where's the natural phenomena? You're claiming who's Galileo?
told you.
did this,
Galileo's
Galileo did-
experiments,
What-
yes,
what-
Galileo's
what-
experiments of dropping balls down of different composition down an inclined plane.
How is that a natural
What was his-
phenomenon?
And what was his independent variable in this non-natural?
Those were observations of the phenomenon.
So just observations, so no experiment.
Yes.
So you've not got an
But
experiment.
it's also an experiment because he dropped multiple objects and down multiple inclined planes and timed using a water clock how long it took them to fall. He used 7 foot long inclined planes, and he rolled objects down it of different composition, and he timed how long it took. And objects of different composition took the same time to roll down the inclined plane.
And how can that possibly be a scientific experiment following the scientific method? It's an observation.
Yes, it's an observation of a natural phenomenon. It suggests that there exists a force or apparent force of a mutual attraction between objects with mass that is independent of what they're made out of and inversely proportional to the distance.
Are you saying that two objects with the same weight will fall on the same rate? Are you saying that?
Yes. A steel ball and a feather will drop at the same speed if you eliminate air resistance.
So, how come if mass attracts mass and there's more mass in the lead ball, why would it not fall quicker?
Are you saying that Galileo dropped the things in vacuum?
No, he didn't.
Oh, really? Now I'm asking you: does two objects with the same weight will fall down on the same rate?
All objects, regardless of weight, drop at the same speed.
Okay, listen this now. I have a sheet of paper, and then I have two sheets of paper. They have the same weight. One sheet of paper, I will how to say put how you say when you push
You have to eliminate air resistance. You know that, so don't even start that down there. You have to eliminate air resistance.
Galileo did that. Galileo did that.
He never eliminated it. You just admitted that he never did this.
Is eliminating air resistance a natural phenomenon?
Does Galileo, eliminate resistance of the air?
Yeah, you eliminate air resistance by dropping the objects.
Does Galileo did that?
No, he didn't. He didn't.
He never had a vacuum chamber.
Why?
But he used objects that were affected the same by the air resistance, right? He used balls. He used small objects that would roll down. He didn't use a feather because a feather would not roll down the inclined plane.
Listen this, I will take two sheets of paper and I will stay in my room without wind, without anything. This is only
air resistance will still cause them to.
Let finish, Brenda.
Great, but the sheets of paper has the same weight. Now one paper I will push in my hand and I will make garbage, and I will drop it. That thing has the same weight like a sheet of paper, but we fall down before that sheet of paper. Do you know that?
Because of air resistance. I've told you this already.
No,
stop wasting my time. Stop wasting my time. I've already told you that it's air resistance. Don't waste my time with this.
The shape of the
Don't waste my time with this. You have to eliminate air resistance.
Okay, does Galileo did that?
Who cares?
I already said no. Why are
you walking?
I already told you. I already said this. Stop wasting my time.
Why are you
We're having a discussion. Just chill.
But I already told. I'm tired of getting answered. I'm tired of getting dogpiled. Stop dogpiling.
Can I do one-on-one with Brenda just for a few seconds, please, guys, if you don't mind? So I've been pretty quiet so far. Brenda, thank you. I just posted something, right? This is from the drop tower. So this was done in a vacuum. And what you're going to see is they got different elements. They all weigh the same. And even though they weigh the same, they're falling at different speeds in this drop tower in Germany. Now, if you want to, I could find the original source, but for now, you're just going to take my word because I'm driving, that this is done in a vacuum, and they don't actually fall at the same speed.
Oh, okay. What's their explanation for that?
I don't think it needs an explanation. It's just a fact.
Yeah, I think it does need an explanation. Obviously, they were the people experimenting. They must have seen that as an anomaly and tried to figure out why that happened. What did they say happened?
Does it actually need an
You
explanation?
don't know. You just saw a video on YouTube. What can you show me a scientific paper?
Paper.
Okay, so does it need a paper?
Yes, I don't take videos on YouTube as being authoritative science.
But papers are not science.
Yes, it is.
Academia.
That's what science is these days.
No, science is a method to establish cause and effect relationships, and you need to follow it, or you're doing pseudoscience, my friend.
Published scientific papers are not pseudoscience. YouTube is not science.
So where do you get your observation of the...
Of what? You cut out. He said something and I didn't catch the end of it.
I'm saying, where do you get the observation that the Earth is this?
You cut out again. I don't know what's going on. You're maybe lifting up on your push to talk. Where do I get the observation that the Earth is a globe? From pictures in space. Pictures in space from the ISS, right? From the Gemini, from Apollo, from satellites, right? We get pictures from space.
The ISS. What does the ISS show?
The Earth.
If you seriously
does the ISS show the whole Earth?
The ISS orbits the Earth every, 94 minutes or something?
You said pictures. I was just asking you.
Yeah, live video and photographs from space.
Of what?
Of the Earth. Of the
whole
Earth.
Or a portion of the Earth?
Some of them are the whole Earth, some are a portion.
You just said you don't accept videos.
Exactly.
How can we verify it's live?
Don't accept YouTube.
How can we verify it's live?
NASA's on YouTube. NASA's got a YouTube channel and it's not even live. It's on a loop.
Guys, 1 second. Let AI come through because we can barely hear him. So let him please come through. Thank you.
I mean, it sounded like we just heard you say that the ISS takes pictures of portion of the Earth and the whole Earth. That's incoherent.
It orbits the Earth every, something like 94 minutes, and there's a live video feed of the ISS orbiting the entire Earth.
I can give you video.
You take that as a picture of the whole Earth?
Yeah.
No, that's not how that works.
Why not?
Oh my God, dude. Because
why not?
Pictures are an instance, not a video. You can't confirm.
Video is not an instance. Video isn't an instance.
You never see the whole Earth in full frame, correct or incorrect?
You can with some of the photos.
Some of the photos from the ISS, you can see the entire Earth.
Not from the ISS, but some photos from space.
Yes, try clearing that up.
From the ISS, there is live video of the ISS orbiting the Earth, making a full revolution.
No, there's video of
yes, there is.
ISS traveling above the Earth. There's no evidence that video means it's orbiting.
It's orbiting. Yes, it is. It completes a full revolution. Yeah, it completes a full revolution.
Yeah,
around the Earth. There you go.
Yes, there you go. Thank you. Thank you.
Brenda.
Bro, you got to reconnect or something.
Yeah, if he's saying something and I can't hear anything. Yeah, he's having problems.
Quite a bad signal, folks.
We didn't catch any of that.
No, I was just saying, you said that you didn't accept TV, media, shit like that. That's all you've got to prove that these people are in this tin can.
No, that's not all I've got to prove.
So what else have you got?
As far as the ISS? The ISS, there's all kinds of records. There's all kinds of records, right? There's the building. There's the plans for building it, the actual building of it, the launching of it, the launching of.
I'm asking you, how do you verify that what we see on TV, because you don't accept TV, we see these people, like, where is the proof? Plans, no diagrams, no evidence that they had
all of that. All of that is evidence, right, that there is in fact a satellite in low Earth orbit, right? All of the evidence, the plans, the building of it, the multiple launches of material up there. It's assembly
You mean
in
the
low Earth
construction
orbit.
the construction that was going on at 17,000 miles per hour?
Yeah.
That still doesn't prove. You
That's
said
all
that
evidence. It's evidence that lends support to my belief that it's true. Yes.
But you've still, the only thing you do have is the TV, though, to confirm it.
Hey, thank you for being honest, by the way. Thank you for being honest. Hold on. Let's just take credit.
I'm happy to be honest. I'm happy to be honest. I will admit a good deal more than you probably think I will.
Yeah, fair. So your next moral aptitude test is to not interrupt people. So anyway, thank you for being honest that you do indeed just have a belief that you believe is informed and that it's not knowledge. Thank you.
That's what knowledge is. Knowledge is an informed belief.
No,
that's what knowledge is.
Justified belief.
Yeah, that's what I used your word. I could have said justified. I have a knowledge of epistemology. So yes, knowledge is a justified true belief, or if you want to say informed.
At least you're admitting that it's a belief.
Yeah, all knowledge is a belief.
No, it's not belief. I don't believe that I'm not moving right now in 4 vectors at millions of miles per hour.
Yes, you do. Yes, you do. Of course you.
No, I don't. That's self.
Do you think it's true? Do you think it's true that you're not moving?
Can you look up the definition of belief?
Is it true? Is it true that you are not moving?
Well, my vestibular system in my ear, for starters.
Is it true?
Ear, well, I accept it. So
yeah, you accept it as true. That is what a belief is. A belief, a belief is a sentence or a proposition that you accept as true.
No.
I got a definition. My definition's kind of funny, right? Because I just made it up. But I think it's a good definition. So
mine is not made up. This is the standard epistemological definition of beliefs.
Cool. Can I speak? So basically what I'm trying to say is everything that you experience, you have firsthand knowledge. Everything else that doesn't exist within your primary memory and firsthand present experience is belief. Thanks.
No, experiences are not knowledge. Knowledge is constructed from experiences.
So when I got punched in the face when I was walking home from swimming in the pool by a guy that I didn't see coming, do you think I believed he punched me in the face, or do I know he punched me in the face?
You use the evidence of his fist hitting your head as confirming your belief that you had just gotten hit in the head.
That's not a belief.
Yeah, that's a belief. You believe it's true that he hit you in the head.
Brenda, take a look in the live stream voice text at the definition for belief, for God's sake.
I'm using the definition used in epistemology. In epistemology, a belief is a mental content that you accept to be true.
Brenda, does water believe? Does water has beliefs?
I didn't understand. Water has beliefs? Water doesn't have beliefs.
Great. Does you have beliefs about water?
Yes, I have beliefs about water.
Do you think that water curving?
Water conforms to the surface of the earth. It is level.
Perfect.
That's contradictory.
No, that's what level means. Level means conforming to the curvature of the earth.
No.
Cool. Show me a definition older than 10 years old that says that.
Oh. Yeah, it's on McToon's. It's on McToon's. Yes, it's on McToon's.
Is it older than 10 years old, or did Globe?
Yeah, it's from the 19th century. It's from the 19th century surveying manual.
Why does it conflict with the definition of horizontal?
Because people are allowed to use words in different ways if they want to.
Oh, just like you done there just now with.
Yes, you just have to be consistent. You can use words in different ways if you want.
Brenda, you move the
I am consistent.
Constantly. You constantly change what you've said. You change your position. You add shit on. You assume stuff. You claim people from fucking centuries ago did shit.
Thank you, Brenda, for double speaking. Thank you,
Yeah,
Brenda, for
listen,
double
Sasha, you're on to it,
speaking.
okay?
Yeah.
I'm pretty
So-
sure that people from centuries
listen.
ago did shit. Yes.
No,
I have
that's
no
great.
problem with
That's
that.
great.
Thank you,
Let's talk
thank you,
about
Brenda,
current
for double
technology. All right, Sasha, you said the same thing 4 times in a row. Now, Sasha's onto it, and Brenda admitted that according to the Globe claim, that the level water is conforming to the surface of the ball, allegedly. So, if that's true, all that needs to be done to falsify this proposition is to measure some water and prove it's not curving, and the proposition fails.
Sure.
Now, that setup, whether true or not, would you agree that that would be correct?
Sure. Do you have a measurement of how flat the Earth is? You got any measurements?
How come you changed the proposition?
Yeah, I have, Brenda.
Do you have a measurement of the Earth being flat?
Brenda's asking me, Sasha.
Okay, sorry, I have it.
Doesn't matter.
Okay, no, I just want you to just say that if the claim that you said is
So
true.
all that matters, when it comes down to it, that's all that really matters.
So I will readily admit that level means conforming to the surface of the Earth, of the
Holy
curvature
crap,
of the Earth.
shut it.
Yeah.
Him interrupting me wasn't your cue to overtalk.
You weren't talking.
Yeah, I was. He interrupted me, and then you went.
Oh, I didn't hear him.
Well,
Okay,
if I interrupted, I didn't mean it. Sorry.
Yeah, that's fair. Your connection's horrible. That's why at the moment.
Sorry, folks.
You're coming in, then you're not coming in, so it's kind of hit or miss. But whatever, it's fine.
Cool, bro.
That's what we got to deal with in this, 21st century of satellites and internet everywhere, right? But anyway, I just want this proposition to be accepted or unaccepted. It could be a yes or no.
I thought I already said yes. Yes. Level means conforming to the curvature of the Earth.
Okay, that's not the question.
I thought it
The
was.
question is, if that's true, then that means that water must be conforming in that manner. So if you can measure water not to be conforming in that manner, then that disproves the proposition.
No, that would be affirming the consequent. So
No,
you would need to
you would need to
do a modus tollens.
Holy crap, dude. Are you serious right now?
So do you have a measurement? Do you have a measurement of how flat the Earth is?
We're not even going to talk about that until you concede the proposition one way or the other. Okay, so check it out. I'll rephrase it a little bit. If it's not curving in that manner, the water, then that means the Earth can't be a globe. Correct or incorrect?
I think that that's affirming the consequence, so I'm not sure that that would be true.
It's not affirming the consequent. If something's not curving anywhere, what is it? Now, this doesn't mean it is or isn't. It's just propositional logic. If something isn't curving anywhere, what is it?
Well, I'm thinking that you want to show me, for instance, water in a glass, in a drinking glass, and say that that's flat, and therefore all water is flat.
Stop thinking ahead. The proposition stands or falls on its own merits. If something isn't curving anywhere, what is it?
It would be flat and even, yeah.
There you go. Perfect. So if you measure water, and now obviously we need a sufficient sample size, not just water in a glass, as you accurately stated. Right? But remember, we set the baseline that in the globe model, water must be curving around the ball. So if we disprove that that curve exists and it's not curving, then that means all the water's not curving. And that means that it's not curving anywhere, which means you've already conceded that it's flat and even. So all we need is a sufficient measurement. Hold on. If we had a sufficient measurement, right, would that prove or disprove the proposition? I'm not saying it exists at this point. I'm just saying if.
We need to see. We need to see that, yeah.
Okay, perfect. Perfect. So you take a laser over a 25-mile body of water, you set it up 6 feet on one side, you set up a storyboard 6 feet on the other side, you hit the target, and you disprove the curve of the Earth.
Yeah, but they didn't do that, did they?
Yes, they did.
It broke. The the collimator broke.
Collimator's irrelevant. Collimator's irrelevant.
It's pretty important, isn't it?
No,
Isn't
it
it?
isn't.
I
No.
think it's pretty important.
No, if the
It's
Earth
not
curves in the manner you say.
They weren't able to do it over the curvature of the Earth, and there's no controls over that. They just pointed it at the target. How do I know it was level? That is not. That is relevant.
Hold on. Okay. We're not going to be sidelined. We're not going to be gish galloped. We're not going to be over talking each other. We're not going to be losing the points. Okay. If anybody knows anything about gunnery, if you hit the target, you've hit the target. It's irrelevant whether you have a certain shot group or not. If the target is hit, the target is hit. It's that simple. Now,
yeah, but that doesn't show that the bullet. That doesn't show the bullet traveled in a straight line.
Well, if the Earth
yeah, that's correct with a ballistic object. You are correct that that's correct with a ballistic object. Are you claiming that a laser is a ballistic object?
Lasers are subject to refraction, aren't they?
I'm so glad you said that. I'm so glad. So, the common excuse to get away from the fact that they hit the camera and scanned the image on the camera with the Gaussian profile of the beam centroid of the original laser, proving that the original laser beam hit the camera. The camera was only about 6 feet off the ground. Okay, so the variance still stands. Now, this differential in this test is 2 orders of magnitude off the globe prediction. And you are correct, to be fair to you, that refraction is the standard answer given to explain this away. Here's the problem. The United States military contracted a university along with Boeing to conduct a test of lasers for accuracy, for systematic use in military applications. They conducted the test and then they analyzed the results. Here's the thing. They used 3 different color lasers. When they went back and checked the results, they found that all 3 lasers hit the target. 120 kilometers was this test, commissioned by the military, done by a university in cooperation with Boeing. Now, what I just said should be sending shivers through anyone's spine who knows anything about this stuff. Because here's the problem. 3 different colored lasers would refract at different rates because refraction is wavelength dependent, which means they would arrive at the target at different locations. They didn't make this prediction. This was post of the evidence where they analyzed it. They found that the globe model was defeated based on this reasoning. All the lasers hit the target and they should have been separated by 20 feet, and they weren't. This proves categorically that the idea of atmospheric refraction defeating these long distance observations or laser tests is false by experimentation, direct observation and measurement, proving that this type of refraction that you need to save you from this observation or the laser test doesn't exist. So I rest my case. I'm done here for tonight. You guys enjoy dealing with this defeated glober all you want.
Can you send me the study? Can you send me the study?
Absolutely.
Great.
Yeah, while you're looking over it, I
rather
want to
quick,
say something.
But
Well
before you
done,
go
AI.
on, so we have it posted a bunch of times in here. I'm going to try to remember the title and then I'll be able to search it. 1 second.
Thank you. Yeah, I just want to point out one thing. So when they so-called they said that they proved Einstein correct and that they could see the, telescope that was pointed at the mirror, that was pointed at the sun. They could see the stars that were allegedly behind the sun. So if you do believe this kind of refraction is possible, then do you not believe in the heliosphere? Not to take that off the topic of what just, was said, right? I think it's really important what AI just said, because either you believe in the refraction theory, right? Which, if that's true, the heliosphere could cause the light to bend around the refracted, I can't say atmosphere of the sun, but that's what it is basically, right? In layman's terms, the heliosphere is the atmosphere of the sun, right? And the different layers of density will cause it to refract. If you believe that, then there goes your space time. Bye bye gravity. If you don't believe that, and you believe the turbulence, right, then you believe in the flat Earth. So either way, it's double whammy.
Yeah, I don't
Sayonara.
think the amount that was predicted by Einstein is the amount that was observed in the Eddington experiment. It was not due to refraction. It was greater than the amount predicted by refraction.
And how did you remove the heliosphere variable out of that to prove that that's true? Or did you
The
just
amount
leave
predicted
heliosphere
because
alone
we know the refractive index, right? So the amount predicted by refraction is different
You know the
than what was
refractive index
observed.
of the sun?
Yes,
How do you
you
know
can
the
figure these
refractive
things out
index
because you know what gases are made out of. You know the refractive index of gases.
In a
The sun is a ball. The sun is a ball of gas, plasma,
in a
right?
vacuum.
And gases have a refractive index.
Can you have gas pressure in a vacuum without separation?
Of course, it's gravity. It's
You
the
didn't
gravity.
demonstrate gravity.
It's the
Demonstration.
yeah.
You
Already,
never
we've been
demonstrated
through
it.
that. We've been
No,
through
you
that.
didn't.
Haven't
You didn't
yes.
isolate your pseudo force from
We
the
did.
exponentially stronger forces of electromagnetism and electrostatics that are
did.
present in all intermolecular
by
interactions.
using materials that are not affected by magnetism.
That's not what your wooden rods and balls do. There's still electrostatics and electromagnetism present, and you admit yourself that the direct variable that you're manipulating isn't even gravity, and still there's this exponentially stronger force.
There's no
still present.
static charge. There's no static charge
It's present in
on the
everything.
weights. So then it's a wash, then, isn't it? If it's present everywhere, then it's the same everywhere. Then it doesn't affect anything.
Can I ask a quick question?
Go for it, bro.
Does a gas produce a gravitational field?
Yeah, because it's matter. It has weight.
Where can this be demonstrated?
Gases have weight.
Where can it be demonstrated that gas
Take us,
produces gravitational field?
Well, that they are affected by gravity.
No, I asked you whether gases produce gravitational fields because you said a ball of gas is existing in a vacuum because of gravity. So I asked you if gravitational force can be generated by gas itself without solid matter.
Yes.
Is there an example of that?
Gas is matter. It has weight.
But it's not
it has
solid matter, right?
It doesn't matter. It just has to have mass.
Does a particle have mass?
Yes.
Okay, then why don't particles generate gravitational force?
They do.
That's not what the standard model of particle physics says.
Yes, it does.
No, it doesn't.
Yeah, it does.
No, I can post it right now if you want.
The standard model of quantum mechanics, right, doesn't include gravity.
Particle physics is the theory describing.
Yes, it doesn't include gravity because because general relativity and quantum mechanics.
That's why they exclude it from particles.
No, that's not why they exclude it.
Affect particles.
That's not why they exclude it.
Why
they
do
exclude
it then?
Because there's no unified field theory.
Well, that doesn't really help your relativity then, does it? Or your gravity?
Gravity, all objects with mass, including particles, including atoms, are affected by the gravitational force, right? And so there are stellar nurseries out in space. They're clouds of gas and dust from which stars are born. It's observed. You can see it.
You can see what?
You can see the stars born in these clouds of gas and dust.
No, you can see these light above you, whatever they are, and you believe the story you've been told, Brenda.
That's what the pillars of creation are. It's a very famous photograph. No, you can see it. It's dust. It's dust and gas. You can see it. And in that dust and gas are stars being born. There are stars being born in the pillars of creation photograph.
Brenda, that's not a photograph. They are not photographs. Those images, they're taking multiple different wavelengths of light and it's all put together by probably
So what?
supercomputers, I would
Yeah.
imagine. Right, so
Yeah, so
you
what?
claimed it was a photograph. They're
Yeah.
they're artistic renditions of the
No,
data.
they're not artistic. They're
They
technological.
are. They're done by data visualizers. I think Mr. Blue Marble, Mr. Simmons.
Are
it's
they
called.
different? Are they different from the insides of your camera? Your camera takes photos in red, blue, and green and combines them with the computer that's embedded in the camera. Are you saying that your camera's photograph? That's not different. It's the same. It's not different. It's the
What about
same.
cameras? Oh, what about cameras that are not digital?
What?
What about cameras that are not digital and that don't
What cameras?
do
What? The cameras in your
like the earliest cameras?
What are you talking about? Cameras today are digital.
Today, not all of them.
My
Who
child has
uses
a Polaroid camera.
The point.
My child has one.
it's ancient technology?
The
No,
point
I
is,
bought it brand new for a
Hubble
birthday.
does not take photographs.
So cameras work by exposure, right? And they have you can use different filters and photograph in the red, blue, and green, and then combine it to produce a final photograph. You can do that.
What you see in these Hubble images is not what the data shows.
It's literally based on the data. It's literally based on the data. You're right. You're right that it's all data. It's data coming from an instrument. No, it's not artistic. It's data from an instrument.
What kind of instrument? What kind of instrument is making pictures? What out of data?
It has a sensor.
Okay, so there's clouds in outer space now?
Yes.
So explain that one to me, please. I'd love to
There
hear.
are clouds. It's called the Pillars of Creation. It's a famous image.
What are they made of? What are they made of? What are the gases
Dust,
made of?
dust and gases.
Dust and gas. Gas exists in a vacuum.
Yes.
Can you demonstrate that on Earth?
I can show you the image of the clouds of creation.
Can you demonstrate gas in a vacuum on Earth? Can you do that?
It would expand to fill the vacuum chamber. It definitely would.
How? If in order to create a vacuum, what has to happen?
It's very, very big. The pillars of creation are light years across.
Because we're talking about from our observations here on Earth. When you create a vacuum in a chamber on Earth, what happens to what's inside?
If it's a block of wood, nothing happens to it. But if it's gas, it'll expand.
Where's it gonna go? Is it gonna stay in the vacuum or is it gonna go somewhere else?
It will stay in the vacuum.
Hey, Brenda.
I'm listening.
What happens to the gas in the chamber? Hold on.
I told him. Did you? Didn't you hear my answer? I thought maybe you didn't.
It's wrong. It's wrong. First off.
What do you mean it's wrong?
Do you know what the NIF is? You know what the NIF is?
Well, do you think that gas doesn't fill the vacuum chamber?
I'm asking you a question. Do you know?
No, I don't.
NIF. Yeah. Okay, the NIF.
I don't know what NIF is. I don't know what that is.
It's the National Ignition Facility that's in California. Now, what they do here is they conduct high-powered laser experiments in a vacuum. So, in order for the experiment to not be contaminated, they have to remove everything out of the vacuum, right? All that's gases. There's no gases in there in a vacuum.
That's what a vacuum is.
All right. So, how are clouds existing in a vacuum, dude?
Because its space is really, really big.
Come on.
Those
can I just quickly
get Beget posted an image of the pillars of creation. Those pillars are light years across.
Can I just quickly...
created by visual artists.
No, it's an image.
Listen. I'm on space.com right now, and one of the visual artists says some of the most striking views in astronomy have come from the Hubble Space Telescope, but the data collected by the spacecraft comes in the form of spectrums of light, and they create them. It says it's a fantastic telescope, but it can't observe everything. Visual artist Louis Calda said that he's a graphic designer for ESA, and he works making artistic renditions from Hubble data.
Yeah, that's fine.
You just fucking said
That's a funny way of saying cartoons.
Guys, hold on.
He isn't inventing. He isn't inventing data. He isn't inventing data. He's adjusting levels in Photoshop.
No,
You full of
making anime. They literally claim on space.com that they're creating animations.
Yes, of course they do. So does NASA.
Yeah, we know that, bro. We know that.
So what's wrong with that? What's wrong with that?
What's wrong with
creating cartoons and passing them off as reality? That's what you're
They
asking?
don't. They always label them as an animation. They label them.
And that
So it's
doesn't.
not full. Brenda, man, honest to God, like it's like outrageous the things that you say and you accept.
Let me ask you a
Yes,
question.
all I do is give you high school level science. That's all I do.
Yeah, high school level. You said it yourself.
Brenda, can I ask you a question real quick about what you were saying about a vacuum? Did I hear you say that a vacuum is somewhere where there's no gas?
No, he's saying
that
that gas
correct?
can exist in a vacuum. That's what he's saying.
In the vacuum of space, there are regions where there are clouds of dust and gas. Yes.
Wait, so what is a vacuum? Can you define that really quick?
There's regions in space where
No, I'm
there
not
is
talking about space. What is the definition of a vacuum?
low pressure.
Low pressure. All right, let's go.
Right. So it's an area of low pressure. There are areas of low pressure, and there are other areas where there are clouds of gas and dust in a low pressure environment. And they gradually coalesce. They gradually.
Where have you seen this? Where have you seen this?
The pillars of creation. The pillars of creation.
That doesn't count, dude.
Yes, it does.
Brenda,
It does count.
You keep saying this over and over. How would you verify
Because you keep
that,
asking me the same questions over and over.
No, it's not the answer. How would you verify that?
How would I verify what?
The dust of clouds in a vacuum. The
image provided by NASA is verification.
That's enough for you. That's enough for you.
Yes, yes.
Cartoons are verification. Wrong.
It's not a cartoon. It's not a cartoon.
It is a cartoon.
No,
Yes,
it's not.
Yes,
It's an animation.
No, it isn't.
You agreed it was
it's a
animation,
compilation.
The
It's
Pillars
made
of
by
Creation
artists.
is not an animation.
It's made by artists.
That's
Yeah,
a
No.
cartoon,
whatever.
man.
It's
Yeah.
based on raw data.
No, it isn't.
I've got the
You
No,
wouldn't
that's
know raw
what
data.
they
You wouldn't know
that's
raw
what they
data
said.
if it jumped on your face and spun around and whistled Dixie.
It's
You wouldn't know what
manipulated.
data is. Even if you saw it, you wouldn't know what data was. Please.
but I've
So crazy, bro. That you guys do you understand how asinine this whole subject sounds? The how you guys just hand wave it. They say it so it's true. That's all you do. They say it so it's true.
And
How
at the
can you
crux
get
of it
down like
all,
that, man? How
at
can
the
you get
crux
down
of
like
it,
that, bro?
at the crux of it all, you got no globe for any of this. That's kind of the basis
Of course
your
we
whole
do.
paradigm. You're going to need the globe.
We've known the Earth is a globe for 2,600
No, you
years.
don't know that because we falsified that.
It's a
No, you
religion.
haven't.
You
No, you
have to
haven't.
accept it, blindly accept it, listen to their books.
Don't blindly
what
accept
they
it.
say. Yes, that's what astronomy
No.
is.
No,
You
that's not
can't
what
test
astronomy is.
astronomy. You don't. Your physical body.
That's not how science works.
These
That's not how science
astronomical
works.
numbers are using to measure outer space. Okay, so you don't have the actual ability to experiment within astrophysics with your
I
own
don't.
mind.
Of course you
Okay,
can.
so when they tell you
Of course you
something about
can.
the size of this shit, bro, you're just believing them blindly. It's a
No.
fact.
And
No,
you have
I'm
no
not
globe.
believing them blindly. I
And you
accept
have no
them
globe to
as the
base your whole
relevant.
paradigm on.
I accept
You
them
said
as
NASA took-
relevant field experts.
Okay, well, let's see the surface measurements of curvature you've still never provided then. Because that would be the basis of everything you're talking
Ships go over the
about.
horizon.
Okay, we already dealt with that. Did you look at the live stream voice text when they showed you ships going over the horizon and then getting zoomed back in? Something you said never happens. Did you look at that?
Those were ships that hadn't gone over the horizon.
So they disappeared. They went over the optical horizon, which is all the horizon is. Then
That's
we
not-
zoomed them back in,
that's not the
and
optical
we saw
horizon.
them again. This is exactly what you said can never happen.
Just
It
because-
did happen, and now you're adjusting your claim. So you're just a liar.
Just because you can't see a boat doesn't mean it's gone over the horizon.
Okay, but that's what the horizon is. It's the
No, that's
optical
not
limit.
what the horizon is. The
Yeah, it
horizon is the horizon is a geometric limit that obstructs your view.
So what is it? What is it?
Okay, so it's at 1.2 miles at a 1 foot height then? Is that where it is? That's where it would have to be if your radius is true.
Yeah, that is about
it is?
1.2. Yes, that would be about
you're
right.
the person who's seen the Black Swan before, so again, I
Of
think you're just
course.
lying.
No, I understand the black swan. It's
Okay,
a
but
fallacious argument.
Black Swan shows that your
Oh my
horizon is
gosh.
not geometric, that it is
No,
apparent.
The proper way to put it is to say that the apparent horizon would be no less than 1.2 miles, not no more than.
Okay, so it's not geometric.
No
then.
less
The
than.
horizon does
No
not obey the
greater than.
constraints.
No
the horizon
less
does
than.
not obey the
No
geometric
greater
constraints
than.
of the globe that you just claimed that it did. So it is just an apparent phenomenon.
It follows the model of the Earth, including
No, it
which
doesn't.
includes
It would be
which
1.2 miles from
includes
Black Swan if it did that.
which it includes reaction. It includes
your
refraction.
model?
It
Doesn't-
includes
Where's your
refraction.
model?
No,
Where's
it
your
doesn't.
refraction model?
This guy's
Where is
crazy.
it? Where's the refraction model? Show us the model. Your
Refraction? Refraction? That's Snell's law. That's just basic.
That's based on six media. One or
You're
two or
done
more
with,
media.
bro. You're totally done with now because you're reflecting. Snell's has to be hitting reflective surface angled away from you at almost 70 feet below your line of sight. Overdone. Match game set is over.
That's not what Snell's law says.
Is air two different
Yeah, it would make your
isotopic
image
mediums?
going up above your head.
No,
You'd
it
never
does.
even
That's
see
not what
What
it
are you
says.
talking about?
You don't have.
Yeah, a plane of incidence. What is a plane of incidence?
The angle of incidence, you mean? Not plane.
No, it's called a plane.
No, it's called
of
the
incidence.
angle of incidence.
No, it isn't. No, it
Yes,
isn't.
it is.
The
Yes, it
angle
is.
is what the light does after it
Sine of
reflects
theta.
off the surface. You don't know anything about it.
Snell's law is sine of theta 1 over sine of theta 2.
Plane of incidence.
Sine of theta 1.
Okay.
That's an
And-
angle. Theta is used in trigonometry. Theta is an angle.
It's there in the live stream. Plane of incidence.
Religious
Wikipedia,
chanting.
Just saying.
Well, yeah, what does that surface look like that it's bouncing off of? Is that a curve?
That's plane of incidence. That's not Snell's law.
This guy.
That's not Snell's law. That's a law of reflection.
Yeah, Snell's law requires two different isotropic media, doesn't it?
Yes, like hot air and cold air,
How is that isotropic?
because they have different density.
What does isotropic mean?
It means that they're different.
I thought ISO was same and Aniso was different, but we don't need to.
Kidding? ISO's the same.
Over the semantics. As far as I remember, ISO is same and Aniso, or with an "and" in front of it, are different. But I'll have to double check that. Anyway, as far as we can tell,
all right.
Snell's law deals with going from medium to medium. As long as we consider air one isotropic, same continuous medium, it doesn't go
Right.
from like water to
You
air.
don't get.
So there's a bit of a problem there.
You're correct. You're correct. I was wrong. Isotropic means the same, right? So you won't get refraction in an isotropic medium.
And that's why we're a little confused, because air is looked at as one medium. Usually, if you're dealing with Snell's law, it would be like from
no,
air to
if-
water or something like
No, if the air has different density, like it's cold or it's hot, then it will have different density. It will refract.
And as far as I can tell, with the way that they put refraction over a ball, they've just basically go with at least terrestrial refraction by acting as if it's a bigger ball to flatten it out. Which, for the
terrestrial refraction is just refraction. There's nothing special about the refraction of objects on the Earth.
Because that's assuming what was first be proved. If you're working or baking into your model refraction, that already assumes a ball or a bigger
refraction.
ball.
Refraction is just refraction. That's all it is. It's just refraction.
How do you interpret refraction? Are you going to interpret it toward a ball or towards something flat, like, a flat surface? What are you going to do?
I don't know what you mean by how you interpret refraction. Refraction is just refraction.
Well, we can reapply refraction. I mean, over a flat Earth, eventually the sky and the ground would meet because of compressed viewing angle. And refraction could be reinterpreted as making things balloon or pop out of this diffraction limited zone or, compress into this zone sooner or later. So
I don't think you know what diffraction limit means.
I think I know enough to challenge the theory. You're a smart person. You're a smart woman. We're smart people. We can figure this stuff out without the experts, with or without them. And so we need to see how we're applying refraction and whether or not it's, consistent with evidence, facts, real life, other theories or not.
Right. So the black swan
just quickly
image.
Interject. Do you remember AI talking to you about the laser test that the Air Force and Boeing did? I think he just posted it in the live stream. You said you wanted to
I don't see it.
It's right there. He just
Brenda,
posted it
can I
like a
just
minute ago.
ask?
I see it.
You know how you claim that boats go over the horizon? Do you mean optically, just with your eyes, or do you mean they go over the horizon when they get to the limit of the instrument you're using?
I mean that they are physically obstructed by the curvature of the Earth.
No, they're not, because we can zoom them back in after they go over the horizon. Just by
if you can
increasing the
zoom it
resolution
back
power of the
in,
observer.
if you can zoom it back in, it hasn't been physically obstructed.
There is no physical obstruction. That's the entire point.
That phenomenon of obstruction is observed.
No, it's not, because it would be at 1.2 miles times square root of observer height in feet every single time if it were being observed, but it's not, even by your own admission, and you use an ad hoc excuse for why that is. So you don't have a
ad hoc.
physical horizon.
I said the black swan strawmans. The black swan strawmans the models that we're using.
It's
strawmans it because the proper way to formulate it is no less than, not no more than.
So what's happening in the Black Swan video then? So what's happening? Tell us, please. What's going on?
Magic.
There is high degrees of refraction that is lifting up parts of the.
Okay, how did you know that? And can you quantify it? How much exactly? How much? Put it into numbers for us.
We don't have the
just
measurements.
How much you need to make that work.
We don't have measurements.
Then it's just an ad hoc cop out, like I said it was, because you just by your own admission right now you don't have the measurements. You don't even know how much is going on. It's just however much you need to make that work on your globe fantasy. Well, you need to inflate your radius by 2 orders of magnitude to make that happen, and your standard refraction model doesn't even come close to claiming that's even possible. So no.
You people are the only people on Earth that are saying these things you're saying. It is so retarded. It's beyond belief.
I'm not the only person on Earth. This is majority. You're a tiny group of people, maybe a few hundred people.
He's not
wishful thinking.
Yeah, that your anti-flat earthers are the smallest percentage of anybody on the internet. You're the only one saying this stuff.
No, I just meant not the internet, but globally, all around the world.
Right. I mean, you're exactly right. I mean, there are lots of people who just look at the screen and believe what they see on the screen and don't really question it, and that's fine. We have a perfect right, right?
There are. I'm going to agree with him, so you should let me talk. I'm going to agree with him. I'm going to say that yes, a lot of people just blindly accept what they're taught in schools. You're correct.
Yourself.
Yeah,
like yourself.
No.
You believe
you're Exhibit A, Brenda.
The difference
you
between
believe in
us,
Galileo done experiments. You believe the shit you see in the sky are clouds. You believe literally that. See, for to be a globe Earth believer, you've got to accept a hell of a lot of contradictory shit.
And the difference between you and us is if we're proven wrong, we will happily happily go back to believing what you guys believe. You shut us up, we will shut the fuck up. We wouldn't care. We'd love to go back to believing in Star Trek and shit like that. We'd love it.
I don't believe in Star Trek. I don't believe in Star Trek. That's it's a TV. That's fiction.
I'm just saying. Listen, I'm just
You know
saying,
what he meant, for fuck's
we
sake.
would happily go back to that. You guys can't even say that. You guys
What can't we say?
You can't even say, well, if we're wrong, I'll happily believe what you guys believe. But you won't even do that because you guys just hand wave everything and say we're wrong without even giving the opportunity to believe it.
If you could show me evidence. Do you have measurements? Do you have measurements of the flat Earth?
You do. You hand wave them and you ad hoc. Yeah, that's what you do. You make ad hoc excuses from. We just talked about one. The black swan measures the horizon to be
it doesn't.
2 orders of magnitude beyond what your Earth radius allows, and you just ad hoc hand wave it away.
I told you it's a fallacious argument.
Care what you told me. I explained why your argument is wrong. You would need 2 orders of magnitude. Yeah, you're off by 2 orders of magnitude for your Earth radius in that one observation alone. You don't even have a refraction model that could account for that. You have nothing but ad hoc excuses. That's all you do when we show you measurements that are not possible on your globe.
You don't get to tell me. You don't get to tell me what my model is. According to my model, you are straw manning. You are straw manning the globe model.
You don't even know what the model is.
The first premise of the Black Swan straw mans the globe model.
You don't even know what that means. You're just saying that mindlessly. You don't even know what you're saying.
I've taken university level logic and philosophy in critical thinking logic.
You don't do any of those things. You've made your claim unfalsifiable by using this ad hoc cop-out of refraction. Now you can move the goalposts all over the place to wherever you need to without even having to do any measurements or even quantify how much refraction is even going on. It's just, how much ever there is. So you've made your claim unfalsifiable, and then you talk about logic proving your globe.
In order to know how,
we steel-manned it. The radius is 3959. It's a completely geometric situation where that horizon has to occur at that geometric distance.
Horizon is apparent, not geometric.
Excuses. Yeah, you said it yourself.
The horizon is apparent, not geometric. Therefore,
good night, ladies and gentlemen. There's no geometric horizon on Earth.
No, there is a geometric horizon, but the horizon that you see is apparent, not geometric.
Okay, so we never see your fairy tale unicorn geometric horizon that you said. Boats go over, but actually they don't. And
how did you know?
And you're going to tell us about logic, right?
How did you know there was a geometric horizon if you can't see it?
Because it must be there according to math.
Except it's not. It's been geometrically falsified, and math isn't reality. So.
Wow, this is amazing. This is a good day. I'm glad I came in.
It's been geometrically falsified, and do you know that math is not reality? Maybe actually, Superman can fly because math.
Math describes the world we live in.
Except what your globe math describes is not where we live, as evidenced by the Black Swan and many others, which you refuse to accept.
I refuse to accept it because it's a fallacious argument that commits fallacy.
Explain why.
I have several times. I have.
In and of itself because it's unfalsifiable. This is what you do every single time we falsify it. Is you just move the goalposts around so as to render it unfalsifiable, and you can't even quantify your cop-outs for us. You can't even tell us how much refraction, how you get the geometric horizon to appear where it is in that picture. You just tell us, because.
Well, we don't know how much refraction is going on in that picture because
you don't have to claim
just a minute. Because we don't have the information from the photographer of what the lapse rate was at that time. We don't know the lapse rate.
Your model doesn't even account for the possibility that you can inflate your radius or your apparent radius by 2 orders of magnitude. Standard refraction doesn't even get you close to that.
So
because you're implying it wrong. The proper way to put the first premise of the Black Swan is to say that the apparent horizon can be no less than 1.2 miles from the observer.
Explain it how. Explain that how, Brenda. Explain that exactly how.
So are we actually looking at a physical object or an apparition? is it just
he's
He
getting
made a claim. He said that it should be smaller than 1.22. So
no.
tell
I
us
s-
exactly
no.
why.
I said
That
I
can't be.
said the first premise is incorrect because it says that the apparent horizon can be no more than 1.2. That's wrong. It's
Okay.
no less than
Tell us what can
1.2.
possibly
us
make
how.
your geometric horizon appear 2 orders of magnitude beyond what your Earth radius allows.
Refraction can.
How?
Refraction can.
How much?
in the
How?
black swan?
Refraction can make the apparent horizon seem further than the
How much
geometric
further?
horizon.
Quantify it. How much refraction do you need?
depends.
What's the
It-
formula, and what are the
it-
measurements you based
It
it on? What's the
depends on
physical
the
data?
lapse. It depends on the lapse rate.
Do you
No,
have measurements from reality here
We-
that can determine exactly how much refraction is being applied in that image?
We don't
And that-
have data from the original poster.
Do you
of
even
how
have?
long-
You
You
got
got
saying
data
it's
on
doing
clouds in
something
space?
better
we,
than
we
radius.
would
Stop
need
it. Stop
data
it. Stop
from the
it. Stop
original
it.
poster.
No, stop it.
Let me ask a question here.
So you don't have data. You're making a claim with absolutely no basis then, according to you.
Try to rank what I post, Brenda, Narnia.
All right, here's a quick question, Brandon.
What?
Is
I'm kind of getting inundated by people
Yeah,
requesting me to respond.
Well, you
So-
don't even have a model that would inflate your apparent radius by that much.
I just
So
told
you don't have a claim.
refraction. I just told you refraction can.
No, you just keep squawking that word over and over again, but it's not actually an argument because there's no
Yeah.
substance to it.
Yes,
You
there
haven't
is.
No,
Listen,
there
Brenda,
isn't.
You're saying,
We
Brenda,
go to the
that-
Green Flashes. Go to the Green Flashes website. He has the formulas there.
Oh, someone
for
else will
refraction.
get it for you. Okay.
But he's a relevant expert in the field, even according to Quantum Eraser.
I care what your credentials are. I know
What?
It's from
Your-
what
your
physical
block-
data. I just want to know what physical data you based your refraction calculations on to determine whether they're valid, and then I want to know what those calculations are exactly. You can't
Exactly.
provide those things to us. You just keep appealing to someone else's credentials. Oh, he's a relevant
Because
expert.
that's
I
how
don't
science
care.
works. Because
No,
that's
it's not.
how science
Appealing to
works.
credentials is not how the scientific method works. That's not what the scientific method says to do. Just invoke some expert in a field.
You
go, man. You tell it like it is.
Here's a quick question: Is in the
And
Black
invoke
Swan,
some priest. Sorry, Frog. Go ahead.
in the Black Swan video picture, whatever you want to call it, is the object there or not? Are you looking at an object? Or are you looking at something else?
What object?
The oil rig, is it actually there, or is that just you're seeing
You're seeing highly refracted oil rigs, and you can see the cranes are twisted and turned by refraction.
Are they there? Though?
They are. They do exist out there. Yes.
But is that what you're looking at? That actual object?
Yeah,
So if
I think you are.
Okay, so if I threw a rock at it, if I could throw a rock that far, would I actually hit the object at that distance that I'm seeing?
I don't know.
You don't know.
Yeah.
So
Maybe they are displaced up or down or something. I don't know.
Yeah,
If
you don't have
cut a frog-
anything that says that it's doing that. But listen, you're saying it's doing something specific, Brenda. So specifically, I want to know exactly what. See, otherwise you can't just keep saying this thing refraction.
Why
You have to
not?
tell us exactly. Yeah, because listen, the Black Swan, we have known distances, so you need to tell us specifically at those known distances how your refraction is working exactly, like by the inch. You should have this.
Actually, all I have to
Where-
do is show that the argument is fallacious.
You have
That's
how is
all
it
I have to
fallacious?
do.
How is it fallacious?
It
Tell me
commits a fallacy. It commits a fallacy of it.
Go ahead.
I was going to say it commits two fallacies: the fallacy of equivocation and a straw man fallacy.
Also, equivocation.
It equivocates between the geometric horizon and the apparent horizon.
No, it
right?
does-
Yes, it
it's
does.
in the wrong
Yes,
category.
it does. Yes,
No,
it does.
You
And
can't
that it-
show
yes, it
geometric
does.
horizon. The apparent horizon is the only thing that even you can show us.
Yeah. You don't have a geometric horizon. That's what it shows. So we don't. What are you talking about? You got to be out of your mind. No one says this bull crap. That's
He's
what I'm
claim-
saying.
He's claiming a geometric horizon that he says can appear basically anywhere, making his claim
Anywhere.
unfalsifiable. He's
and
really being
listen,
fallacious.
And it will always make it look exactly flat. How is that? How is it doing that? Exactly as flat would look. Just like we see it and measure it flat. Oh boy. Unbelievable.
Projection much.
So we don't have any data on exactly how this refraction is working. We've never seen anything. We've never seen this model. Where is this? It doesn't exist.
We have two horizons now, everybody.
Well,
and the one they're using is, the one they're using is the one you can't see.
Right. And at first he said that we can see it because boats go over it. And then he completely adjusted his claim after we showed him that boats don't go over any physical obstruction.
I want
to be dishonest.
I wanted to ask a question when you guys were on the boat going over the horizon, because, okay, I'm on a ship and I zoom in, like, okay, there's a lighthouse at a certain distance, right? I can't see it, but I know the direction. So I zoom in and now I can see the lighthouse. Does that mean, Brenda, that the lighthouse hasn't moved beyond your geometric horizon yet? Let's put the observer on land, looking at a lighthouse. Is the lighthouse need to move further to get to your? It's stationary. How does it work then? You couldn't see it before, then you zoomed into it.
I just want to point out that if refraction is true, let's take them at their word, right? Let's give them the benefit of the doubt. So refraction is true, and the horizon moves all over the place because of refraction, and allows us to see past the curve, and sometimes we can't see as far as the curve. Well, that means every time they're measuring, hold on. That means that every time they're measuring the horizon, they're only measuring the refractive horizon. So that still falsifies their horizon. They have no geometric horizon anymore because every horizon is refractive.
Yeah,
and if it isn't,
you can't. But look, Hank, you can't trust your eyes now. So if I'm looking at binoculars and I see this oil rig out there, they're saying it's not really there. You're just seeing something that appears to be at that position, but it's not. It's behind the horizon. So if I wanted to shoot a bullet at it or run it, it's not there. It doesn't exist. It's not real. It's an apparition. It's just a mirage. Is what they're saying. That's fucking crazy.
It's magic. Basically, you're telling, like, the education systems all over the world are telling kids to ignore reality and believe what they see on TV. I think it's child abuse.
Yeah, so the mirages are moving location without you knowing where the demarcation is. Where's the demarcation? Where this mirage starts and ends? Because it should be your geometric horizon. There should be an easy way to delineate where this change is occurring. It should be happening right at your geometric horizon. So at 1 foot above the horizon, 1.22 miles is where this should be occurring. Why aren't we seeing this phenomenon of this demarcation between reality and the mirage? Where is it? That's what they need to show.
So another thing that Brenda said that was absolutely incorrect is that Huey's argument is wrong. Instead of it being the horizon can be no further than, Brenda said that it can be no closer than. So what about fog, Brenda? Would fog make it closer than? Are you straw manning fog? You never heard of fog, Brenda? Because I've been in fog and so bad that I literally pulled over on the side of the road because I knew at any minute there was going to be a pileup. And once there's a pileup, it grows. Like they keep piling up.
Well, you must be wrong because the horizon can never appear closer than that.
Yeah, so in fog where I have only 1 mile visibility and I'm off the coast 5 miles, and I have a radio direction finder. Maybe 5 miles isn't enough. It should be. Because a lot of jetties are only about 6 feet above sea level. You can triangulate yourself right back into port, right into the mouth of the jetty using triangulation, even when you can't see.
Welcome Matthew No Arms back. Matthew Learns.
No
aka
arms.
Matthew Weathers. Welcome back, Matthew.
Hey, happy long weekend to everybody.
Matthew, what do you think about the fact that all the top, like these top level physicists and astrophysicists openly admit that the heliocentric model is no more accurate or viable than the geocentric model, and they choose it simply based on philosophical grounds?
Yeah, that sounds fine. It's the idea that the reference frame doesn't matter.
He asked you, what do you think about that? How do you feel?
He said, yeah, that's fine. I guess
it's fine, yeah.
Matthew. So I want to really get to this because I'm interested in the philosophical implications. So you know that their philosophical bias is summarized by the Copernican principle. You know what that is?
I don't know what the Copernican principle is, no.
Okay, so the Copernican principle simply is that the Earth does not occupy a special position in the quote-unquote universe. So meaning they perceive it as some type of humility, ironically, through their arrogance, but that the idea that the Earth would be the center would make it special or unique, requiring design. So they philosophically prefer the Copernican principle, which is that we're insignificant.
I doubt Copernicus himself would have said that. I wonder how it came up with that name, because he was a theist.
No, that is.
Well, with the Copernican principle, yeah, it's basically there are assumptions there that can't be validated, so you would have to go with a priori knowledge versus a posteriori. And in that case, well, who's the arbiter of that knowledge and what's the justification? So again, these people are talking about how they're not in a special location. Also, if you speak to people who have this worldview today, many of them are atheists for some reason. So, I mean, what do you think is going on here, Matthew?
Yeah, those sound like metaphysical questions, philosophical questions, and it makes sense that if you're an atheist, you're going to like prefer those kinds of things that might like reinforce your atheistic worldview. I have no commitment to those kinds of.
Well, that's why I'm asking you, because again, I'm pointing out that I can cite for you all day long infamous physicists and astrophysicists that tell you that you cannot prove that the Earth is in a heliocentric model, but that we choose this decision, we make this decision on philosophical grounds. And the philosophical grounds in which they choose that lean towards the nihilistic, atheistic, materialism, which is that the Copernican principle is true, meaning that the Earth does not occupy any type of special location. It is insignificant. Isn't that intrinsically kind of contradictory with what you think?
It is, and I would disagree with them on because we actually do occupy a very special place, even among the people who say that there is no God. They would say, "Oh, isn't it lucky, or isn't it fortunate that we're this distance from the sun and all that?"
I think that's a little bit different context, because we're talking about position being central to what we see as the perceivable universe versus no, it's actually arbitrary. There isn't a specific. That's what we mean.
Well, no, Matthew, you're also still just wrong. So, if you in this heliocentric model and this vastness of this universe, quote unquote, it is not that crazy that there's a sustainable planet. Actually, there's expected to be millions of them. So what you're saying is just wrong.
So the fine-tuning principle is this idea that every time we look and look at physical constants, it seems to be designed to support life, and that's true about almost everything we look at.
I'm glad you brought this topic up, because I think the flat earthers need to learn a lot about this as well. So fine-tuning, you're right, that is one of the big issues that they have, and they really had to face it with the CMB. Fine-tuning, like he said, being the idea that, well, that would require a fine-tuner, and all of this that we observe seems to insinuate that there's some type of significance, statistically speaking, to the Earth. So do you know, now the same people that brought you this heliocentric paradigm based on philosophy are the same ones that are opposed to the fine-tuning problem. So do you know what they're currently proposing to explain away the issue with fine-tuning?
Yeah, they say there must be trillions of other universes, the multiverse, which is nonsense because there's no proof for any of that.
Exactly, the multiverse. That is how devoted these people are to avoiding a designer. And these are the same people that brought you the heliocentric paradigm because of their philosophical preference. So wouldn't you find it pretty intriguing that they'll all tell you you cannot prove that the Earth is heliocentric, and in fact, it is no more viable or accurate than the geocentric model. And furthermore, it's actually less viable.
Yeah, so the reference frame doesn't matter as much as is kind of a new thinking, but I would dispute the idea that the heliocentric model was brought by atheists. It was Kepler and Newton and Copernicus, and they were all strong believers.
He didn't. He didn't say that.
Yeah, I didn't say that.
Okay, well, the first people who were heliocentrists were almost universally theists.
Or wolves in sheep's clothing.
Yeah,
But yeah,
that's
not the point.
anyway. So the point is whether or not they were theists is irrelevant. That it was the Copernican principle, which is that the Earth is insignificant when it comes to space.
I see.
What
Okay, I got it. I see what you're saying.
Yeah, but I'm trying to point out to you that the astrophysicists that have given you this current paradigm openly admit that the geocentric model is actually more viable, meaning it has less unanswerable problems. Did you know that?
I did not know that, and I haven't heard that from anyone.
But when I show it to you in about 2 minutes, I mean, and say that is the case, don't you find that pretty interesting? If that were the case?
Sure. Yeah, that would be interesting. Again, I think it's just which reference frame you use.
No, it's not just which reference frame you use, because if the Earth is in a heliocentric paradigm, we have the problem of dark matter and dark energy. Because in 1933, they found out that the galaxy only has about 1% of the mass, galaxies have about 1% of the mass needed to actually move as fast as they do. And they actually move 10 times too fast. And that's where you get the fact that they're off by the universe accelerating. It needs to accelerate 10 to the 120th power faster. Now, in a geocentric paradigm, you do not have that problem. So the geocentric model is objectively significantly more viable. Isn't that interesting?
So I thought that geocentrism versus heliocentrism was just determining whether the Earth is at the center or the sun is at the center, and it didn't have anything at all to do with dark matter.
Well, you're not. Yeah, you don't get it then.
Right.
See,
I assume that geocentrism would have the same problem with dark matter.
Here's the thing. One thing makes less assumptions to. I don't even know what assumptions geocentrism would make, actually, because I'm sure that whoever mapped out the sky, all they're doing is going off of those angles, and they're like, okay, yeah, here's a system. Now there are other people that are saying, well, these are bodies, this is how far they are, this is where we are in reference to that, and all this and that and the third. And now there might be dark matter because there's something wrong with that particular model. Here's an anomaly. Then you do that, and then, oh my God, here's another anomaly over there. And it's mounting and mounting and mounting when it comes to the heliocentric model. It's just fine if you just keep it geocentric.
Yeah, so dark matter is about distant matter and distant galaxies and stars, and has little to do with the gravity and the position of the sun and the planets and Earth, I think.
And correct again. So the only reason you can say that is because the anomaly or the discrepancy happens on the galactic scale. In your paradigm, our solar system isn't excluded from the galactic scale. It's just a minor portion of. So the problem with dark matter and dark energy still exists where we are in your paradigm because it exists everywhere.
Okay, sure.
96% occupancy is unaccounted for. 96%. Now, this is where you have the cosmological scale and the quantum scale at such odds, because then you have a vacuum on the Earth and we have vacuum energy, right? And if we were to apply what we can prove by measuring the fluctuations in energy inside of a vacuum chamber to space, that's where we get the discrepancy, because we know it's there. So when we apply it to space, assuming the relativistic application of the heliocentric model and quote unquote gravity of that is relativity, that's where they get the number 10 to the 120th power, because the universe would have to be packed full of something that isn't actually there. And it would have to be moving that much faster. It would have to be expanding that much faster. The amount that it's off is insane. It isn't just made up. It's based on what we can prove, which is vacuum energy, 0-point energy. So that's why the quantum and the cosmological scale cannot coexist. But only one's actually tangible, where we're in the real world. This is a philosophical devotion to a mind-numbing level. And dude, the devotion is based on ensuring that our paradigm is that the Earth is insignificant. So ironically, religion was, cast as science, because that's what it is. It's a philosophical devotion. I can quote all kinds of people. I'm about to start dropping the quotes in the chat. And these are the heroes of your paradigm, Matthew.
Oh, I don't have heroes like that.
The heroes of the paradigm. The heroes of your paradigm, not your heroes.
Yeah.
Okay.
Yeah. So this is pretty interesting.
Yeah, I hear what you're saying, that if there's problems way out there in the galaxies, then that model itself would have the same problems here within the solar system or even on the Earth. So it is a paradigm that's not working. But wouldn't you see that as sort of a separate question as to the shape and position of the planets and Earth and that kind of stuff? Or what does that have to do with the shape of the Earth, I guess?
No, because the 500 years ago was when this all started, which is kind of what I wanted to talk to you about. But I guess we'll get to that some point. But the surface level portion of it is, well, there were just good theists out there that were, for maybe a lack of knowledge on a language, had to get their information from whomever was ahead of the church at the time. And at some point, they decided Copernicus makes sense. So they started telling people, hey, we're moving around the sun and all of this. Copernicus, go ahead and whip up that model so we can whip up this calendar and do what we got to do. And the people opposed it. And that's what happened with the whole Protestant Reformation thing. And so the bottom line is, the problem has always been, are we moving or not? Because I thought that we weren't. And I thought that the Bible was true. Now you're telling me all this stuff that the Bible doesn't say when it comes to cosmology. So it definitely is the central point of the problem. Are we moving or not? Who's justified it ever? We know who claimed it. Where did they justify it?
Yeah, do you actually know the history?
Yeah, so 500 years ago, it was that's when people started bringing up the heliocentric model instead of the geocentric model. But even before 500 years ago, the geocentric model was a spherical model. So 1,000 years ago,
that's hearsay, because we see the the coordinate system that we use for the sky for mapping and all of that, we see that as a plane with what appears to be a sphere on the outside. But that's open to anybody's interpretation. That's not anybody saying that's a sphere. I'm sure there are probably people who did, but those claims aren't really tied to much of anything.
Oh yeah, no,
They're just baseless assertions. So what we're talking about is the difference between movement or not. At this point, doesn't even have anything to do with the sphere because no one's validated that either. No point in even talking about it.
Yeah, we're not talking about the sphere. We're talking about motion.
Right.
We're talking about motion. This is what
Okay,
we're
so
talking
motion. You're right. Motion is sort of about 500 years old. 1,000 years ago, there were people who believed that the Earth was a sphere. 1,000 years ago.
No one cares. Okay.
Matthew, you weren't alive 1,000 years ago. Shut up.
But if we're not moving, and I love where you're going with it. I'll be quiet after this. And if it can't be lost on anyone who cares about this conversation and has a faith in the Creator and values all things that are true, it's very clear right now that we're talking about movement versus non-movement. Because if it's non-movement, then nothing that was derived from that the new what do they call that age of information, all of this is built off the premise that we live on a sphere that's moving around the sun, at least for the last 500 years. I don't know what anybody else said before that. So if that's the case, then if we're not moving, if that claim, that initial claim was never substantiated, then the whole thing is wrong. The building upon the origin that you don't believe in, the Big Bang, and what space is, all of that is included. So you can't hold bits and pieces of this belief if we're not moving. Not logically and justifiably, you have to take that up with your authority, whoever that is, whatever God that is.
I would like to just jump in here. Like, Matthew's going to be one of the few Glovers that we can maybe have a decently constructive, honest conversation with that can be informative for the audience. And he is a creationist, right? So I don't want it to get too, like, hostile or anything. I actually think that this may change your life, Matthew.
Thank you.
I'm not being hyperbolic. So do you see, of course, you've seen this quote. I'm going to be dropping a bunch of quotes. I'm sorry, but when I was in here earlier, it was dead silent for hours, so. Okay, this is the quote I'm sure you've heard.
I see the Einstein one.
Right, so I've come to believe that the motion of the Earth cannot be detected by any optical experiment, Albert Einstein. And I'm not saying just everyone that wants to jump in and talk about it, that's cool. Just kind of try to keep it concise and productive. Like, you understand that this quote, well, okay, what's to say to this? What's your take on this quote?
It sounds like he's saying that there isn't a optical experiment that can show motion, and which kind of fits with his idea that you can use any relative frame of reference. So I think it sort of has to do with the frame of reference idea that he's famous for.
So then, do you agree that Einstein's saying that you can't prove the motion of the Earth?
You can't prove the motion of the Earth using any optical experiment. Yeah.
What exactly do you think that means? Optical experiment. What does that mean?
I think they're trying to use something like the speed of light, or the Sagnac effect and those kinds of things is my impression.
Okay, for the audience, Sagnac effect was, of course, discovered by Sagnac, who said that it was a product of the vortex of the ether, right? And this is what ring laser gyros utilize.
Yeah.
The Sagnac effect. Okay. So your understanding is that he's specifically talking about experiments that you utilize light.
Right.
So then Einstein right here is saying that you can't use a ring laser gyro to prove that the Earth is moving.
I think he was saying that you can't prove that the Earth is in motion, like instantaneously. Like if you're moving at some speed, you would experience the same thing as if you were not moving at all, as far as the speed of light. So the speed of light isn't going to help you because of time dilation.
So you agree then that Einstein's saying you can't use a ring laser gyro to detect motion of the Earth?
No, I don't think he would have said that.
But that's what that is, an optical experiment?
He's talking about motion, like something,
Okay.
whether something is moving or not. Ring laser gyro is talking about rotation.
Okay, rotation is a type of motion. So in the heliocentric model, you can't pick and choose rotation or revolution. They're intrinsically tied together. They are not mutually exclusive. If the Earth is rotating, it has to be revolving and vice versa.
So I'm not an expert, but I guess I would have assumed that Einstein was talking about whether you can tell if something is in motion, whereas the ring laser is determining whether there's acceleration, whether something is changing motion. And I think that those would be two separate things, but I get your point.
Acceleration is a type of motion, man.
No, acceleration causes motion. F equals ma. M is different than the.
Hey, if something's accelerating, is it moving?
There might be a point where it's accelerating without moving.
What?
Okay. The top of a parabola. Take physics.
This one single sentence in the Wizard speaking
You're
of
so
me,
lost, man.
this is where I get indignant mildly, where we start using these tactics where we unjustifiably split hairs, making distinctions without differences. Acceleration, rotation, revolution, this is all motion.
Yeah, it's just objective. So, Matthew, would you say that he said this quote 70 years, actually almost 80 years after Foucault's pendulum? So would you agree that Einstein's saying that you can't use Foucault's pendulum to detect motion?
No, Foucault's pendulum is a physical thing happening, not a light experiment.
Okay, so you think that when he says optical experiment, he only means light?
I don't know exactly which experiment he was talking about, but I think he was talking about experiments that are like speed of light and those kinds of, yeah. So he wasn't talking about a swinging pendulum, which is a mass.
Okay, perfect. Okay, so I'm doing this for all the flat earthers so they can learn, okay, how to defeat this argument. So that's right. He gave this speech in context of why he came up with relativity, and he was explaining that what started his journey was Michelson-Morley. And then he explains that he ultimately came to the conclusion that no optical experiment could ever detect the motion of the Earth. Now, here is another quote from Einstein. To the question whether or not the motion of the Earth in space can be made perceptible in terrestrial experiments, we have already remarked that all attempts of this nature led to a negative result. Before the theory of relativity was put forward, it was difficult to become reconciled to this negative result. Now, here he does not say optical experiment. He says terrestrial experiment, meaning any experiment carried out on the Earth.
So you think he was talking about every possible experiment, or what is the context? Was he talking about the Michelson-Morley experiment again?
Now, this is actually from his writings on special and general theory of relativity. Couldn't get a much better source than that. And in the context, he's not talking exclusively about Michelson-Morley. He says Michelson-Morley and all the other experiments that attempted. He specifically says all the experiments. He specifically doesn't just say Michelson-Morley in context of special and general theory of relativity, which you couldn't get a better source from Einstein than what he's famous for, right?
Yeah, that makes sense. Yeah, so he's saying that whether or not you can't detect the actual motion versus being stopped, and that fits with what he was saying. Like you were saying, the relativity, that being stopped is functionally the same as moving, and it's hard to tell the difference.
So okay.
Are you fucking kidding me, dude?
No, it's a relativity. That's just the basic idea of relativity.
No, my laugh
Well,
was
that's
rhetorical.
Mach's
Go ahead, Witz.
That's Mach's principle. Okay, so anyway, you act like Einstein came up with the idea. No. It's called Mach's principle, long before Einstein. Einstein didn't actually come up with anything. But anyway, we'll cover
He
that.
didn't come up with he was not a genius that came up with new equations.
I doubt he was a genius, but
He was a paid shill by NASA, even though they didn't exist.
See, don't spiral on me, Matthew.
No, I was just straw manning for humoristic effect. That's all.
Okay. I think he actually was a figurehead put up because they had to respond to Michelson-Morley, which debunked the claim that the Earth was in motion. So they had to come up with a theory that says, well, it had to make it unfalsifiable and say you could never tell. And Einstein was the guy pushed forward. He was a Zionist. And of course, he provably patched together tons of other people's work. That's just a fact. Henry Poincare did most of what is in relativity. He took the Lorentz transformation from Lorentz. Most of his work was not his own. Okay, so that's the point. Anyway, so I don't want to make this really take too long. So very simply, the Globers have always said, "Oh, it's just optical, you stupid flat earthers, just talking about light," which means they don't understand. They're debunking their claim of ring laser gyros. But in addition, now what flat earthers normally say back is, no, optical means you can see it. So I actually have to correct the flat earthers here. He is talking in context of experiments with light, optical deduction via light, because he's specifically talking about Michelson-Morley. Now, it doesn't mean that he's not just saying just Michelson-Morley, he's saying any optical experiment. So anything with light cannot prove the motion of the Earth. The flat earthers should critique their approach. Now, I've found another quote from Einstein that goes in further detail and says terrestrial experiment. This is the main one that flat earthers should actually use because it says anything on the Earth. Okay, so whenever you invoke the ring laser gyro invented in 1976, you say, oh, well, that happened long after Einstein. He didn't know about it, so he wouldn't have said this quote then. That's one of the best that the Globers come up with. We'll address that in a second. We'll put that on the back burner. So you bring up Foucault's pendulum, 1851. This is 80 years after that. That means you think Einstein was wrong if you think Foucault's pendulum proves that the Earth is moving, okay? And the mechanical gyro was invented in 1909. So that was, again, 20 years before this quote. So he did not think either the mechanical gyro or the Foucault's pendulum would prove that the Earth is moving. And he understood this because of Mach's principle, and it could very easily be movement around the Earth. And if you're inside of a system that has motion on the outside, you would actually have motion trickle down to the interior aspect of, let's say, a hollowed celestial sphere for intents and purposes, and you can replicate it. He wrote about all this, which is why it's so funny. It's just that the globe earth proponents do not know any of the history, but to be fair, a lot of the flat earthers don't as well. And that's why I'm going to stake my flag on this. It ruins the whole paradigm. Okay, so now that we've got that covered, that's just all objective. Okay, so do you have any rebuttal that you would like to say, or you want to move on?
No, I see what you're saying. That it's hard to prove any type of motion using any optical experiment, using any optical devices, or even using swinging pendulums. I think none of those prove that there's motion happening.
Electric, you are hot miking. Electric is hot miking.
The Earth is. 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 The Earth is the flat. The Earth is. 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 The Earth is the flat. The Earth is. 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 The Earth is the flat.
Did you know that the Earth is flat? There's no curvature, it's not spinning, and space is fake. Do they have any evidence? They do.
I'm a flat earther, flat earther, flat earther, flat earther, flat earther, flat earther. I'm a flat earther, flat earther, flat earther, flat earther, flat earther, flat earther. I'm a flat earther, flat earther, flat earther, flat earther, flat earther, flat earther, flat earther. I'm a flat earther, flat earther, flat earther, flat earther, flat earther, flat earther. Hey, my name is Tristan, and I'm in second grade, and I asked my teacher to show me an experiment where water curves. She couldn't do it because it doesn't curve. The water always finds its water. Always finds its water. Always finds its water.
What'd your teacher do?
She just didn't talk to me anymore. All she did was walk away. And I was like, what is this about? What?
That's okay though. For being so young, you're very, very smart. That's fantastic.
Yeah.
So keep up the good work, man, and stay flat, okay?
Okay, I'm a flat earther. She couldn't do it, do it, do it, do it, do it, do it. I'm a flat earther, flat earther, flat earther, flat earther, flat earther, flat earther. I'm a flat earther, flat earther, flat earther, flat earther, flat earther, flat earther. I'm a flat earther, flat earther, flat earther, flat earther, flat earther, flat earther. I'm a flat earther, flat earther, flat earther, flat earther, flat earther. Hey, my name is Tristan, and I'm in second grade, and I asked my teacher to show me an experiment where water curves. She couldn't do it because it doesn't curve. The water always finds its water. Always finds its water. Always finds its water.
What'd your teacher do?
She just didn't talk to me anymore. All she did was walk away. And I was like, what is this about? What?
That's okay though. For being so young, you're very, very smart. That's fantastic.
Yeah.
So keep up the good work, man, and stay flat, okay?
Okay, I'm a flat earther. couldn't do it.
Rip this up for sound bites. This is awesome.
It's like it never even happened.
Yo, if my mom was a dog, I'd be a son of a bitch. David Hogg is a gog, he's a son of a dick. He's a son of perdition. Yo. Hi, my name is Flatted Saints. I came here to shout out the vacuum of SpaceX. Don't wanna chat about Roe versus Wade. Let's talk about latex. It's not about safe sex. They don't care about babies, they keep making playtex. Fascinating about getting jabbed in the matrix. Grab the handle and stab them straight in the chest. Eat the banana and I'll handle the rest. Getting high, flying in my room, land on the bed. Then I nailed this chick while she hammered my head. In my red pajamas, looking like an animal bled all over my pajamas. That's what my grandma said. They say hoaxes are red and psyops are blue. Two arms of the same body higher than you. On the wings of eagles that are flying askew. You've been compliant to them, they've been relying on you to build underground tunnels and supply you the tools. Then burn down the factory, supplying the food. I hit my notes with a quota in rhymes I spit. Sipping on Corona Light with 19 chicks. You know what Kobe looks like? I can't find the shit. The more you open your eyes, the more they blind you with weaponized technology and wireless. MTV's got the all-seeing eye in it. Outside the studio and inside of it. Thinking outside the box, you ought to try that shit. Riddle me this, yo, and riddle me that. I took a piss and a crap and I wiggle my ass. You giggle and laugh over my mental collapse. I'm disingenuous over this digital gap. You're so insensitive, bitch, you need to freaking relax. Sometimes it makes no sense what I spit in my raps. If I went back to flipping bricks, then I'd get me some cash. Feeling broken so bad, I'm smoking my last cigarette. Now a new pack, I'm hoping for that. You can't die from smoking weed, overdosing on grass. To understand the future, I'm exposing the past. The last shall be first and the first will go last. Got so much intel, my brain's bursting with facts. Feeling worthless, in fact, I'm hurting so bad. I pulled back the curtain to find a circus of backs. Crisis actors fighting back their intuition to last. Sons of perdition, a bunch of subliminal rats. Agendas getting laws against criminals passed. You wanna hold me, but only when I'm lonely. In fact, I'm comatose. How long you suppose a coma will last? I'm overdosing on somas from a felonious past. When I awoke, I was told the earth could only be flat. I'm exposing SpaceX and phony spaceships, going on a blind date with the gay chick. Once I set her straight, she never complained, screaming my name as she came to her apex. Or would it be climax? I'm so good at these rhymes that I stopped the hands of time as we stood in a time lapse. My rhymes became divine if you're drinking the wine fast. The half-baked rhymes I happen to make. Who's the boss of Charles in charge? Give me a break. Full house of silver spoons. Yo, Ricky was great. No small wonder I could never take Vicky on date. Jiminy Snickets, Lemony Crickets, and Winnie the the snake. It's a miracle how I make lyrics pop. Off the page with rage, make these lyrics talk. It's serious art form, you got it or not. You ain't a hot tamale? Your tostada gets dropped in Ensenada. That's where tamales get chopped. Rigor mortis sets in, and you hard as a rock. Where in the world did the globe come from? Maybe China. My girl's got a globe for a lazy eyebrow. It's crazy, baby, maybe shave your vagina. Maybe you're right, I'm always late, cause I'm a... Wait, I forgot what I was saying. I'm higher than a firefly flying by in the night sky. Y'all can't catch me, I'm just a pitcher in the ride. They call me Jack Flat, Nasty Kerouac, Latrino, eating flapjacks back of a shack in Reno. David Hogg made the blog go down in Chino. I just had a heart attack, man. What the hell are you talking about? Dude. Oh my god. I don't even know what I'm saying sometimes. That's crazy. Like, how do I even think of these things? It doesn't make sense. Love it. Make sense. Just weird. Alright. Cut. Space is fate.